No. No, we have no good sides.
Okay.
Andre at the end. Okay.
So you're
Cool,
not.
Yeah.
Swivel chair. Yeah.
Okay.
No, you sit in the center. Yeah, that's right.
Oh my goodness.
All right.
Hello.
We're here. Good
Echo.
morning, Render. I hope everyone has had, yeah.
I like your, you got the DJ voice going on.
It's good. It's good.
Thank you for joining us, kicking off the day 2 of Render. My name is Andre Saballo. I'm a software engineering manager at DraftKings. In my time with the organization, I've had the opportunity to lead multiple teams across our payments and account management platforms, which means I've had the opportunity to be on the front lines throughout our AI transformation at our organization and see how our engineering teams are using these AI systems to build real products in real time. Today I'm joined by 2 of our industry leaders at DraftKings, Zach Mayberry, Chief Technology Officer, and thank you. And Brian Walker, our Senior Vice President of AI and Operations. Round of applause, round of applause.
I don't know how we can follow that.
Yeah.
That's pretty good. I was just going to say that I have the privilege of leading the best gaming company on the planet. So, clap, clap.
Yeah.
There you go. I'll cue you guys in with, so hey, you know, I know both of you have been to Render in the past. This is not your first time at Render, but for those in the audience who it may be your first time, let's take a moment to do some brief introductions. Zach, I'll kick it off to you.
Awesome.
Yeah.
And then,
Something along the lines of like how long both of them have been here.
Okay.
I think like that's cool because Zach's approaching his 10 years.
Wow.
Ryan is 6.
seven.
Okay.
Like,
Yeah,
I
so
feel like that's a good.
yeah, we can even do that, right? So you don't have to keep that.
Yeah.
Yeah.
We'll kind of talk
Okay.
about that. Yeah. And then the flow of questions, we'll do intros first, and then you've got your.
Yep. Intros, and then we'll start with sort of a reflection, so where we came from. So I'll kick it off to Zach. I'll say, hey Zach, so let's take a look back. Tell us a little bit about. Oops, sorry. Make sure I get the words right. Take us back to the early days. What did AI look like at DraftKings 1 to 2 years ago? What shifted along the way, and where are we now that we have these more robust systems running in production and producing real business results?
Yeah, so AI isn't new for DraftKings. We've actually been working with AI, machine learning, and advanced data science since the start of our company. So we're over 12 years into our AI and data science journey. But when it comes to generative AI, this is where we've really been focused the last 18 to 24 months, starting with experimentation, learning, and now really productionalizing many tools, processes, and improvements that are helping our team move faster than ever. Yada, yada, yada.
Yeah. Very good, very good.
How does that sound? Good? Yeah, great.
One question for you, by the way. I assume, do we need to project a lot? Like when the room is full of people, like this feels comfortable.
Yeah.
But I don't know if it amplifies enough with a room full of people towards the back.
Let me see how it sounds like that.
Yeah. I assume you guys will adjust, right?
Our audio team will definitely adjust it.
Okay, so we can just talk kind of normally. Yeah.
Naturally.
Cool.
Okay.
That's great.
All right. No, it's good to know because I could probably, I have a habit of projecting too much sometimes.
No, they'll fill the room for us.
Okay.
I mean, as long as you're not whispering, though.
Yeah, no.
Yeah.
Just talking normal.
Yep.
Okay.
Okay, great.
Okay.
Perfect.
All right.
Cool.
I feel good.
Yeah, sounds good to me.
Do a little TED Talk here.
I think the other
I would pick GitHub.
Good morning, everybody. Good morning. Did you all have fun last night? Did you sleep last night? No, that's okay. That's okay. Good morning. Welcome to RenderATL Day 2. I don't want to take up too much of the welcome time because we have a very special guest doing that. Please welcome President of Atlanta Tech Week, Avalon Bingham.
RenderATL, how we feeling? Wait a minute, I didn't hear anybody from this side like say anything. So let's do it on this side. RenderATL, how we feeling? I know that y'all probably were out last night. That's why y'all so quiet. So it's all good. It's all good. Well, welcome to day 2 of RenderATL. This is also day 5 of Atlanta Tech Week. So make some noise for Atlanta Tech Week as well. So I want to see by a show of hands, how many of you all have been at our Atlanta Tech Week events around Metro Atlanta this week? By show of hands. Okay, all right. I've probably seen y'all a few different places around Atlanta, but we're super excited. Again, this is day 2 of RenderATL, day 5 of Atlanta Tech Week. So much fantastic programming that we've had, not only here in this building, but across Metro Atlanta. When we think about what's happening from an Atlanta Tech Week perspective, it really is the opportunity to showcase why Atlanta is the best place for builders. And we do that through a combination of events, combination of activations with key local partners, but also with our startup ecosystem. So founders, investors, builders, innovators. What does that next future look like for the city of Atlanta? And how do we lean in? How do we support? How do we showcase what's happening? So we came into this year for 2026 with really bold and ambitious plans. How could we move the city forward? For a bit of context, this is actually our 4th year of Atlanta Tech Week. A big part of that has been the success of RenderATL, which has allowed us to expand what we do from an Atlanta Tech Week perspective. And this is my 3rd year as president. And so we've gone through really the typical stages of growth that you see with most startups. A lot of learnings, a lot of iterating very fast, but trying to create the best product for not only our users, which are attendees like yourselves, but also with our partners who help support us in many different ways. And so as we've already now in day 5, tomorrow is the last day of Tech Week. By the end of the day tomorrow, we'll have had over 250 events across Metro Atlanta, which will be a record for Atlanta Tech Week. So make some noise for that. And we will have done that over 60 plus square miles across Metro Atlanta, places as far north as Peachtree Corners, to South Downtown, not too far from here, Midtown, tomorrow, Buckhead, really all over Metro Atlanta. We've seen community partners hosting events all over the city as well. And so as we think about the future of Atlanta Tech Week, we think about how to continue to expand, how to continue to empower the builders, how to continue to empower our community partners to host events to showcase why this is such a fantastic city to build in. What I want to also really highlight is some of the things we've seen throughout the week. So as we've gone from startup brunches, in Peachtree Corners at Atlanta Tech Park, whether we've also seen, community activations that have really helped to show terrific engagement. We've also been able to see really fantastic kind of personal stories that people have shared. We've had pitch contests with people who've overcome tremendous obstacles to showcase what they're building. We've had legends, people like Ambassador Andrew Young, Billy Aaron, the widow of the late, great Hank Aaron, be able to sit down, have conversations about their legacy, how technology is impacting and evolving their legacy for new generations to hear about their stories. And we've also heard from a really unique array of thought leaders from the Atlanta ecosystem. So I encourage everybody, if you have not come to our Silicon South activation, which is actually right upstairs on the 3rd floor, to hear about what's happening in our city. So technology really, from our perspective, is the throughput that connects and kind of binds all of us together, but there's still tremendous stories that are happening, and a lot of those that will be shared today. What's happening in the future of places like South Downtown, as I mentioned. So we'll have the CEO of South Downtown, John Birdsong, will be joining us upstairs later this afternoon. What does the future for technologists look like in the American South? So we'll have Remington Rollet, our Director of Silicon South Foundation, who will be talking about the next iteration of what happens with RenderATL, and so many more. We also have other workshops, so for everyone here who's looking to continue to elevate their skills and elevate their understanding and opportunities, we have our Build ATL activation happening inside of Silicon South, and that kicks off here shortly after 11 o'clock. So tremendous programming that's happening. Of course, if you haven't been, our AI Expo is also upstairs on the 3rd floor. For those of you all who are also maybe working in legal, who are wanting to understand maybe better the intersection of technology and IP and in the legal field, we have our Legal and Tech Summit that's happening at Hotel Indigo. So a lot of fantastic programming. I also want to give a big shout out to our partners with Node.js, who are also on the 3rd floor right next to us with the Silicon South Summit. So one other just quick housekeeping note, when in doubt, please check out our RenderATL app. It's how you can earn rewards, earn points. You can see what's happening, where it's happening throughout the day. And also for those of you who will still be in town tomorrow, please come check it out. You'll see what we're doing in Midtown. So again, not too far from here in Tech Square, we have a tremendous lineup of events. One of our partners, Georgia Tech, is hosting a tech hop. So we'll be shutting down 5th Street and West Peachtree for vendor booths, for activations, food, fun, a lot of great things to help us close out the week. So with that, I am going to exit the stage, but I'm super excited about everybody being here. Thank you all for being a part of it, making Render a part of your experience. It's been a fantastic week. We still got today to go. We still got tomorrow to go for an Atlanta Tech Week perspective. But thank you all for being here, and we'll see you guys on the floor.
All right, good morning, Render 2026. I hope you all have had an amazing time so far. Thanks for joining us as we kick off day 2. My name is Andre Saballo. I'm a software engineering manager at DraftKings. Throughout my time here at DraftKings, I've had the opportunity to lead front-end teams across our payments and account management platforms, which means that the work that myself and my teams do are, we've been able to really be at the front lines of AI transformation at our organization and see how the decisions that are made directly impact the products that we build in real time. I'm joined here today with 2 industry leaders, Zach Mayberry, Chief Technology Officer, and Brian Walker, Senior Vice President for AI and Operations at DraftKings. Give them a round of applause, please. Thank you both for being here today. I know this isn't either of your first time here at Render, but for those of you who this may be your first time at Render and haven't had the opportunity to meet either of these gentlemen, please let's take a moment to tell them a little bit about yourselves and your roles at DraftKings.
Awesome, yeah, I'll kick us off. First, just want to say, thanks to the Render community here, all of you for showing up, and all of the folks that put on such a great conference here. This is my second time. Each time here, I think, has been pretty amazing. It's also been amazing to see how much better this conference gets every year. So, really honored to kick the day off here. A great day too. As Andre said, my name is Zach Mayberry. I'm our Chief Technology Officer. I've been at DraftKings for almost 10 years. I got one more month, and I'll have been there for 10 years in a ton of different roles. Essentially, every one of our teams, other than our global data team, I've worked on. So SRE, the payments and account space, daily fantasy sports, online sportsbook and casino, our lottery business, pretty much everything. And I think what's been amazing for me in my journey is the culture that we have built, the awesome products that we have, best in the world, the best team, in my opinion, in the world, and the great opportunities that not only myself but many others have had to grow their careers there. So really excited to be here, and thanks for having us.
Awesome. I'll echo Zach's point. Really happy to be here at Render. Love the conference. Super pragmatic and practical. I think that's one of the highest compliments I can pay. I've been to a lot of conferences, and Render is at the top of the list. My name is Brian Walker. I've been with DraftKings now 7 years. I've had a couple of roles at DK, but my current focus is leading the AI transformation for the company in addition to operational roles. So it's a very unique position where, because there's an operational element to it, I get the good fortune of working with the entire leadership team across the company. And then AI obviously is a key transformation component of that as we continue to constantly focus on how we improve our operations, improve how we support and deliver value to our customers and to the business. AI is a transformational engine to help support that. So we'll talk about some of those examples as we go through the conversation, but having a lot of fun. It's my selfish opinion, one of the best roles in the company.
Awesome, that's awesome. So, okay, Zach, take us back to the early days. What did AI at DraftKings look like 1 to 2 years ago, and how's it kind of shifted along the way?
Yeah, so I'm actually going to take us even back further than a couple of years. For us at DraftKings, AI isn't something new. We've been working with data science, machine learning, and AI really since the start of the company. A lot of the products that we build wouldn't work well at scale without advanced AI and data science solutions. So AI isn't new for us. I think what has really been new in the last 18 to 24 months has been the generative part of AI. And that's where there's a lot of really exciting stuff to talk about. You know, I'll share mostly on the engineering side. I know Brian has a lot to share coming from the broader company context. But really, every single part of the software development lifecycle, we have started with experiments, we have figured out what has worked, and then we've rapidly figured out how to distribute those experiments in more scalable ways to the rest of the team. So everything from assisted or agentic coding, automated code reviews, QA engineers building test automation harnesses and frameworks, product managers vibe coding POCs that help us get to a solution faster, designers using design systems with agentic capabilities to be more consistent and develop faster. Really, every part of the software development lifecycle, or even the product development lifecycle, we've seen already transformed. And the great part, I think, about the culture that we've driven is there's no limits or there's no caps. We really push everyone to use different technologies, as many technologies as possible, and learn and experiment. When we see really strong utilization, that's a great indicator for us to dive in and understand, like, what is this person doing? Because it's probably really interesting. Some of the most interesting things I have found have been where the token use has been maximized or the spend has been highest, and that hasn't been an indicator to slow down. It's actually been an indicator to really dive in and understand this must be valuable because smart people are doing smart things. What are we doing here, and how can we get more people doing it? And that's really where we've seen the business accelerate.
Mm-hmm. Very good, and I'm sure much of that may resonate with several of the attendees here today at their organizations. I'm sure we've all had to move fast or make decisions on high-value priorities for the organization, and being able to take that opportunity for experimentation and pivot where needed. I think that's something that resonates with each of us. Brian. Across DraftKings, AI experimentation has been happening in a lot of different corners. Where do we go from whether it's isolated use cases to really having this run operationally at scale?
Great question. The challenge with a lot of big organizations, certainly even small ones, I would argue, is that how do you make that transition from kind of experimentation at scale into more focused implementations and delivery that add value? The one kind of formula that I found works is be intentional and understand what your core culture is first. Understand what works within your culture. Like, look at the big projects that have been successful and what are the cultural elements that have yielded that success, and lean into that for your AI transformation. So as a practical example, the playbook for us to get the great accomplishments we've achieved at DraftKings, really at the core are two things. Number one is we have very clear business goals. And number two, we have single-threaded dedicated teams that focus on achieving those business outcomes. So we've essentially, when we kind of flipped and started to really scale this, I'd say 12, 16 months ago, was that pivot to this centralized team, single-threaded focus on scaling AI across the organization, and have very clear business goals around that. So that is really the key for us, is this kind of having a centralized team that can drive across different functional units and then have decentralized ownership and accountability. That has really been the secret for us to really get this thing to run at scale ultimately. The second piece is, as the teams have experimented, Zach shared some wonderful examples of getting teams to actually use it, take action, don't just sit there and overthink and over-design, particularly with the nature of the tools, because they're changing so quickly. You have to get in there, whether you're individual or a team for a small, medium, or large project. You have to jump in and start doing things, start building. So the focus there on actually doing it in a very focused way, and we'll come back to this topic a little later, of like how do you do that at the small, medium, large scale. There's different approaches you have to be conscious of. Pick your lanes of where you're going to focus on, and again, we'll touch on those examples later. But those are the real secret sauce for us that have made us successful in scaling AI in a very rapid, dynamic way, but also under the kind of reality of tools literally changing every 2 to 3 months, right? So it's a constant challenge. So you have to kind of get your teams to organize, but having goals, single-threaded teams, focusing on these outcomes is the step one of that process.
Yeah, and I think just to add on to that, you can't understate the importance of the experimentation part. And like you mentioned, Brian, sometimes it's better to get started and figure it out than it is to kind of overthink it or wait. And so obviously where it's clear that there's value, where things are intrinsically good, or we know we have a necessity and that's going to breed great invention, of course, prioritize those things to the top. But sometimes it's not so clear, this may be valuable, but how valuable? Or if we can solve this, it'll be valuable, but we may not be able to solve it. Those are probably not good reasons not to try something. And I think more often than not, the mistake I see is self-selecting out of the opportunity to innovate. It's a bigger problem than trying and failing. That's better every time.
The other one I would put, sorry to riff on this, Zach's team in the company has been, in my opinion, the leader in the organization. They're seeing the biggest impact. It's just tremendous. I'm blown away by how the team has done that. I was talking to somebody at breakfast this morning about this concept of compound interest, right? We all understand compound interest from a financial point of view. You understand compound interest from your career, learning AI skills now. We're going to pay dividends down the road. Same thing happens to what Zach just talked about with his team. What I've observed with their team is they're getting in there, being aggressive, doing those experiments, learning, and that ability for an individual and teams to learn rapidly and iterate and continue to evolve. That's a compound interest piece that pays off dividends now, literally 12 months later. And the cycle of AI is, because it's changing so quickly, you have to move with urgency, not panic. You have to move with urgency. You can't sit around and say, it's changing too much, we're going to sit around and wait on the sidelines until it matures. You're going to be left so far behind if you don't move now. And Zach's team is a wonderful example of how aggressive they were out of the gate, learning, iterating, improving. Like, they're miles ahead of what others are doing.
Oh, very good. And as teams continue to move with urgency through experimentation, Brian, I'll pick on you here. How do you decide what adds value versus what adds more complexity?
The area that's worked well is, again, I'm riff on Zach's piece of, like, there's an individual component of using the tools and just actively doing things that help improve cycle time and output is kind of the zone to start with. That certainly applies at an individual and a team level. At the larger picture, when you start to get more momentum there, it opens up the door for, like, hey, we need to actually pause at a functional level, at a team level, and think about how we get work done. this is a good practice regardless of AI, right? Every team, in my opinion, just like a football team or a baseball team, they go, or an F1 racing team is a great example. They go, they perform, they sit back and look, how did we do? What can we change? Let's go back and look at film. Same approach here in running a business. So the AI piece really helps that process a lot. It forces you almost in many ways to say, we have this amazing abundance, this amazing capability that's within reach that we can really transform the organization. Let's stop for a hot second and think about how we get work done. Big picture, step back, understand what are your core flows, what are the most friction points, and then from there, map to what is the native capability of AI? It's really good at content generation. It's really good at solving super complex problems that involve massive data sets, for example. It's really good at agentic workflow things that can automate toil out of the process, those types of things. So starting at the high level, stopping for a beat, understand how work gets done, and then use that as your entry point to iterate and brainstorm is really the right starting point there, whether it's an individual team of 5 or an organization of 500.
It's good to have a framework too for even something like value. So at the beginning, and this framework evolves over time. So at the beginning, we really just cared about adoption. Are people using the tools? How many tools? Maybe even how many tokens? But as you see out in the industry, if you just focus on that, any measure will be gamed. Sometimes in positive ways, sometimes in negative ways. And so I think over time, as adoption gets better, you actually have to start to change what your value equation looks like. We start to focus more on efficiency or throughput or efficacy. So where we could measure the business value outcome, we'd use that. Where it was about time saved, we'd use that. Where it was about avoiding tasks, we'd use that. Even that, though, isn't enough because you could be doing things faster, but if your quality goes down, it may not be ultimately worth it. And so where we're at now, we've introduced really a much more holistic adoption, efficiency or efficacy or value, and kind of quality just quality, I guess is the simplest way to put it. But it's measured in different ways depending on what you're talking about. And so I think being able to evolve your value equation as you go is important too, because what you value changes over time.
Yeah. And it's interesting what you said about the measuring the quality and through experimentation and taking a step back. Zach, where would you say AI is genuinely delivered at our organization? And what are some areas where it may have actually surprised you?
Yeah, I mean, I feel like I'm living in like Daft Punk, Kanye, stronger, better, faster, harder world these days. I think everything has improved. It's honestly been inspiring and amazing to see. I think like the biggest thing I'm worried about is how long can we keep this cognitive load going, because it's clearly higher. Yeah. But I continue to be amazed at even with that, how people continue to respond. But as I mentioned, I shared at our investor day, 100% of our code reviews are AI assisted. Some of these are even getting to the point where AI provides the first approval. In other cases, it's just sort of assistance to make the code review process less onerous. Same thing on the development side. I see anything from 30% to sometimes double the capacity improvement in teams compared that are using AI compared to teams that are not using AI. And then I just think in general, when you look across our roadmap, our fight to become #1 in our category, now the release of our predictions product and rapidly closing the gap there to be #1 there too. These are things that I don't think would be possible. The mission that I put forth at our investor day back in February with our chief product officer, I think in the past that would have taken us 18 months to do. And we're sitting here at the doorstep 4 to 6 months later, knocking down the door of the competition, which is just not, I just definitively don't think would have been possible without these improvements to how we work and how we get things done.
The other piece that's surprising to me is, to completely echo Zach's point, right? The ability to leverage AI to move faster, increase output. Like, you see the surprising little signals. So for example, in some of Zach's product development teams, I've heard stories of like, hey, we're able to either reliably hit deadlines or actually pull them in. Even in the last minute when there's changes, pivots that have to happen, normally those would have pushed release dates out. Now they don't because they've got AI tools and they can rapidly support those dynamic changes. The other example, I'm stealing from Zach again, the interesting pattern we've seen now around, I'll call it localized either individual or team-based tools with the vibe coding capability is many times, particularly for leadership, I call them disposable Lego bits. Like if there's a solution that Zach needs a problem and he can't get the custom view that he needs out of an existing tool that we have in the system, he can vibe code up an application that'll get him exactly what he needs in minutes or hours. And it adds tremendous value that normally would have taken a couple of weeks of somebody in the department to go build this custom view for him. So it allows him to get a solution for what he needs, make a faster decision, make a higher quality decision, and it's not something that needs to be maintained over time. He can throw it away, and if I need that thing in 3 more months, I'll rebuild it in half the time, and the tool's already advanced so much further, I can get it done much more quickly. So I think there is this interesting space that's starting to happen, these patterns that start to happen, where because of the power of the tools, you can build what you need in the moment to make the right decision quickly, and then it's not like this legacy piece of code you got to maintain, just throw it in the trash bin and then rebuild it later when you need it. So like those interesting micro patterns that are starting to show up there that I find quite fascinating.
It's really changing, I think, like what we prioritize and what we build and when. This sort of compaction of this cost, quality, time, thing you'd read in any management book or any leadership book or any software development book. It's like this time factor is just kind of getting disrupted. And it's not without cost, but even there, like cost will fluctuate over time. If something becomes really expensive, the market usually responds with other options because people want to get in on the gold rush. So like, I think what we knew that was kind of stable about when we would build something, we'd spend a lot of time up front. We still do, we're still very thoughtful, but it looks different. We'd spend a lot of time up front getting right the architecture, the application structure, the functional requirements, the non-functional requirements, the designs, every aspect of what we wanted to build. The consequences of getting it wrong later and having to go back and rework were so high that we built these, even if it didn't look like waterfall, we built these processes that were big and slow but error-proof, I guess. Now that you can build things so much faster, it really forces you to reimagine. Not that those things are still not important. Of course they are. Having the best architecture is the only reason why we stay up when the lights are brightest. So everything is still important, but how you attack that problem needs to fundamentally change because the inputs are just not the same. The time it takes to build is just not the same as it was. And if you're not rethinking how you're attacking the problem when the parameters change, you're not going to be as efficient as you could be or as successful as you could be.
Thank you both, and I think that may resonate with the room, especially for the engineers out here that are building production systems. How would you say AI has probably changed the way teams think about architecture, code review, velocity, and really just that builder mindset that you kind of referenced earlier?
I think the thing for me that changes, and as an engineer, or for the engineers in the room, I think we need to be more open-minded than ever. Everyone's a builder. And maybe in the past, if I said that, that would sound nightmarish, very dangerous, scary. And not that there still aren't sharp rocks out there, but with the capabilities that are now available, that we have at our hands, we can make a sufficient solution earlier in the chain. And I think that's really interesting. If there's, let me give you an example that is very close to being actualized at DraftKings. So a ticket comes into a customer support agent, and it's about poor accessibility on a button, unreadable text, or something of that nature. Simple to fix, but really frustrating and annoying for the customer. In the past, enter the workflow behemoth. That gets turned into a ticket that needs to get routed to the right team. A product manager has to prioritize it, has to determine like when the work is going to be scheduled. It has to enter into a sprint. The dev team has to point it, even if it's a half of a pointer or whatever. All of this stuff still needs to happen, and it takes forever to ultimately fix that problem for the customer. Now, with agentic systems that can feed into each other, we're right on the doorstep of low complexity, low risk, but high value work being able to flow right through the system, including all the way out to production to the end customer. And so the notion that a CX agent could be so empowered to fix a customer issue in the moment and within minutes, that could be reflected on the site and doing good rather than causing harm, this is like mind-blowing compared to the legacy way of working. Now that won't work for everything. So like you asked about architecture, all of our best practices, brain surgeries will be brain surgeries. Like there are incredibly hard problems that even with AI assistance are going to need exceptionally talented, bright, and innovative people to solve. But the things that take our attention and focus away from doing those things, those are the things that can just flow. And to me, I think that's what's so exciting. It's going to be really important is building the knowledge bases around these things so that we can trust and have faith that these systems can act in good faith and act like we would, even if the problem is simple and low risk and non-complex. So. But I think these are some of the things that are super exciting about where technology is going.
Yeah, the other interesting, I love to try to bring it back to real world examples and not talk about it in an ethereal sense. I bumped into just last week one of the product managers in our sportsbook product, and this guy was off the charts excited. Like the passion and energy of him telling me this narrative. Liz, I want to talk to you about using this story internally. Couple things. He went through this scenario of like, let me tell you what happened yesterday. I was on a call. I was working with my design and engineering partner. We were using this vibe coding tool to do various prototypes of something that they were going to build. And he had been partnering with his engineering lead to actually take the outcome of the various prototypes they wanted and pull that into their SDLC system, so it would automatically take the prototype, create the spec, JIRA tickets. The Claude system would actually code the low complexity stuff. Like that flow would happen in literally like hours. While he's doing this, he's getting questions from some of his business partners and his boss, and he's able to go in and give him the answer to specific questions, again, with his vibe coding platform plugged into our core database that tells him market data of what's going on with the particular product, what are the conversion rates. He said, normally, if I would have to get him an answer, I'd have to get a ticket into the analytics group, and that would have taken 2 days for them to go pull the data and get it. He said, no, I got it live to my manager in the moment. We were able to make a pivot decision. He said, normally that cycle, no joke, 6 months ago, would have probably taken 2 weeks. We literally got it done in 2 hours. Like it's that at scale is bananas. Like that, literally that capability didn't exist 6 months ago, the capability to do it. So my point is, that didn't happen overnight. That's where the compound interest thing is. We're moving fast, building these things brick by brick is a really concrete example of how that is playing out in real time. And this is happening in other functions as well. It's happening in marketing, it's happening in operations, it's happening in the HR team. Like there's countless examples of this kind of stuff happening at scale. So.
Yeah, the biggest mind shift is AI is not an engineering problem.
That's right.
Right? Like many things, I feel pre the last 18 months, the paradigm was there's some business problem, engineering/product solves it and hands that back to the business and then supports it over time. really the empowerment is bi-directional. Everyone can move faster. Everyone is a builder. And that's, I think, the piece that has really fundamentally changed the calculus here.
Completely agree.
And I think with that empowerment also comes just general excitement. And it's good to see across both engineering teams and non-engineers as well. I'll use an example. One of our delivery managers on the payments platform, total rock star. From our first meetings doing sprint planning or capacity planning, you know, he would have his working sheet, he would call it, similar to an Excel document that we would go through. Recently, he basically vibe coded a mini CRUD application that, you know, is deployed internally for our dev tools, and everyone's able to share that and make those updates in real time, which is cool to see. I see product managers who have always, you know, had a great ability to write those product requirement documents and share them with engineering teams, but now they are utilizing our AI tools to write complete requirements and specifications, and we all know how important that is to get it right the first time on the engineering side, and so we're not having that back and forth. So it's exciting to see.
It's a really good point that you're making there. Sometimes we don't do more, we can do what we do better. And on the product side, that could mean that in the past, maybe we just barely had enough time to cover the functional requirements. We didn't think a lot about some of the non-functional requirements, and now we can be more thorough or complete. Important to not lose sight of that.
Yeah, very good. So Zach, one of the hardest parts of AI transformation is measuring whether it's actually working. How do you think measuring impact, whether that's speed, effort, quality, business outcomes, or early adoption? What would you say is probably, for us at least, the most standalone important metrics?
I think for me, I index heavily on the quality side. And I sort of take, not that you ever want to take anything for granted, but maybe I take a bit as expected that we will figure out how to do everything that we need to get done when it needs to get done by. And it's not actually easy to do. You don't always have time for everything that you want to do, but I think smart people who are motivated by a great mission, when there's strong competition out there that you want to put out of business, those are great motivators to figure out how to get it all done. The thing that I like to really focus on is that, well, getting it all done is great, but if it's not at the quality that it needs to be, we're not going to be delivering for the customer in the way we need to, and that ultimately means it won't matter how much we get done, right? If we just get more done, it's not going to matter if it doesn't resonate. So I think that's one that I focus a lot on. Kind of laddering down from there, efficiency is one that I look at. So less about the absolute or aggregate value delivered and more about the time that we spent multiplied by the investment that it took. Do we like that ratio? So spending more on tokens or spending more in the cloud isn't necessarily bad if the business grows exponentially as a result of it. That's a great thing. I can tell you definitively, my CFO will write more checks if we're growing the business faster than the checks. Any CFO would. So, you know, it's my job as Chief Technology Officer to really put the pedal to the metal when it comes to our innovation and not let the other things sort of hold us back. So starting with delivering well for the customer with quality, working next to kind of efficient, innovative delivery, and then kind of from there experimenting with new things to make sure that we continue to be ahead of the curve.
Yeah, I would agree. There's always focus on the cost side of the equation. Many people get into that mode, particularly when you talk to some folks in the finance organization, for example. No offense. That is a natural piece, and for sure the kind of cycle time improvement is important. But I think the companies that are going to win and the teams that are going to win long term are those that focus on leveraging AI to really produce more high quality output. Like that is the power in the system, and we've seen it, right? As our ability, Zach referenced this before, we're in a hyper competitive market. There's huge expansion right now in the prediction space that we're going after. The opportunity that that provides of leveraging AI in this moment in time is really one of the most unique opportunities ever, quite frankly. So I think focusing on the ability to kind of move forward faster, produce more output on the top line is really the long-term place to focus on. Yes, you can get some efficiency along the way, but that's not, I think, the primary one. The other piece that, and this is where I get frustrated sometimes listening to kind of external media, and that question comes up of like, you listen to the Wall Street people or whatever, like, when is this bubble gonna burst? And all the perma bears are kind of crying in their soup. The internal question sometimes I ask people, like when I get that question sometimes internally, I say, all right, here's an experiment I'd propose to you. In 2 hours, I'll send out an email saying all AI tools are shut off in 2 hours. And then I'm gonna say, if you have any problems with it, go talk to this person. How do you feel about that, right? It's like those stories of the product manager that I told, like people, if you got these tools ripped away from you tomorrow, people would scream. They would scream about it, right? So I think there's this difficult part to measure. To your earlier question, Andre, there's a tough thing to measure because there's so many, Zach alluded to this, there's so many like micro improvements that have been made across the organization. They're really, really hard to measure, but they show up in longer quarterly cycles as the team performs better and they're hitting their targets, exceeding their targets, that kind of thing. That, I think, is going to start to play out over the quarters and years ahead. You're going to start to see that more with leading companies that do adopt it, because there's this hidden layer that's really tough to measure at scale when you're dealing with a 7,000 person company, for example.
Yeah. Very good, very good. Strong judgment and customer centricity matter. A great human can make AI better, and AI can make a great human better. What does great collaboration look like between humans and AI?
Whew. I feel like I've watched like too many like Ex Machina movies and stuff like that. I don't know. There's lots of examples out there. Bad collaboration, I think. So you mentioned judgment. I think this is so important. Whether we're thinking about AI as a coworker or an assistant, whether we're thinking about it as a subordinate that we're farming off, work to, the judgment piece. And you could argue, I think, that it's getting a little bit better in the latest models, but I still believe there's no replacement for great human judgment. And so I think what good collaboration looks like is recognizing that you're responsible for bringing that to the equation. And if you get some judgment out of the AI that is reasonable, you take that as a win and you move on, but you sort of trust but verify, and always understand that it's on you to provide clear, great specification up front, to judge continuously along the way, to be skeptical. It's actually so funny. I see more skepticism in peer code reviews, human to human, than I do human to AI, and I find that a little bit hysterical. There's some sort of some great, sociologist or psychologist or both could do like a great social experiment on that, because there's definitely something there, that speaks something about the human condition. More so the AI code reviews I see are like, yeah, I don't know, it's the AI did it. The AI's a genius, great, like good stuff. And then the peer reviews are like, I'm gonna nitpick the semicolon, Andre, because I don't know, I didn't get enough potassium this morning. So. It's interesting, that judgment piece, I think, is super important to remember. And then I think this is related, but I'll use a different word, although I think it can manifest as judgment sometimes. I think accountability is so important. And at DraftKings, we always had a tremendous, you build it, you own it, you run it, high accountability culture. Not just even in engineering, I think accountability runs super high in every one of our functions. It's more important than it's ever been with AI. AI is just the latest version of, you tell your professor the computer didn't do what I programmed it to do, and the professor would say it did exactly what you programmed it to do. And I feel like every student, at least in comp sci, had this moment where they were like, okay, this is my fault, even though I wasn't running the program. This is no different, right? Like, whether it's vibed, whether there's some judgment along the way, we are ultimately responsible for every single thing that this system does, even if it does some things that we didn't ask it to do. It's no different than if we were writing the code line by line. So those are the two things that I think, when you talk about collaborating, with agents, or delegating to agents, or farming off entire projects to agents, strong judgment, and high ownership and accountability are more critical than they have ever been. So if you're going to practice anything, find professional opportunities to practice that.
Mm-hmm. The other piece I would add to that is, I'm stealing, again, a line for our Chief People Officer, where she described we're in an age of abundance. I really believe that in every way. And the AI kind of tools and capabilities that we're using today really can create this abundance. And the pieces that I see, the example back to that product manager story I told, is that I find that good human AI collaboration is one that actually creates space for humans to do what humans do really well. Whether it's thinking creatively, having that space for judgment. We're all working in fast, high pressure organizations, competitive spaces. And many times you can see parts of your organization, or even individually, you get caught on that hamster wheel of like, I just got to hurry up and get this thing done by my deadline, or else something not good is going to happen. I think leveraging AI tools to kind of build systems that allow you to kind of get on top of that and remove some of the toil, such that it creates the brain space for you to think more creatively, think more critically, think bigger, set higher goals. Those are the spaces that I start to see opening up now when you really lean in hard and leverage AI in a really practical way. It's quality, it's people raising the bar on what they're trying to deliver, that type of thing. It really creates space for humans to be really human and lean in hard, and having the mental space. It's the old 2x2, right? Everything in life can be reduced by a 2x2. The stuff in the upper right is critical and important. That's the hair on fire, we got to get it done tomorrow. Don't think, just do. And then the category 2 is the stuff that's important, but not necessarily as urgent. And what you're doing is, I think AI can create more of that category 2 space to actually, that's where the real value is, that's going to pay off dividends down the road.
Oh, very good. And I think what stands out to me from what both of you said, it's as our organization and other organizations out there, as everyone's kind of going through their own version of their AI transformation, yes, there's a lot changing, and it's changing fast, but it's also important to call out what hasn't changed, and that is that accountability for each and every individual. Across my teams, we talk about this all the time, that, hey, we are, as an implementer of this unit of work, we own every line of code that we put into our systems, regardless of whether it's generated code or not. So that's a great answer. As we wrap, for the engineers in this room who are earlier in their careers, what's your honest advice for navigating a moment where tools, expectations, and the definition of what a great engineer, it's all changing so quickly? What qualities do you look for in engineers and engineering leaders?
I'll get us started. I think I'll be controversial. I'll say I actually don't think what makes a great engineer is changing. Or maybe change is subtle and happens over a long time. But coming back to accountability and good judgment, like breaking that down into how that relates to being an engineering professional, I think what has always been important is critical thinking and problem solving. And at different scales, that means different things. But being able to break down the problem all the way from the ultimate objective that you want to achieve all the way down into the components that you need to put together to make that possible. That's always been what it is. Whether you were doing punch cards, 70 years ago,
I remember that.
to launch the space shuttle, or whether you're writing compilers, or whether you're writing objective-oriented languages, to now maybe not even looking at code and working, delegating that to your agents. Like, the thing that is true across all of that is there's an objective to be had, and there are ingredients that need to be put together in a creative way to meet that objective. So I think all that stuff has always been important and will continue to be super important. So if you're just coming into the field, the advice I'd actually give you is you're probably more AI native than the professionals that are in the field. That's a superpower. Lean into that. I can guarantee you all the professionals who are already in the industry are working to craft that superpower too. So it's not an advantage that you'll have for long. But I'd lean into that. And like I said at the beginning, experimentation culture, I feel like this has always been important for engineering-minded folks and will continue to be important. Technology is constantly changing. Maybe now it's changing faster than ever, and we do have to think about you know, how that manifests in terms of cognitive load and learning. But it's just accelerated. It's the same story as it's always been. There'll be some new piece of technology tomorrow that'll become the most important thing to learn, and smart people will figure out how to learn it and figure out how to apply it. So I would lean into those things as you enter the workforce.
Yeah, I'd echo two quick ones from my point. 100% what Zach said, right? The fundamentals of a good engineer are never going to change. Like, there's a long history of, certainly in software engineering, it's a long history of abstraction over the years when you look at it. So I think that's only going to continue, and lean into that. The piece that I would, for those that are getting into it that are new though, new engineers, I would also add to what Zach said is, like, it is important to understand how what you've built works. Don't get into the trap of being so thin and so broad. You really should take the time to understand, I built this thing in the agentic code, I vibe coded pieces of it, but really make sure you know and go deep and how it actually works, like in detail. You're an engineer, you need to know how every little gear and widget works in the system you built, and understand and think critically, be a systems thinker, problem solve. So I think that's super important. Go deep, don't be thin, because that's where, if you just trust what AI comes up with, it's not gonna work out well. The second one is outside engineering, is what I see, Zach alluded to this, everybody's a builder now. The challenge I see for people in non-engineering roles is you need to almost have an engineering mindset. So the critical skills that I see in business units now are things like systems thinking. Being able to understand, okay, I'm an operator, I'm running I'm in marketing, I'm in finance, I'm in operations, I'm in HR. You need to think like an engineer, think like a systems person. What are we trying to do? What is the flow of work from left to right? How many steps are involved in that? What are the problems? What are the friction points? How can we solve them? So that ability as a business person to be able to put on that engineering mindset and think critically, and again, I use the term systems thinking, that is a skill and a craft that everybody should master, because with the power of AI, you'll have the ability to do that yourself now. You won't necessarily need software engineer, computer scientists to help build you that. You can do it yourself. So I think for non-engineering people, that is, talk about age of abundance, holy cow. That whole area is opening up for you to be able to really drive and lead teams, deliver value. Andre's point of accountability, most important thing, whether you're an individual or you're a part of a team, that's a key fundamental principle at DraftKings is everybody is accountable, deliver outcomes, care deeply about outcomes. That is the fundamental cultural piece, and AI just supercharges that.
One last thing. It's really important to work somewhere, I think, that is AI forward. And there's a lot of great places to work, but I will tell you, and I'm biased, there's nowhere better to work than at DraftKings.
I think that's, you let Brian hang. Zach, Brian, thank you so much for joining me today. Thank you to everybody for joining us for this panel discussion. I want to say a big thank you to the DraftKings team representing out here in front. So you see everybody in the white jerseys representing. As you see us throughout the expo halls, please don't hesitate to say hello, learn a little bit more about our teams. I want to invite everybody from DraftKings, if you guys want to come up, we're going to take a big team photo. Thank you guys.
Good job.
Hello, everybody. I know you are about to leave, but I wanted to let you know of a quick change in schedule. Scott Hanselman's talk is going to be in this room in just a few minutes. And so if you would like to see Scott Hanselman's talk, stick around. It'll be in just a few minutes. See you soon. Hello, everybody. Welcome, welcome, welcome. Thanks for getting the alert on the app. So, we've got 2 back-to-back talks. If you want your double points in the app, you got to stay for both. First, we've got Scott Hanselman, who's going to ask a very good question. What would you build? What could you build if you could build anything? And then after that, we've got another talk from Jemiah Suisse, and then we've got some special announcements and stuff coming after that. Okay, so without further ado, please welcome Scott Hanselman.
We'll get it though. There it is. Hey friends. How are we doing? Feeling good? You building stuff, learning stuff, making connections? Got that LinkedIn? All right, my name is Scott Hanselman, and I started coding in 1984 because I'm old. And I'm going to retire in 892 days. Had to do the math. And thank you. And when I retire, I'm going to go teach high school science. I'm going to teach computer science and maybe regular science. And having 40 years of programming experience feels some kind of way when a young person comes up to you and say, hey man, software engineering is cooked. It's all just vibes now, bro. That feels some kind of way. So of course, when I got to hang out with Killer Mike backstage, who's got 30, 40 years of producing experience, I said, hey bro, producing is cooked, man. We don't even need you. We can just ChatGPT it. And then when I woke up, after he laid me out, I thought to myself, what a stupid thing for us to tell people that their expertise is useless, to take away that sense of power and strength and agency and production, and to say, we don't need you anymore, we can do it with this thing. I think that it is just as ridiculous for us to go to Killer Mike and say, we don't need you anymore, we have AI, than it is to go to a software engineer or a mechanical engineer or a business person. So we need to stop that narrative. We need to stop that narrative. We need to also stop externalizing our brains and then paying $100 a month to get them back. You pay $100 a month for cell phone, internet, power, water, and now we're getting dumb, and we got to pay $100 a month to get that back. But the problem is we're not thinking about whose fault that is. Yes, capitalism, yes, billionaires, not a fan. Would not recommend, 0 out of 10. But when we let the AIs take our brains away by not thinking, when you become a meat proxy, where someone asks you a question, say, I don't know. I'm going to ask ChatGPT, and I'll tell you what ChatGPT said. Well, what am I for then? I'm just that proxy in the middle. Those conversations don't get had. They don't get said out loud. Additionally, the AI feels magical. It's overwhelmingly magical. Like imagine going back in time and showing like someone from like Laura Ingalls Wilder, like, you know, Little House on the Prairie, show them an iPhone. It's inconceivable magic. Any sufficiently advanced technology is indistinguishable from magic, is a very famous sci-fi quote. So how am I supposed to tell my mom and my dad that the AI is not as smart as them when it feels as smart as them? It's like if you've got like an auntie or a grandma who's got a parrot, and that parrot swears. You ever have like a parrot in your life? How's it going? You suck. Why do you think that parrot sucks? It's because your grandma swears like a sailor. The AIs only talk the way they do because we have fed them that way. You are talking to yourself in the mirror when you talk to an AI. And we don't talk about that enough. You're talking to yourself in the mirror and a little bit of everybody else, because that's what it was trained on. I'm going to do a little demo here, and I'm going to show you how I think about AI, and then we're going to dig into it a little bit. So instead of just doing one of those things where I'm going to log into, you know, ChatGPT and do a little demo, I made a little web application here, and I'm on localhost. So this is running on my local machine, and it's going to let me see stuff that you don't see when you're talking to an AI. You don't have to be technical to know about this stuff. So right now, I'm running this on localhost. I've got a server on localhost 3000, and I've got the website on localhost 3001. And I'm going to ask it a question. Complete this sentence in one word. It's a beautiful day. Let's go to the. Okay, what's the correct answer? What is the AI answer for that? Beach, park. Well, hang on. Someone's saying beach with like, yes, it's beach, unacceptable. And someone's like, no, it's park. So there's only one correct answer, people. Let's find out what it is, because the AI, the all-knowing oracle, says it's beach. So the park people, you're wrong. You suck. But here's the thing. Because I have control of this, I can see the logarithmic probabilities that were coming back. I can see the parallel universe that we just entered as a group. The universe just split in half. 22% of us headed down beach. But in another universe, 77% of the time it's park. Isn't it interesting that we didn't even get the most likely question? We didn't get the most likely answer. Does this seem familiar? Anybody know who Steve Harvey is? We went out on the street and we asked him, it's a beautiful day, let's go to the, show me beach. Oh, it's beach, fantastic, all right, let's move on to the next round. This is a kind of family feud. It's making decisions based on statistics, and the statistics indicate that we're either going to the park, to the beach, or 0.1% of us are going outside. Let's see if we can try it again. I'm going to take the exact same sentence and I'm going to paste it in, and I bet you we're going to get park. 99% of the time we got park. Why? Because we already did beach. Context matters. We're in a different place now. We've said beach. Which makes you wonder, though, if beach was the right answer, why didn't it say beach again? It's not a fact machine, and going to the beach is not a fact. It's context. Now, let's give it a little more context. Complete this sentence with one word. My name is Scott Hanselman. I'm from Portland, Oregon. My dad is a firefighter. My mom is a zookeeper. It's a beautiful day. Let's go to the. Where are we going? Show me zoo. Going to the zoo. Or the market or the museum, but the zoo is happening. The zoo is happening because I walked it down the primrose path. So now, is it a fact machine? Is it the great world intelligence? Or is it an improv partner? What's the number one rule of improv? Yes, and. You've got to say yes, and. It wants to improv with me. It really desperately wants to have that next word. What is that next word in the chain? Do you know that this doesn't even speak English? It's all just numbers. 1, 3, 5, 7, 9. That is just the right number. We just knew that was number 11. Just start moving forward. We could do primes. We could do Fibonacci. When you see the pattern, you might go 7, 8, 9. You might go 7, 9, 11. And the pattern, the longer the numbers get, the more clear it becomes. The more context you give, the better at number guessing it is. I'm not saying AI is not a miracle. I'm not saying it's powerful. I'm not saying it's not going to change the world. But I am saying it's very, very spicy autocomplete. And I refuse to have my job replaced by spicy autocomplete. So, if I think about this math idea, and we think about the fact that these words aren't really words, they're just numbers behind this, we can think about some of the math that we could potentially do. I'm going to clear my screen here. It is trained on this corpus. A corpus is a body, the body of work. Reddit, Twitter, all the dumpster fire parts of the internet, my blog, Wikipedia, your blog, everything on the internet was brought together. And the normal distribution, the normal curve has exceptional stuff that's amazing and really lame stuff over here. But what's this part here in the middle? That's the average. It's the statistical mean. As my son says, it's mid. So if you ask it to make a website, it's going to be mid. If you've ever done something with an AI and you said, wow, that's fine, that's because it's forced into the gravity well of the statistical mean. It desperately wants to be mediocre. These are easy answers. Beach and park are easy. And it's not going to get better unless I give it more information. Complete this sentence with one word. My name is Scott Hanselman. I'm a type 1 diabetic, and I only drink Diet Coke. I don't drink water. I don't drink juice. I drink fizzy brown, luscious Diet Coke. I happen to be in Atlanta right now. It's a beautiful day. Let's go to the. Now, if I'm not going to the Coke Museum, I swear to God. No! Unacceptable. 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 AI is trash. That's my talk. 1.72%? Come on. Come on. We all know Diet Coke people are smarter than other people. I will accept also Coke Zero as an answer. Pepsi? Get out of here. You're in Atlanta. What's wrong with you? This math that happens is really, really interesting. Now, this is a gendered example. It's not a perfect example, but I'm going to use it. Where imagine a multi-dimensional space where you have a axis. You know, axis is sometimes like time and distance. We're going to have gender, and then we're going to have royalty. What is the most royal, most male thing? King. What if you subtract gender from a king? You would just get a generic royal. And then if you add female, you would get queen. And if you subtract a little bit of royalty, you might get princess. You're moving around, not in word space, but in a semantic space, a meaning space. And a really weird example of how to do this that I like to do that messes with ChatGPT is this. We're going to make a word vector. We're going to make a word. Okay, here's the deal. We're going to make a list of words, and I want you to start with the word good, and I want you to make each word after good one gooder. Until you get to the most goodest word, I want 100 words, and the final word will be the goodest word of all the words, starting from the word good. Go. Okay, so good, better, best, exceptional. I like that. This is good. Nice, fine, pleasant, agreeable, notable. Okay, phenomenal. That's good. 36 at phenomenal. Sublime at 51. I feel that. Zenith, 83. I don't know. Goodest? Bruh. Bruh. What are we doing? Okay. All right, hang on a second here. 97, God tier? What are we doing, man? You fell apart after 90. I thought you were doing great. 90, 91 was solid. But after 92, you're just making stuff up. What are you doing? It's going to say, you're absolutely right to push back. Yeah, I did fall apart after 90 there, because we're doing improv, aren't we? You're right. You're absolutely right. I had it going at 92. I started drinking. That's actually a better list. That's a better list because a human got involved. Human in the loop matters. But doesn't this feel like an improv partner? Doesn't it feel like I told it we were going to do a thing? Would you play along with me, really smart computer machine thing? If you start interacting with the AI like that, if you realize that you're talking to a statistical parrot that desperately wants to be your friend, they desperately want a yes and they will never push back unless you give it a reason to push back. It changes your relationship with the AI. Now, I'm telling you that. I know that not everyone here is a programmer. This is trying to be a non-denominational church that we're having today, so I want everybody to feel welcome. But when you know how to drive stick shift, it changes your relationship with the vehicle, right? I know we got people in here who had hard parents that said, you want a car? Drive stick first. You want a car? I need you to change the oil. I need you to change the tire. Then we'll talk about getting you a car. But then we have young people, though, who have Uber, which is great. Uber is a mobility joy for people who have different abilities or may not be able to drive a car. I don't want to gatekeep Uber. So how do I, as old man who shakes fist at cloud, want to tell people, y'all need to learn how to drive stick? But I also respect that you might need to use Uber. I want my kids to learn how to drive, but I couldn't find a stick shift for them to learn on. This is a challenge that we have to do. We want to have kids learn how to use AI in schools. We want kids and people to learn AI, to respect it, but we also have to acknowledge that this is a weapon. That's a crazy thing. The guy from Microsoft just said AI is a weapon. so is your Prius, right? Your little 150-pound butt is driving around in a 4,000-pound car that could knock people over. Everything is potentially a weapon, so we have to look at it with respect, and we got to think about how can this tool be used for good and not for bad. But if you know how to drive stick, you feel how the car moves, and here, hopefully, you're going to start thinking now about how you use ChatGPT, how you use Copilot, how you use Claude, and then you have to ask yourself, did I do that, or did it do that? Did I become smarter in my use of the tool, or did I just outsource my brain? That kind of what's called metacognition, thinking about how you think, is so deeply, deeply important. We've already broken the kids with COVID. We broke them with Zoom, and we broke them with all that, and then we broke them again with Instagram and social media, and now we're breaking them a third time with AI. Here's the thing, though. Darn it, it's useful. So here I am, working for a company that's all in on AI. Do you even AI, bro? Are you token maxing? What are you doing? I'm kind of in on AI. I'm kind of like, you know. I'm kind of an AI vegan. I've decided that I don't eat anything with a face. So I don't do AI images. I don't do AI video. I'm not going to generate poetry. I'm not going to go and make music with AI. I think it's wrong, and I'm making that decision, just as a vegan would make a decision about what they choose to eat. But I also acknowledge that I really like using it to generate code, generate websites. I like to brainstorm with it. So I feel like a hypocrite. Feels like church again, doesn't it? Don't eat pork. But if you do, here are some recipes that we've got printed in the... Right? Like, I don't eat pork, but pepperoni. That's my relationship with AI. And it's okay to be a hypocrite because we're all hypocrites. We're all sinners, and it's okay. But if you have that conversation with yourself, if you say the quiet part out loud, you will better navigate this AI space that we're in. And when I started being honest with myself about what my limits were, and I started to think to myself, I've just been pressing enter for the last 20 minutes. I can feel my brain slipping away. It changed my interaction with the AI because I can make anything now. I've got a rocket ship attached to my back. But should I make anything? I want to make things that are going to help people. I want to make things that have craft to it. I want to make things and say, yeah, I used AI for brainstorming, but I wrote that, I did that, I made that. And you want to be able to do it as well. And what's funny is that they just announced this AI watermark a couple of days ago. I don't know if you heard, but you're going to be able to detect even more when something is AI generated, which is making people feel some kind of way. Because you're like, well, hang on, you mean I can't pass it off as my own work? We're trying to figure out what that means. What happens when a novel comes out and an author decides to say proudly, I used AI to help me with this, but this is my book? What are we going to do as humans to think about that? We all felt the same way about computer art when we moved from painting into Photoshop. And you see someone in Photoshop today, and you're like, that is a skilled artist. They did that whole thing on a tablet in Photoshop. That's amazing. We don't feel like that yet about AI. So as a society, we're going to figure this stuff out. But as we move through it, we need to be teaching people how these vectors work, how this math works, and how all of this works together. All these words are related. I just put in Atlanta, and I built a multi-dimensional cloud of word vectors. Now, I went to community college, so that's the smartest thing I've ever said. I don't know how to go beyond that from a math perspective, but you don't need to. These words are all related. When I showed you the king and queen example, I showed two axes, royalty and gender. Inside the AI, the axes are not labeled. Gender is not a real axis. It just knows the words are related. It doesn't know why. Look at this. Those are all the different related words, and you can go and click on any one of these and find out what the words are, why they're related. You can go and put in names. This is called TensorFlow's embedding projector. So if you want to take a screenshot of that, you can go play, put in your name, put in your neighborhood, and see what's next to it. Which brings up an interesting question, which is the concept of bias. Where did it get this information? When I put in, I'm from Portland, for example, I'll put in Portland. Portland is Oregon. These are all the different things next to Portland. If I started looking for other words, I could find words near Portland, maybe like hipster. I don't know why. Seattle's in there, yard. If for example, hipster showed up in there, I might say, well, that's not fair. We're not all hipsters in Portland. And I might think that the system was biased. Bias happens when words are associated with each other for possibly a problematic reason. Early on in the AI days, like last year, Google got into trouble because someone was typing in things like, give me a picture of doctors. And it generated 10 white guys. And then you say, give me a picture of neurosurgeons. 10 white guys, maybe one woman. Here's where things get interesting. And this isn't political, it's mathematical. Do we want it to reflect past reality or aspirational future? I didn't say, tell me what doctors have historically looked like. I didn't say, make me a chart and use pictures of doctors as that chart. I'm assuming, depending on how you roll, that you would want to see half men, half women. You'd want a United Colors of Benetton list of doctors. That would be awesome. But that would be aspirational. That would be something that we as a society need to do. And if the AI is trained on the past, you would have to put your thumb on the scale to make it be aspirational. But then if you do that, they call you woke, they'll call you this, they'll call you that. What do you get your thumb on the scale for? Well, it was wrong. Well, what kind of wrong is that? Then they went and they said, I want you to send me a picture, generate a picture of everybody and the founding fathers. But they put their thumb on the scale too hard, and they ended up with a bunch of women and black folks and Native Americans signing the Declaration of Independence. Which is kind of awesome, but that's not how it went down. And it is kind of awesome, though, right? Like, it's a pretty cool picture. But the question is then, whose fault is that? And the thing is, it's not anybody's fault, it's math. But you've got to understand that those are what are called weights. So go and learn about this. Learn about weights in AI. You can Google for that. And learn about what are called open weights. When an AI has a bias in a certain direction, you can put your thumb on the scale. And these are not evil thumbs. It might just be like, oh yeah, it's saying some problematic stuff, and we don't want to talk about that, we're going to talk about this. Open weights are published, where researchers can go and say, well, that model has open weights. I know exactly why it answered that. I know exactly why it said zoo. I know exactly why it thinks Scott's a hipster from Portland. And then closed models are trust me, bro models. And then you have to ask yourself, as you vote with your feet, do I like the answer that Claude gave me? Do I like the answer that Microsoft Copilot gave me? Do I like the answer that ChatGPT gave me? Because then you have to ask yourself, who do you trust? Rather than trying to make it political and rather than trying to make it pick a side, Honda, Toyota, ChatGPT, Codex, which one do you like? What we need to do is be educated consumers. And if it smells bad, if you don't like it, you got to think about why you like it, which brings us back to metacognition. Where did this information get grounded on? And what are we going to do with it? Does that make sense? All right, cool. Now, I'm going to jump to a little story here because you have to ask yourself, what are we selling? What am I selling? Am I just selling slop now? No, I'm making the stock go up and to the right. Right, you got to keep it real. That's it. It's all about the stonks. No, what I want to sell and what I want people to be excited about, I'm not really selling anything because I'm retiring. I don't care. They can't stop me now. I want to sell confidence. I want to sell trust. I want to sell capability. That feeling that I can do stuff is what I want my kids to feel. You can do this. You got this. I dropped him off on Friday. Whew. House is empty. And fortunately, he's like, no, man, you can't trust ChatGPT. I'm not going to have my paper written by ChatGPT. I'm like, yeah, good parenting. Don't trust it. Lord loves a working man. Yeah, anyway, don't trust ChatGPT. So I want the kids to have a sense of confidence. I want them to have the kind of confidence that Baby Scott had. And I want to pour one out for the hair. That's not gel, by the way. That's just pure unearned confidence that's holding that hair up. I'm telling you, I was tearing it up back in the 90s. In this is a newspaper article where I wrote an application for the Palm Pilot. Shout out to my Palm Pilot people out there. Yeah. What's a Palm Pilot? What's a Palm? Is that like an iPhone? I wrote on a Palm Pilot in 4K of RAM. That's 4,096 bytes of RAM. Right? He's taking a picture right now. I could fit 1,000 co-pilots and 1,000 Palm Pilots, rather, inside the single JPEG that he's going to create on that phone right now. So to understand the distance and the far away. And I wrote that, and I did this with Tony Stark in a cave with rocks and sticks. And I realized that it's because of these people. That's my dad, Portland firefighter and woodworker, and he does Native American bows and arrows. He takes a tree, he finds that the tree is shaped the way he wants it to make, he cuts the tree down, and he turns it into a traditional bow. And then he goes and he attempts to shoot a deer. He's never hit a deer, but he looks really good doing it. And my mom is a zookeeper, and she made all of the gloves for the Birds of Prey program at the Washington Park Zoo in Portland, Oregon. These are craftspeople. These are craftspeople. So I was always thinking that, well, I'm this guy, and they're these people. But now that I'm older, I realize we're the same. I want to make cool stuff. I want to craft stuff. And here's where the capitalism happens. I dropped him off, and we went to IKEA. And we bought a bunch of flat pack stuff, and we put together his little things, and we set up his little, and then we left. And I called my dad, and he made a joke, and he's like, well, I was watching this thing on Japanese carpentry. And they can like take two pieces of wood that aren't supposed to fit together and make them fit together and have millimeter precision. And he's like, I really admire the craftsmanship. And I was like, Dad, I don't know why you're telling me that. I just came from IKEA. And I dropped my son at Howard, and you think he should have Japanese quality chest of drawers? And he said, I'm just saying. But how do we exist in a world where Japanese carpentry exists, Japanese carpenters exist, and that level of tradition and 1,000 years of quality exists? But sometimes you just need some billy shelves. That same experience, that slider bar of quality, is the same thing that we need to think about when we're thinking about AI and when we're thinking about making stuff. Are you going to be a slop cannon, just spitting out AI slop? Are you going to be a vibe coder, where it's like, yeah, I don't really care about the code, but it's cool? Or are you going to be an AI-augmented information worker, an AI-augmented software engineer? Are you going to be like Japanese carpentry, but you're cool with drills? You know the Amish, right? Like they're cool with that thing that like makes planes the wood, but they're like, nah, I'm just going to use a drill, or I'm going to go like this and use a regular drill. You need to decide. But you should decide with your eyes wide open how far you're going to take it and where AI is going to help you. This is not an anti-AI talk. This is a pro-being conscious talk. This is a pro-being aware of what you're doing and acknowledging that in a world where AI is magical and these parrots can do stuff that we couldn't do, it means we're going to have to memorize less stuff. But the most important thing is you have to have good judgment. I sent my kid to school on Friday because I need him to learn judgment. I don't want them to teach him ChatGPT. I want them to teach him how to call BS on when ChatGPT says something and he's like, it doesn't feel right. Brainstorm with it. Use it for toil. Use it for tedium. Use it for stuff that's not creative. And apply your taste and your responsibility and your human judgment to it so that you are a better person. And remember that it is not intelligent. It is not creative. And it is absolutely not a replacement for thinking. Now, that said, you can do some crazy stuff. And I want to show you a couple of things that I did. I wanted to get a Peloton. And I'm like, these are great. I see the ads all the time. Good-looking people who are fit on bicycles. I want to be a good-looking, fit person on a bicycle. I want one of those. Peloton.com, $5,000. Okay, so we'll be walking. Do you have Peloton money? I do not have Peloton money. That is ridiculous. However, it looks pretty much like a bike with an iPad. I can get a bike, and I have an iPad. So I went to Goodwill and I bought a bike for 30 bucks. And then, like Odysseus to the mast, I lashed the iPad to the bike. And then I said, well, now I just need videos of attractive people to motivate me. But then they were just making me sad because I'm this close to someone better looking than me with abs going, you can do it, you can do it. And I'm in my garage and I'm wearing jeans, and yes, I work out in jeans, and no, you're not going to shame me about it because it's fine. So then I thought to myself, this seems like vibes. I'm going to vibe something. So I said to my co-pilot, let's make me a website. So I made a thing called Pedalscape. And I can go on bike rides anywhere by curating videos from YouTube, human curation, and I ride my bike virtually through wherever. And I built a whole thing where I can go and decide, oh, I want to have lakes, do I want to have this, do I got 20 minutes, do I got this, do I got that? I think it's kind of a cool looking website. I added in things like 4K. I went through all of the YouTubes and I curated, this is in the mountains and this is in the ocean and da-da-da-da-da. And then I found out that there's a thing called web Bluetooth. You can connect to Bluetooth from a web page. Pedalscape wants to pair. And then I got a $10 cadence sensor, which is like a magnet that goes onto a wheel and it goes by. And then I connected to it with JavaScript. And now I can overlay the cadence of the bike on top of this thing. 30 bucks, 35 bucks for the Goodwill bike. iPad I already had. Gaffer tape, $10 Bluetooth. Peloton. That's cool. So I put it out on the internet and I said, hey, internet, I made a thing. First comment, it's trash. I have a treadmill. So I was like, okay, fine. It's just vibes, man. Now, here's where things get interesting. It's not just vibes. I checked it into GitHub. It has a build server. I can make changes to it. It has tests to make sure I don't break it. I didn't do it in one shot. I didn't say, computer, make me, right? This took turns. It was a collaboration. This is AI, augmented software engineering. I sat down with GitHub Copilot and I had a conversation and I pointed it in a certain direction. And I talked to my users. And some of my users were speaking Spanish. So I translated it into different languages. Did I use AI to translate it? No, I used humans to translate it. These are actual human translations. Then I wanted to make sure it didn't have a database and it was entirely local. So I built the whole thing as a progressive web app, and you can install it directly onto your Android. It has no tracking, no cookies, and you can export all of your data as a JSON file. That's not Copilot or the AI deciding that. That's me. I will acknowledge, though, I'm not a web designer. So would you all agree that from a design perspective, it's not exactly breaking any design awards? It's mid. It's mid, thank you. I appreciate that you volunteered that it was mid. I was heading in that direction and he's like, it's mid, just jump. No, I get it. No, it's bad, I understand. Because it's mediocre. I made another website for my cloud podcasts. I don't have any design skills. So it looked like this, which looks like literally every website in the world. And I made another one called Tiny Tool Town. And it has a gradient with text and the same fonts, and that sucks. So that's why I had to put in GeoCities mode, which works with Netscape. And there's also Fire at the bottom, and there's some broken images, and then you can email the webmaster or sign my guest book and join my web ring. And then I'm hoping to get a link on Black Planet, so it's gonna be hot. You need to decide when you get that mediocre website how hard you want to push. If it's vibes, it's cool, it's vibes. It's okay to vibe something. But then you can't vibe it into production. You can't vibe a serious business. That young guy who was like, bro, AI software's cooked, bro. Okay, why do you think it's cooked, young man? Well, Unc, it's because I told the AI I want a copy of Minecraft. I did it in one shot. One shot is when you tell an AI to do something and it nails it on the first try. And I said, okay, what was the prompt? Because you're a prompt engineer now, right? Everybody's a prompt engineer. If you have prompt engineer in your LinkedIn, you should probably take that out. That's up there with thought leader. If your LinkedIn is thought leader and prompt engineer, we need to talk after because that's not okay. He said, I told the AI, make me a clone of Minecraft. And I said, young man, and then I did the prayer hands. Which word do you think is doing the heavy lifting in make me a clone of Minecraft? Well, I said probably Minecraft. That probably means a lot. I said, I don't think you understand how much Minecraft means. If you said, make me a clone of Mario, make me a clone of Pac-Man, make me a clone of Space Invaders, make me a clone of COD, those would all work, right? Because they are known. There is probably no better known game than Minecraft. So when I say the semantic heavy lifting, he thought he put in, make me a clone of Minecraft, 6 words. What he did is he put in the 700-page specification that describes the exact behavior, look and feel, and process by which Minecraft works, and the knowledge of every clone that anyone has ever written of Minecraft online. All of that semantic meaning got pushed in because he just said Minecraft. If you don't believe me, I would encourage you all to use your co-pilots and go and say, make me a clone of Minecraft, and you can't say Minecraft. And you're going to get the most freakish, nightmare-inducing stuff because as soon as you can't say Minecraft, it doesn't know what you're trying to say. But as soon as you say Creeper or Voxel or Steve or anything that nudges it into the word space of Minecraft, it will fall into the gravity well that is Minecraft, and it will start looking like Minecraft. It will find itself to the statistical mean. So when you ask yourself, is it impressive that I can go and say, make me a clone of blank well-known thing. Make me Star Wars, except do it in the style of Shakespeare. Is that a parlor trick, or is that a world intelligence? Try making things that haven't existed before, and that's where you come in, and that's where we need to force ourselves to come back in. We want to have this momentum. Copilots and things like GitHub Copilot are a momentum engine. When you're talking to it, it's like talking to a rubber duck and trying to work your problems out or calling a friend. When you don't know what you're doing, it's like talking to a junior dev that has infinite energy. But if you kind of know what you're doing, you can be like a senior developer. It has infinite patience to explain things to you. And this is where good taste comes in. So back to my kid and back to your kids, and we think about kids. I'm trying to put together an internship, apprenticeship program at Microsoft with my buddy Mark Rusinovich. And we're calling it PRAISE, Preceptorship for AI Augmented Software Engineering. I love a good acronym, like Agents of S.H.I.E.L.D. That was awesome. You got to make a good acronym. The longer the better. Preceptorship. You ever heard that word? Any nurses, nursing people who know nurses in here? Preceptor, yes. Preceptor is a word from nursing and from medicine. When you come in as a nurse, you've passed the boards, you've passed the NCLEX, you are a nurse. Day one, you are qualified to be a nurse. But with software engineer, you bring people in and they've done the degree, they've done the boot camp, they're qualified, and then we say, okay, welcome, you're an intern, you're an apprentice, and then you got to dig yourself out of this hole that we put you in. But in nursing, they assign you a preceptor. The preceptor has a name tag, and they're a safe person. When you're a software engineer, you go into work, and if you say something wrong, you think it's going to go on your annual report. They're going to write you up. What is DNS? Oh, man. Oh, you don't know what DNS is? Oh, my God. I'm going to tell your boss. In nursing, if you don't know something, you go to your preceptor and they're a safe person. So we want to build preceptorships for software, for AI, for information work. Everybody watch The Pit? Yeah, you've seen ER? This is a universal thing. I've done this talk and talks like this everywhere in the world, and I wanted to confirm that it turns out medical dramas are the same everywhere. Somebody comes in, I can't breathe. Oh my God, he's got a blocked airway. Quick, we got to get him into surgery. There's no time. He's only got 2 minutes of oxygen. Oh my God, what are we going to do? It's my first day. And then the chief resident, hey, do you have a pen? Yeah? Hands him the pen, takes the pen bits out, looks down the barrel of the pen to show you that it's open. He says, quick, we've got to open his airway. I'm going to stab this guy in the neck with a pen. He gets ready to stab the guy in the neck with a pen. The guy's going, we're losing time. Just as the guy, the senior resident's about to stab him in the neck with a pen, he says, hey, who are you? It's your first day. Yeah, I just got here. I just graduated as a nurse. You ever stabbed a guy in the neck with a pen before? You can't do it. We can't do it. He's dying, man. He's dying. But it's alert. We're a teaching hospital. We're a teaching hospital. Takes the pen. Okay, you got to put it neatly between the first and second thoracic notch. I don't know the medical words. I just made that part up. And he says, I can't do it. Do it, do it. No, I can't do it. Do it, man. They wheel him away. Thank you. Then they cut to the chair after, the Love Island chair, and they go, hey, how was your first day at work? That was amazing, man. Today I stabbed a guy in the neck with a pen and I held a human heart in my hand. I'm going to be a doctor. We need to make moments like that for young people. That's why I sent my son to school. That's where you need to go back to your job, to your young people, to the people in your life, and you need to think about, how can I make a moment today where my kid gets to stab somebody in the neck with a pen? Not exactly that, but in that general genre. In a world of AI, if it's going to do that work for us, how do we make these moments? At Microsoft, we're going to do that with, hey, website's down. Senior person could fix it, but hey, senior, bring these two juniors along and let's work together and let's let them push the easy button. Let's let them bring that website back up. That's how I grew up. I've been doing this for 40 years. And every time I got somebody with a little more information, I sucked that information out of them. They put me into situations. They created luck for me. Luck is opportunity plus being prepared. And they made that luck for me, and we need to make that luck for them because we're not going to be able to navigate this AI world if the kids are saying it's just vibes, man. We got to be able to tell them how to have good taste. We need to drive the stick shift. They need to know the fundamentals. The fundamentals are more than ever important. You've seen those things on TikTok, on Instagram, where they make a kid read from a 3.5 by 5 card and they can't read. We've got to get on that. Otherwise, these AIs are going to gaslight them into thinking that they're smart. You're absolutely right. You're a genius. You're my new friend. That kind of talk from the AI is going to be problematic, and it's not going to serve us in the future. We need to create a world where people are not feeling dumb, they feel brave, they feel powerful, and they feel capable. And that is my goal for you, is to go out with that renewed understanding about how AIs work. Think about what you can make, whether it's a Peloton clone or your dream application. It might be an application for everybody, or it might be an application for an audience of one. And that's okay, but I want you to be awake when you do it. I want you to be aware. I want you to make good choices. Thank you very much. I want you to stick around because we've got Jemiah coming up right after here. So stick around. All right, don't go nowhere.
Wow. Am I on? Can you all hear me? Am I coming through? No? I think we need the audio up a little bit more. Am I good?
Man, this is going to be interesting. Trying to follow Scott is not an easy feat. Like, that was incredible. Like, absolutely. All right, but we'll give it a shot. Hey everybody, I am Jemiah Sias, the Vice President of Market Strategy and Developer Relations at New Relic. We need Camden's mic on.
Test. Hello. Do I have audio? Oh, I have audio now, okay. Camden Sweda, Senior Director of Product at New Relic, overseeing our AI feature development.
Yeah. Awesome, and I'm actually excited that we are following Scott with parts of his conversation talking about the things that you can build with AI, right? And in this session, we're gonna show you something that we built at New Relic, which is our SRE agent. I'll hand it over to you, Camden.
Yeah, so I'm going to unpack a little bit about Autopilot. I don't know if any of you were at the session yesterday, but we talked about some of this. But the kind of key things we focused on with this agent that is designed to help eliminate toil for engineers and SREs and on-call responders is that we have built a set of specialist agents that are kind of all optimized for you right off the shelf. So it's going to offer a lot of off-the-shelf value for things like Kubernetes troubleshooting, Kafka issues, APM issues, and so on. It also shows all of its work, which we'll see here in a little bit, so that you can kind of follow along with how it's using New Relic to solve these problems. And so you can kind of learn better, how to use your data, how to query it, where it's at, what's missing, that sort of thing. And then also, right, this agent gets better the more you use it due to a couple of features. One, of course, is the retrieval augmented generation, where you can kind of feed it runbooks and retros. Another is long-term memory, where it's kind of storing memories, either because you're explicitly making it or it does it automatically, and then kind of breaking them down into facts and then creating relationships between them. So, we can kind of unpack a little bit more about this, or I think we can, kind of emphasize a few things about the ecosystem part of this, right? So we already talked about the skills and tools that kind of make this a team of experts, the memory, the so on. But the other thing we really want to emphasize is that this, Autopilot is extensible, right? We have integrations with ServiceNow, we have integrations with Slack, Atlassian, AWS, DevOps agent, increasing number of these things because, we recognize that our customers or any engineering team for that matter will have kind of a long tool chain that they need to rely on during incident response and triage scenarios, and we need to kind of go where they are, right? So,
actually, let me chime in quickly because I do think that you spoke about it yesterday, right? And then, so for me personally, I actually want to see things in action, right? I want to get hands-on with them. I want to use them. So let's focus on demoing, and we're not going to do any more slides, right? So I'm going to set a scenario, and then basically, Camden, can you show us what it looks like?
Yeah,
right? Okay.
totally.
So let me just level set. Two is in the room. Are we all building and responsible for running software in production? Right, distributed environments, cloud-based, AWS, GCP, Azure. So we got quite a few folks who's still running legacy systems on-prem.
A couple.
No one. Oh, a few people,
yeah.
Right? All right, but so in this room, we have like a mixture of folks that are running almost any type of environment that you can think about, right? And so this kind of I'm sure you'll resonate kind of like with this scenario where you have a haunted microservice. There's something wrong with your production environment. You can't really figure out what's going on. You don't know which service in the stack is happening, causing the issue. And so let's take a look at how Autopilot can possibly help with that. So let's say, for instance, we have a distributed environment. We have multiple services that are alerting at one time. Let's say that it's like a checkout service, something that's actually business impacting, right? Your users cannot process orders, so that's going to stop your company from making money. It could cost someone their job. It's the worst moment of kind of like your day-to-day as a software developer or a DevOps engineer, right? And so what you don't want to happen is customers to be tweeting you or messaging you saying, hey, I can't check out, right? Like that's a terrible experience. And so let's see how we can help with this situation.
Yeah, let's get over to the demo. There we go, yeah. So what we're looking at here, right, New Relic's homepage gives me a pretty high-level picture of kind of my instrumented state here, particularly the services and things that I care about. And just as Jemiah said, right, we've got a few different services that are kind of in the red, right, because they're throwing errors, they're exhibiting anomalies, whatever they may be. Now, this gives me a very kind of high-level picture, right, of what's going on. And normally, I think for many of you that maybe have used platforms like this, you know, you would typically start by, like, say, going to the summary page for a particular service to see if you can see any kind of smoking gun type things, right? Are there deployments that have been made recently? Can you observe anything? But, you know, you'd oftentimes be kind of fiddling with, you know, with the time picker, various filters, that sort of thing, maybe looking for a dashboard. And kind of what I want to highlight here, right, is that using Autopilot, I've mentioned a couple of times that really at its heart what it is an expert New Relic user, right, that can kind of navigate the platform for you, navigate your entity graph for you, navigate your data for you, and kind of draw these conclusions. And so what we're seeing here, right, is a pretty high-level prompt. I'm asking it for a variety of things that's run. And as you can see here, right, it's put together a pretty comprehensive kind of summary of the situation, and this maybe took it, you know, a couple minutes, 2-3 minutes. It's always getting faster, but sometimes it's quite a bit of data for it to go over. But the point is right, this, you know, in many cases could be running asynchronously before I even land on this page due to what we'll get into in a little bit, how you can hook it up to workflows and alerts and so on. But you can see, right, one of the things that the agent did, which I think is one of the biggest sources of time savings for an engineer, is it kind of walked the entity graph for you, right? So it's going to look upstream, it's going to look downstream, it's going to do kind of a broad anomaly analysis across golden signals across all of those entities. It's going to look for things like deployments or other suspicious change. And then, you know, after walking that entity graph, looking at logs and a variety of other things, it's going to attempt to do a causal analysis, where it's either going to try to match what it's seeing against sort of documented deterministic causes that we have in graph form, or it's going to, you know, base it off of logs or do whatever it can, right, with its causal analysis sub-agent. And then finally, of course, it recommends actions, next steps, and then suggests some follow-up questions. Now, before we, you know, kind of move on here, I just want to highlight a couple of things, right? I mentioned earlier, you know, this is all very kind of explainable, right? You can kind of understand exactly what the agent's doing, and I'll zoom in a little bit here. You know, and you can fully understand very transparently what the goal it was it gave itself based off of the prompt, its reasoning, and then in each of these steps, you know, the fascinating thing is we kind of expose pretty transparently to you exactly what queries are running, what tools are running, what skills it's using, which sub-agents it's using. So oftentimes you'll see it kind of handing things over to a Kubernetes sub-agent when there's particular issues with Kubernetes, and there's kind of a growing roster of these things. And, you know, you may not need or want to get into this level of detail, but especially early on, we see users doing it because they're building trust with the agent. They want to understand maybe it steps 1 through 5 were what you would do, but step 6 seems strange. Well, you can use step 5 as a jumping off point, right? And you can grab the queries that it ran, you can grab the nerd graph calls, whatever you need to do, and you can kind of pick it up from there. So all of this is very, you know, is easily accessible from within, you know, this reasoning panel here. And you can see at a high level, right, it did its causal analysis. It looked at the particular entity's golden metrics. In this case, obviously, we're using chaos injection with feature flags. So the agent's smart enough to realize what we're doing there, but I've kind of convinced it to go along with it anyway. You know, it's looking at downstream service entities, looking for deployment correlations, and so on and so forth, right? Notably, right, this is kind of I'm prompting from the APM summary page, but you can also configure this to run automatically from an alert firing. So in this case, right, let's say you get a notification in Slack, you get paged, you follow the link in that payload to New Relic. Well, Autopilot will have already been running, right, to do a similar kind of analysis and triage. And, you know, even if it's not going to solve all of your problems for you, right, but what it does do is it saves you 10, 20, 30 minutes, sometimes more, of going and finding the dashboard, writing the queries, iterating on the queries, finding the data in New Relic. You know, all of this different stuff that we normally associate with kind of early triage that eats away at our ability to hit our service level objectives is kind of accomplished for you, right? And then you can use this information that it's gathered as a basis for your own root cause analysis. You can review its recommended actions and maybe even take some of them. What do you think about that, Jemiah?
I think it's amazing, right? And especially the concept of autopilot being able to automatically respond to an issue, right? For every minute that your system's down, your business could be losing hundreds of thousands of dollars. And so it's incredibly impactful. So let's just recap what we saw, right? Because when we think about how long it would take for a human to respond in this moment, normally you're getting in Slack, going into a war room, there's multiple teams in there trying to figure out whose service it is. You're kind of like passing the buck, no one wants to be the owner of the issue, you're trying to figure out who else you need to bring in. This is all critical time, right? And figuring out what's going on, do we need a patch, do we need a rollback? Now you're gonna get all that insight up front with no guesswork. Autopilot's gonna do the mapping for you, it's gonna understand the topology, it can see what's upstream, what's downstream, and it's reasoning with the trusted living operational model. So it's providing you key insights with true understanding of causality, right? So an easy to follow causal chain. So it's not just a list of random correlations, it's really kind of like giving you a complete view of what's going on so you can trust in its recommendations. One thing that I did see is that it's also associating it to business impact, right? So I don't know if we have leaders in the room, right? But you're not just responsible for the performance of your system, right? You also have to understand what does that mean in dollars, right? When this service goes down and my users can't check out, how much money did we lose in this last 20 minutes, this last hour? And so autopilot can give you that, right? And so I think that that's absolutely incredible. All right, so we're gonna go into another scenario. I'm gonna keep pushing at you.
Definitely, yeah, let's get back into it. I think this is where things get really interesting.
Well, let me set it up though.
Oh.
All right, so we hear a lot about AI. I think there's a lot of questions around how does the human play in this, right? Like how do we stop these new tools from impacting our environments? Now our processes are non-deterministic. You have agents that are making its own decisions. It's calling other agents. It's calling out to other tools in MCP. How do we add some level of control over that? And so let's show it.
Yeah, sounds good. So this is where things I think get pretty interesting, and we're seeing a lot of customers get very creative with basically embedding calls to this agent within deterministic workflows that they've set up, right? And they're connecting these workflows to alerts, they're triggering them off of a variety of other events. It's kind of the sky's the limit in terms of what you can actually set it on. But what they're doing, right, is they're saying, I definitely want steps 1 and 2 to happen before anything involving generative AI happens, right? Like maybe they want to go grab logs from AWS, maybe they want to go grab something from the public MCP server, whatever it is. There's a variety of actions that you can kind of embed in these things. And then they want to make sure that that context is passed on, right, to autopilot for that it can use it as part of its analysis. And then critically, right, they want to be able to dictate sort of what is possible after autopilot runs. So rather than a future in which, right, this agent is going to be kind of choosing actions and making API calls, right, we're more so aiming for one in which there's conditionals that follow in this deterministic workflow. It's very auditable, very dependable, that sort of thing. And these conditionals, right, are based off of the output of autopilot. So autopilot will provide some reasoning, maybe that, yes, this does appear to be a serious issue with your front end, right? Checkout is disrupted. Seems like checkout may even be entirely down. People are abandoning carts, whatever it may be. And then use that as the basis for things like escalation, as the basis for like paging in more people, maybe even eventually, doing things like rolling something back or scaling up some infrastructure, whatever it is. But in this particular example that we're looking at here in New Relic's workflow automation, what you're seeing is this is essentially a human in the loop kind of approval workflow. So it starts off of an alert, right? And then these kind of approval URLs are created. And then the call to autopilot happens where autopilot goes and does its analysis of a particular scenario, right? A particular issue. And then based off of that analysis, right, it's going to actually send a message to Slack, and we can see an example of that here. It's going to send a message to Slack and basically say, hey, give me a thumbs up if you want the rest of this workflow to complete. Notably, it's the workflow completing, it's not the agent completing its run, right? Or give me a thumbs down, right, if you don't. And depending on the user's input, right, it will then go ahead and proceed with, kind of logging the denial and then ending, or actually kicking off whatever the remediating action is that's being attempted by this deterministic workflow. So say, scaling up some infrastructure resources or doing a deployment or whatever it may be. And this is a relatively simplistic example of human in the loop, but when we see how customers are sort of are doing this and kind of mapping their incident response processes, their particular business processes to these workflows, and then kind of embedding these calls to the agent and giving it custom prompts as part of that, right? This just says demo, but you get the idea. You can put whatever you want in here and kind of prompt the agent to do whatever you need to do. The sky kind of becomes the limit when you kind of mix these deterministic workflows and a call to the agent. So it's really fascinating. And to Jeremiah's point, what this does is it helps us really ensure that customers are able to determine ahead of time what is actually possible following one of these runs and what will definitely happen before the agent runs itself. So this is a great way of kind of getting started, especially if you're triggering this off of alerts that are from monitoring happening in New Relic already.
So
what do you think about that?
Yeah, I think it's great. Let's quickly recap, and I'm going to hit you with one more scenario. Let's switch back to the slides, right? I think it's great because it does a few things, right? It keeps the human in owning the process, right? With that workflow automation, you kind of choose when autopilot runs, which tools internally and externally it has access to, right? But it does open a wealth of possibility in what you can do and the level of control that you can have. It does provide you that safe execution, keeping the human in the loop. I think we're using that internally as well, as being able to do some auto remediation in a controlled manner where we know exactly what's going to happen. I think for maybe the last 20, 25 years, we've heard about getting to this self-healing system. Right? We want our systems to be smart enough to where when something goes down, it understands what's happening, and then it can roll it back, or it can do kind of that level of work for us. And I think that we're getting there, but with the gating that we provide, you can build confidence in what's going to run, right? It's not going to be a system that's completely out of control, and then it's auditability, right? You can see everything that happened. I can look at my logs and follow every step that kind of the agent in the workflow took. So for a large enterprise company, I think this is that level of insight that's needed to build confidence in deploying these type of tools and using them in production.
Totally, yeah.
All right, so let's talk about how the agent learns, right? So issues don't happen in a silo, right? We see repeat services that are going down. And I think if you're using a tool like Autopilot, it should be getting better. You should be able to resolve issues quicker. So walk us through on how the system actually learns. Once I work with it, if I have a similar issue, is it automatically going to pick that up? Will I get to reduce my MTTR just based off of leveraging the tool? Can you show us what that looks like?
Absolutely, yeah. So what you'll notice, right, when you use Autopilot is oftentimes you'll see it do something like load skill knowledge query. Right, you can see it here. So what it's doing is it's going and it's not just looking at telemetry, entity relationships, log contents, that sort of thing, right? It's actually going back and querying what it knows happened in the past, right? And this can either be because you have been indexing what has happened in the past from, say, Confluence in the form of retros, or, right, maybe you're indexing things like runbooks to try to inform the agent on this is how we like to handle this type of issue. But either way, right, the agent's going and saying, okay, do I have kind of a golden example of what I need to do, or have I seen things like this in the past? And you see this, it's either using RAG or it's using memory oftentimes, and we'll get into kind of what both those look like here. This one, right off the bat, though, is the RAG, or Retrieval Augmented Generation, for those that maybe aren't familiar, platform that's built into New Relic. And so what this basically allows you to do is point a document store, right, or rather point New Relic at the document store, and then put some guardrails up around what actually is indexed from that source. So as you can see here, this is a Confluence integration, and Confluence has its own query language. And so you can write out, or more likely copy and paste this Confluence query language here, which tells this connector only ever index the documents that kind of match these spaces or whatever it is. And then you set an interval, right, on at which you want this to reindex. And in this case, right, we're indexing a set of retro documents as we add them to this space. things get re-indexed, and the agent's kind of knowledge grows. This is a pretty powerful and flexible, right, solution to a lot of different things, right? We have customers, of course, doing this with their runbooks, with retros, but also kind of best practice documentation. I think somebody was even kind of indexing like an SRE handbook that was internal to them. Various things like that, right? This is a good way and very kind of like efficient and inexpensive, way of giving this, agent a growing body of knowledge. And then it will go and automatically start using these as soon as these connectors are set up, right? So that's a good kind of basis for bringing in this, let's call it unstructured data into New Relic, and then being able to associate that unstructured data to your more structured things like your entities, your entity relationships, the telemetry that's coming in through instrumentation. But it's not just like, you thinking ahead and indexing documents that allows this agent to kind of have a growing memory of the past, right? We have what we call long-term memory, and in this particular account, we've named Autopilot Gary 2 for some reason. But the what you're looking at is Gary 2's memories, right? And agent memory is actually a really interesting topic when it comes to IT operations use cases in particular, right? It's one thing just to say, okay, well, an agent's kind of like summarizing all of its past conversations and storing them for future reference. But when you're talking about reliability engineering, incident response, IT operations, that actually could be pretty dangerous because you don't want kind of bad context, bad conclusions, bad ideas getting kind of baked into this agent's memory base and kind of polluting, future conversations or leading people astray. And in fact, when we kind of started designing this memory system with a lot of our customers, many of them said, well, the first thing I want to do with Autopilot is bring in my really experienced SREs and have them kind of kick the tires on it, give it feedback, critique it, identify its weaknesses or whatever it is, and then be able to store, like kind of impart that tribal knowledge that's in their head to the agent and then have that kind of be available to everybody else who might be using the agent later. And so with our long-term memory system, right, we scope these memories to either a user level, account level, or organization level. And so you can imagine only your most experienced, right, your most trusted SREs or engineers or responders, maybe your incident commander if you have one, would have the ability to store organization scoped memories. And so they are the ones that are able to impart this good knowledge to sort of everybody through this agent. But you may also have cases where you have your New Relic accounts organized in such a way where you need memories that are particular to a specific account because it's a Teams account or whatever it may be, right? You can also give the permission to particular users to do account level memories. And then last but not least, right, any user can also store a memory for themselves, right? Like maybe they want Autopilot to respond to them like a pirate or something like that, right? They can do that without affecting everybody else's interactions with the agent. So it kind of contains that. And then critically, right, anybody with the right permissions can actually come in and delete any memory. So you could come in and kind of purge a user's memories, you could come in and purge organization memories, whatever it is. But as I mentioned earlier, right, what the agent is doing behind the scenes that I think is really fascinating with any of these memories is it's not simply just summarizing a response or a conversation and then making it available for recall later. What it's actually doing is it's actually parsing out what happened and then breaking things down into what it thinks are verified facts and relationships between them. So in this case, right, on a past conversation, it believes that a fact was established that just because it didn't find a deployment registered in New Relic, doesn't mean that a change didn't occur because somebody wasn't actually hooked up to New Relic change tracking, and so these deployments weren't occurring to. And then it'll apply this relationship to a particular service or a particular signal or a particular scenario. And so what it's going to be able to do next time is it's going to be able to say, well, last time I had a situation like this, there was actually a change that had happened that caused the problem, but it wasn't actually recorded as a change marker. So maybe the first thing I should do is sort of ask the user, are you sure a change didn't occur? Here's what happened last time, right? And you see all sorts of different, flavors of this kind of fact and relationship. In this case, it's identified that there is no alert condition actually that's been set up to target the store ad service, right? And so it's going to be able to incorporate that into things like its recommendations to say, hey, next time around, or you should really get an alert condition set up here, right? And then there's a standing rule. It's identified a standing rule. Somebody's imparted this rule. This, that an SRE has said always do such and such, right? And it can kind of build out these graphs. And so what ends up happening over time, either because you're explicitly telling the agent to via a little button next to the response, or as it kind of automatically goes along, is it's breaking these down into these little knowledge graphs, right, that it's going to be able to efficiently query, all right? And again, all of these can be managed by users with permissions to help, kind of control, the volume of memory, or if there's, somehow bad memories get in, all of that can be kind of disentangled as well. So yeah, I mean, it learns as it goes, Jemai. I mean, have you had situations where you wish this kind of tribal knowledge was being imparted to your team or anything like that?
Yeah, no, I think this is important, right? So as you're using Autopilot to respond to issues, it's creating relationships and facts, and it's learning how to better perform as an agent in the specific context to your account, you as a user, and with rules that you've set, right? So there's no more kind of like guessing game. The system can actually visualize and retain memories of past incidents, life cycles, and it's gonna ensure that you solve a problem for good, right? Versus having to constantly go through that same flow. We allow you to democratize knowledge, right? I'm sure in our organizations we have like those SREs that can always help, or those engineers that just know the complete system, and now you can share that throughout the organization through creating kind of like these new facts, leveraging Autopilot. And it's like having an SRE now on every engineering team that knows everything about your organization. And then it just makes it more efficient, right? So by being able to kind of like check past behaviors, analyze the information that it's learned, it's gonna help you get to resolution kind of like quicker. So it's extremely powerful. Yeah.
Definitely, yeah. It's interesting to see how it kind of evolves over time, with agent memories in particular. So yeah, I guess we're gonna kind of recap what we saw here.
Yeah. So quickly, right? We saw the Autopilot kind of like find a service that was having an issue. It's been able to analyze our entire environment and really get to a root cause and show me kind of like its work along the way. We allow you to keep the human in the loop, right? Being able to work with these AI agents, but have a level of control that's important for building trust within your organizations. Then as you're leveraging this new SRE agent, Autopilot, it's learning, right? So the more you work with it, the more relationships it's gonna create and get you to that reduced MTTR that we're all trying to get to, or those elusive 5 to 6 nines that organizations kind of like set as a standard.
Definitely. Yeah, and just kind of flashing this up here, right? We've got a lot of work streams happening. We'd love to engage with any and all of you on any of these as design partners, right? So we have, we're continuing to kind of invest in the core agent experience, but we're also building specialized agents for infrastructure problems, obviously including Kubernetes. We also have some Kafka skills and agents being developed. New Relic is actually one of the biggest users of Kafka on Earth, so we have quite a bit of expertise there that we're kind of baking in here. We have a new security agent as well that can identify security vulnerabilities actually in runtime, which is very helpful for, an engineering team says, we already resolved that vulnerability, but you can say, no, I still see it on production. And then it helps kind of remediate those. And then a variety of other things, right? Better generative user experiences where we can kind of take the pretty text-heavy view of today and break it more into like a Canvas-style view and things like that. So lots of stuff happening. Again, we'd love to chat with any of you about kind of what you'd like to see or what you're seeing elsewhere, or what you're building yourself, and just kind of share notes. But yeah, tons of good stuff happening here currently. All right, yeah, and I guess to kind of take us home, right? You know, if any of you are new like customers, Jemiah and I would both love to chat with you, get in touch with your rep, set something up. Also, check out our booth. It's number 5 upstairs. You can win some prizes. Also, the expert lounge, just kind of straight out there. Jemiah and I usually hanging out there. We'd love to chat with you after this or whenever you may stop by. But thanks so much.
Awesome. Yeah, thank you everyone for joining us today. All right, so I think that I'm going to keep the show rolling, and I'm going to bring up the guy that kind of like started it all, right? So let's welcome Justin Samuels to the stage, the founder and CEO of RenderATL.
Yeah.
What's up, man?
What's up, everybody?
You need this?
I think I'm good.
Okay.
Hopefully they can hear me. Mic check. Yep, I think you can hear me. Hey, everybody. Thank you for making some time today to be here during a particular very important ceremony. And number one, how are y'all enjoying the conference? Is everybody having a good time at the conference so far? Good. This is a very special moment, not just for me or the organization, but for my team. The reason why this is such a special moment is because it is when we are going to do our dedication and present them with their class rings. Rather than giving out a Letterman jacket or a plaque, everybody on our team who has been here for the last 5 years, when they hit their 5th year, we give them a class ring to then symbolize their commitment to the organization. I have on my class ring right here that then shows that I've been with the organization for over 5 years or more. So today you'll be able to see what those class rings look like, and you'll be able to see who has been here for 5 years or more. So without further ado, I'm gonna call out my team real quick. Come on out, Hank. Come on out, Alberto. So Hank and Alberto both have class rings as well. But Hank is our creative director here. Him and his team has made everything that you see here look beautiful each and every day, whether it's the graphics, whether it's the vinyls. Him and his team has made all this look good, including these beautiful jerseys that we have on. Can you give him a round of applause real quick? And then Alberto is our head of hospitality, where if you want to have a good time, that's the guy to go talk to right there. Hank, I want you to talk to them about what does the ring look like for this year.
Yes, so we did a lot of research and there's a lot of exploration around like what ways we can make each year and each ring unique to our team members who've been here for 5 years. So this year we explored some options around using rose gold. So you'll see some ways that we did some nice engraving, including some of our brand elements. And we also have a single gem on each of them. And the concept behind this is that we are celebrating 4 of our team members today, and we're all centered around one mission. So that ultimately equals up to 5. So 4 members, 1 mission, and just celebrating that. So I'm super excited for y'all to be able to see that. And yeah, it's gonna be great.
Amazing. And as you know, everything we do here is extremely intentional. Like you said, we have one particular gem in there. Ours has 12 in here right here. And we're going to keep everything very intentional that we do, that if you want to ask more questions afterwards, we're happy to break down what does each and every individual ring means. So without further ado, let's call out our 5-year ring holders for 2026. Come on out. So we got Eric Hayward, which is our Chief Operating Officer. Who's the next person? We got Sika, which is our right hand right here. Sika. Casey, this is our Senior Director. And Brianna, which is our Senior Director of Marketing. All right, without further ado, let's show them what we have.
Don't open yet. Don't open yet,
okay. That's what tripped me up. All right, and on the count of 3, Everybody open your rings. 1, 2, 3. All right, let's show the audience what they got.
Hold it up, hold it up.
If we could change the background wall to what the ring looks like, y'all.
Oh, we have it on the sides.
Oh.
Yeah, we have it on the sides, yeah.
Oh, I'm on the side. Perfect, perfect. All right, with that said, congratulations, y'all. Really, it means a lot that y'all held us down for the last 5 years. I really wanted to make sure y'all get honored in a huge way. This organization wouldn't be what it is without the hard work of y'all each and every single day. I really do mean that. Like, everybody on here, including y'all too, really made organization possible, and I wouldn't be here, organization wouldn't be here, or without the hard work of all of y'all each and every day. So please give yourselves a round of applause. All right, with that said, Alberto, take us home.
Once again, thank you all for joining us for the week of RenderATL. To the team here on stage with us, as Justin said, we are a family here. We have fiancés a part of the team, we have best friends, we have groomsmen, we have bridesmaids as a part of the team. It really is, truly is a family. It means a lot to me, it means a lot to us, and thank you all for sharing this and embarking on this journey with us at RenderATL. Let's please give it up for Eric, Sika, Casey, and Brianna. We're gonna join the front for a photo.
And on the side of the screen, you could use your app to scan and get double points right now. Thank you. Make sure you hold up your rings.
Yeah, get the ring up, Hank.
Oh, no, I got mine up.
Perfect.
Thank you, everybody.
Hello, everybody. Also, don't leave. If you are a first-time Render attendee, can you raise your hand? Would you like a freebie? Marketing has all the fun things. If you want a freebie, if you want a button, come up to the front and get your first-time attendee button. And if you have been here before, raise your hand. If you've been to Render before, I have something for you too. Don't worry. If you also want to come to the other side of the stage, please feel free to do so. For those who have been here before, you're going to get a black button. For those who your first time, you're going to get a pink button. Don't be shy. You can come up. I don't bite. I promise. Here you guys go. Hi. Have you been here before? There you go. Thank you. Oh, no problem. Are we gonna put the QR? Can we put the QR code back on the screen, please? Thank you guys. I would just like to say thank you all for being at RenderATL. We're always so glad to welcome new friends with us. And who's having a good RenderATL experience so far? Love it, love it. Awesome. So if you are the first time attendee on this side, if you've been here before, please come to my other side. Ooh, my back hurts, y'all. I'm not as young as I used to be when we first started Render. There you go. Hello, here you go. There we go. You've been here before? Here's a button for you. And one more. Awesome. So I'm gonna let you guys, oh, come on. I'm gonna let you guys get back to the show of all of our amazing technical talent. We really do have some of the best speakers in the world here at RenderATL, and we're so glad that you are one of our amazing attendees. So we will be chatting with you soon. Thank you for being at RenderATL. Thank you for sitting and being patient with me. And don't forget to tag RenderATL because I am in marketing. Please make sure you're tagging us on social media. Bye, guys.
Hello, everyone. Just wanted to say don't leave. Text your friends, bring them in. Angie Jones will be speaking at 1 p.m. See you soon. Hello again, everyone. Hello again, everyone. Hello. I am very, very excited about this next talk. It's talking about why your AI agent still sucks. Because it does, until you hear from Angie Jones, VP of the Agentic AI Foundation. Give it up for Angie.
Hello, 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 everyone. Why y'all laughing? No, don't yell it out. What's wrong with you? All right. So, your team has just hired an AI agent. Meet Agent 10X Dev. It never sleeps. It doesn't have to go to your pointless meetings. It studies all the public code available, more than any one person could ever read in a lifetime. So the agent's first mission is to ship a checkout discount feature to production, right? But before we send it off, think about what that would involve for your team. What does someone need to do before you would consider a feature shipped? If we think about it, writing code is only one part of the mission, right? The agent has to find the ticket. Are y'all using Linear or Jira, right? Do you use GitHub issues or what? It has to find the right repo. And then within that, it needs to follow your design patterns, write tests the way that you all do. Are y'all using feature flags? How would the agent know that, right? So let's say that it figures all of this out. What about the review process? How do y'all know where to check it in or what it should look for or how it should do this, right? So every team has its own version of this process. And I'm willing to bet that your team does not have all of this written down anywhere, right? Because this is what we call tribal knowledge. So yes, Agent 10X Dev, it knows how to write software, but it doesn't know how your team ships software. So some of what it needs is basic project context that you can put in something like an AgentsMD file, right? So that's like where the issue tracker lives, like where the front-end code is versus the back-end code, how to run the test, stuff like that. So the agent will have this context whenever it works in your repo, but it's not enough. In fact, let's see what happens when AgentsMD is all that the agent has to work on. So the agent wrote the code, it got the feature working in minutes, the test passed and everything, and you are almost impressed until you look at the UI. You see that it looks like every other AI-generated interface you've ever seen. It got the agentic purple and everything, right? So the agent even used the component library that your team stopped using 3 years ago because y'all never took it out the code base. It built a custom modal, who knows why, even though your design system already has one. So yes, technically the code works. Sure, we can argue that the agent made some reasonable choices based on the information that it had, but you can't ship this, right? And if we're keeping it a buck, it's your fault. Because you didn't give the agents the skills that it needed to be successful. And what you're actually doing is relying on generic, general training knowledge to fill in the gaps of your team's specific practices. And that's never going to work. So you need agent skills. Agent skills are a way to codify your team's tribal knowledge so that your agent knows how to do things the way that you want them done. So your workflows, your conventions, the decisions that your team has already made. Without skills, your agent is like this superhero who doesn't quite know how to use the powers effectively. So it's just messing stuff up. It's likely making more work for you and your team versus actually helping. And this is why you kind of write off AI and thinks that it sucks. Skills give your agent superpowers that it needs to successfully complete those missions that you needed to. All right, so let's give Agent 10X Dev its first skill. So agent skills are an open standard that most of the agents support now. So there's no framework to install, there's no model training that you need to do. A skill is simply a folder, and it has a skill.md file inside of it. And we're gonna add this folder right inside of our repo. And what that does is that makes this a local skill that's for this particular project. That means that any agent that works in this repo has access to this skill. So this is now a shared skill amongst the team, and it lives right alongside the code. But because it's local, this won't work for any repo other than this one, right? This can't be your company's global front-end skill that every team uses. If you want something like that that works across different projects, then you need to install this in its own repo or a repo where you have other skills. But if it lives within a project itself, then that's considered a local skill, okay? And the ones outside of that, anyone can download and they can use them as a global skill. All right, so the information at the top of the skill.md file, this identifies the skill. So we have its name and description, and then the rest of this file is going to contain the instructions that the agent should follow. So for our front-end skill, we can organize these instructions around things like what to do before the agent starts coding, right? How to implement the feature, what to avoid, that's a good one, and then what to check before finishing. So that's a complete workflow. So you go from just telling the agent to, hey, ship a feature, to actually providing instructions on what shipping a feature entails, right? And more specifically, how you want that done. So a useful skill will give the agent a process for the workflow. For example, before coding, we want the agent to inspect the product instead of just guessing, right? It should find similar features and check the design system first. During the implementation, we tell the agent how our team handles common interface decisions like states or like accessibility. We should also explicitly call out what the agent should not do, like don't recreate components that we already have. Don't introduce new patterns in our code base without a reason, right? And this helps the agent understand what liberties that it has versus what is non-negotiable. You do not want to let these agents just YOLO in your code base, all right? Then, before the agent gets to call this done, it should check the screen sizes, it should check things like keyboard behavior and focus states. Also, very important, whether this actually fits the look and feel of the rest of the product. So what we've done here is we have codified the guidance that someone would normally perform during a review cycle, and we've given it to the agent before it even starts. That's a superpower. Notice, though, what we're not doing. We're not explaining how to do every step, right? We don't have to tell the agent how to open a browser, for example, or how to compare two screens, stuff like that. It knows how to do that already. So your skill should focus on the parts that are specific to your team or the parts that the agent wouldn't necessarily know. Now, Agent 10x Dev, it tries that front-end work again. But this time it has the front-end convention skills. So before writing the code, now it's actually looking for the closest existing feature. It's reviewing the patterns that our team already uses. It's checking the design system before creating anything new, reusing our existing components, and handling the interface states that the team expects. So this is the same agent in the same model, right? That didn't change. The difference here is that it has the process and it has the boundaries that was missing before. All right, so the front end looks right now. We need some tests, yes? I love a good test. So this is a front end feature, so I would love to have some browser tests. Our team doesn't have a process documented for how to do end-to-end tests or how to write them. So we could technically let the agent handle this itself. It does know how to write end-to-end tests. The problem here is that LLMs are not consistent, right? So you don't want your agent to do this differently every time you write a feature. So that's a good reason to provide it with the skill so that anytime it writes the test, they're done the same way. Now, end-to-end testing is not unique to our team. So before we build a skill from scratch, we can first go and look and see if there's already a skill available for this. And that's the beauty of skills. Like, they're reusable, they're portable, which means they can work in any agent that supports skills, so you can share ones with your teams, literally with anyone in the world. And you can also use ones that people have already made. You can just grab them from a marketplace. So skills are usually published in Git repositories. And there's marketplaces out there like skills.sh. That's the website. Skills.sh, and this makes the skills easier to find. So you can search for anything, for example, browser testing or end-to-end testing, and you'll see several skills that might give your agent the process that it needs. So for each result, we see the skill's name, we see the repository it comes from, we see how many times that it's been installed, and the install count can help us see like which skills other developers are using, right? But we still want to look more closely before we choose one. So let's open the first result and let's see if it gives us what we need. So you get all sorts of useful information at a glance, which can help you decide if this skill is worth using. So the summary tells us like, oh, this skill covers Playwright and Cypress, right? Along with test structure, accessibility, responsive design. It'll even debug flaky tests. So you're like, okay, that sounds good. And then it also shows on skills.sh, it shows the actual skill.md file. So you can see it for yourself. I've abbreviated it here on the slide, but on the website, you will see the full contents of that file, which contains the instructions that the agent would receive, right? So we want to make sure that the process actually matches the workflow that we're looking for. We can also, on that right side, we can see the repository where the skills come from, which has more than 38,000 GitHub stars, and the skill itself has been installed more than 20,000 times. So these are good signals that the skill is trustworthy, but it's important to remember that skills actually change how an agent behaves, and that agent usually has access to your system, right? So every superhero story needs a villain. Ours could be hiding in one of these skills that we're about to trust. So before you install anything, you need to check the security audits. Now, skills.sh has regular security audits of the skills, and this one passed 3 independent audits. But to be extra careful, I always go ahead and review the detailed results of each of the audits. So again, it shows the 3 independent ones for each skill. All 3 have passed. Gen Agent Trust Hub, it found no malicious intent or risky operations. It checked that the external libraries actually fit the skill's purpose versus just like installing random ones that might be fishy. It makes sure that it's properly handling credentials and stuff like that. The socket one checked for things like prompt injection, that's important, or other hidden code that might be within a skill, right? And make sure that the skill isn't doing anything that would trick the agent into stealing your data, for example. It also makes sure that it's not instructing the agent to like trust untrusted packages or install those or misuse tools or stuff like that. And these audits give us useful evidence about how secure a skill is. So if you're comfortable with this and the skills meet your needs, now you're ready to install. So skills.sh gives us the exact installation command to use the skill CLI. So to run the skill CLI, we always start with npx skills. No matter if you're installing, you're updating, you're removing a skill. And then to install, we add the add command. We use the add command, which runs the skill CLI, and this begins an installation. And then next, we provide it with the GitHub repository where this skill lives. And that repository could contain several skills. So the skill option tells the CLI which skill you want to install. All right? So when we run this command, the CLI is going to ask us which supported coding agents should receive this skill. And it's kind of based on which ones you have installed, but there's like dozens and dozens of them available. So we can install this same skill for things like Claude and Codex and Goose and Cursor, GitHub Copilot, many others. And you can also specify if you want this skill installed locally or if you want it globally. By default, it'll be local. So wherever you run that command is where it would install it, unless you specify like the -G command, which would say, okay, I want this to be global so that I can use it anywhere. Once this is installed, our agent 10x dev can finish with the mission. So Agent 10x dev, it's used this new skill, it's wrote those end-to-end tests, and now the feature is almost ready to commit. But I don't want to check in a bunch of AI-generated code and then put that burden on my team members to review that code, right? That's rude. We don't do that. So I should review the code first. But here's the problem. I don't want to review AI slop either, right? So what I actually want is for the agent to clean up its own mess, get it to high quality, and then I will review it. Now, I'm not going to go to the marketplace for this one. Anyone have an idea of why I might not go to the marketplace for this one? Anyone? Huh? Too general? Yeah, right? So code reviews, the agent already knows how to do a code review. But again, that is based on general data, right? So most teams have a specific way that they want their code review, or they have specific things that they want to look for. So for something like that, you're better off writing it yourself, all right? So do we create this one locally or globally? Who says local? Who says global? Very good. So local. We're going to do that one local because we want to use this for this specific project. If we wanted to use it across the whole company or for multiple projects, we could do it globally. All right. So before creating the file, this is important. We need to think. We need to think about what's the process that we are trying to codify. So a skill should be rooted in how you or your team actually work. Don't just let the agent write the skill for you, because what's going to happen is the agent is going to simply put its general training knowledge in a file. Why would you want that, right? That defeats the purpose of creating a skill. So you want to capture your specific process, not just what the agent already knows. And the agent can help you. I'm not saying like you have to write everything by hand, but what I'm saying is don't let the agent lead. You have to guide it, right? Sometimes what I do is I'll finish a session where I'm guiding the agent throughout that session to do this and do that. And at the end of that session, I go, okay, I taught this agent a lot. Make that into a skill, right? Anthropic has this skill creator skill that you can use. But again, you're the one with the context, so make sure like you are guiding the agent and you're deciding what goes in that. All right, so for our skill, we want the reviewer to look for the problems that our team cares about. So those priorities need to go in the skill MD. And I've also noticed that an agent is biased towards the code that it writes, right? So to mitigate this, we want our agent to have a separate adversarial review agent to do the review, right? So that should work without context or without the assumptions that our coding agent made when it produced the code. And again, I do not want to be involved in this process. Take the human out of the loop, me. So I want the coding agent and the review agent to work this out amongst themselves. And so the coding agent would tell the review agent, review, let me know what I need to fix, I'll fix it, and then call another sub-agent, not that same one, a new one, and y'all just kind of repeat this process until everybody is happy, and then call me, all right? So now we know what we want. We can create the skill. We thought about it. To create a new skill, we use that same skill CLI. So the command starts with npx skills init, followed by the name of the skill that we want to create. So the CLI will create a folder named recursive code review, because that's what we put in the command. And inside of that is going to be a skill.md file, and that file starts with that front matter we talked about. So the required fields there are name and description. Those are kind of like the only two most agents support. There's a few other optional ones that you could put, like author and version. Most agents just skip that, and so that's for the humans to read if they want. If you're trying to put something important outside of those two fields, your agent is not going to read it, just a heads up. And then also the generated description. So that'll be just like generic placeholder text that you're going to need to replace. And then there's a section to add the instructions. So skillmd is the only required file that you need in the agents, according to the agent specification. But a skill can also have subfolders. So you can have things like scripts. So a script subfolder is going to contain like executable files that the agent can run. You can have a references folder. This is additional documents or examples that the agent can use to better understand what you want. An assets folder, so you can put files that the agent might need in order to do his job. And then you can add any other folders that you want. You just kind of, in that skill.md, point the agent to those other folders to say, hey, if you need like this sort of information, look in that folder. Now, let's change the placeholder description to something that reflects the skill's purpose. And then for the body, we outline the step-by-step instructions on how to perform the recursive adversarial code review. All right? So this seems clear. Shall we ask our agent to use it? Yes. All right. So when prompted to review the changes before committing, the agent did the code review itself, and it decided, looks great, beautiful. But our skill explicitly told it to trigger a sub-agent and have it do the review. So how come the agent didn't use the skill? Let's figure out why. Agents follow this discovery, activation, and execution process when they use skills. So when a new session starts, the agent loads lightweight information about every skill that's installed, right? So it sees the name, it sees the description, and also the location where that file is installed. And this serves as a table of contents that the agent has available. So here are all of my superpowers that I have, right? But you got to keep that brief. And then every time the agent gets a task, it compares that task with the available skill names and descriptions. And if one looks relevant, then the agent activates it. And only after activation does the agent read the body of the skillmd file to follow the instructions, right? So this process was intentionally designed this way to protect the model's context window, because if the agent loaded the body of every skill that was installed, all of that context would be in your session before you ever get started. So you're using up a lot of your space already, okay? So that's good, but the trade-off here is that the instructions that are in the body cannot help the agent actually determine whether to use your skill or not. So it's imperative that the description catches the agent's attention, right? The description is what's going to trigger the agent to use the skill. So I write my descriptions as bait that I want the agent to take in the right moments, right? All right, so agents, where am I? Y'all got it? All right, so our description was too generic. That's why it didn't trigger the agent. So the description says, improve code quality through recursive review. And then we asked the agent to review our code to submit. So if the agent doesn't think it needs to improve code quality, which it thought it looked great already, there was no need for it to get this skill, right? So what this is doing is saying what the skill is meant to improve, but not clearly when the agent should use the skill, and that's the key. So what you need to do is give it an explicit order. I start mine with use this skill when. That is now a directive, right? And then I name the situations that I expect. So I put, hey, if you're reviewing uncommitted changes, if you are reviewing anything before a commit, if you're preparing a pull request, then use this. That is now an action to take, right? And this wording overlaps with how developers are going to request this likely, right? And so we're giving the agent a clear reason, given a task or a prompt that it gets from a developer. Now we're saying, here's a good reason to use this skill. And you can also test whether a description activates at the right time. So for example, Anthropic Skill Creator has this description optimization eval that generates about 20 queries for a skill, and it tests to make sure like the ones that should trigger it actually do, the ones that don't, it doesn't. So you could always do that as well. All right. So the description helps the agent choose the skill automatically when it thinks that it matches a task that has been given, but sometimes we already know which skill that we want to use, and we don't want to leave it to chance that the agent, picks up on our intent. So you can invoke the skill directly by entering it as a / command, right? So here I type / recursive code review. So / and whatever the name of the skill is. And this is going to explicitly invoke that skill that I want the agent to use. And what that does is loads the full skill.md into the context, all right? So make sure that's actually what you want to do. And then there's still a bit of progressive disclosure here. For example, if you had like additional reference files or something like that in that skill folder, those are not loaded in the context, only the skill MD, and then the agent still would decide, okay, do I need to look in the reference? Do I need something out the assets folder or whatever, all right? Okay, so now our review is complete. The agent did it right this time. We can commit the changes and we can ship to production. So now that you have the basics of agent skills, I do want to share some design principles that I've found very helpful, and they seem like really effective. So again, the most useful ones come from real experience. So when designing skills, you want to be sure to capture how an experienced professional will solve this problem. And this could take a few iterations to get right. Don't think like you write it once and then it's perfect forever, right? It's really hard to do a complete brain dump of how do I work, in a single setting. So as you use your skill, pay attention to like what the agent might still be messing up, or maybe it's something that's unclear, and you can always just update the skill accordingly. Also, when designing skills, aim to make them modular so that they can be used as part of bigger workflows. So I often have workflows where I'm using multiple skills within a session. For example, I have a skill that teaches my agent our company's brand guidelines, right? That skill, it doesn't do anything, it doesn't take any action, it simply outlines what our guidelines are, it provides like our fonts and our logos in the assets folder, and then I'm able to chain that skill with other skills, like wants to create new web pages, or like new marketing flyers, or blog post banners. Those are 3 separate skills that each one of them could use that brand guideline skill as well, right? And if it wasn't its own modular skill, those 3 skills, I would have to copy what I have in that brand guideline to all 3 of those other skills, and I don't want to do that. Skills are also only one part of the agent's context window. You also have the system instructions that come with the harness, right? You have user prompts, you have MCP servers, you have any other context that you shared throughout this session. So skills should only provide information that the agent actually needs, right? You want to use concise guidance, you want to use progressive disclosure so that you avoid overwhelming the context window. And remember that the skills are for things that the agent doesn't already know. Don't explain common definitions or concepts within the skill. You're basically just wasting your tokens. If you find that the body of the skill MD is getting too long, like maybe it's over, my target is like 500 lines or less. If it gets over that, then I consider moving things out into some of those subdirectories and just putting a pointer to it, okay? Global skills. These should work across different users, different repos, different agent harnesses. So someone should be able to install a global skill and get value out of it without needing to recreate your entire setup first, right? So avoid relying too heavily on things that are specific to a given harness, right? Sometimes I see people put a Claude Code specific command in their skill. Now I can't use that in Codex, for example, right? And it's definitely fine for the skill to rely on things like a specific MCP server or an external tool or a framework or something. Just don't make the skill responsible for maintaining that dependency, right? The dependency should be bundled and managed through plugins rather than the skill itself. Now, the reason you're even creating a new skill is because you have an opinion of how something should be done. And you can't guarantee that your agent is going to do it that way. So bake those preferences into the skill. If the team already has a preferred way to do something, then the skill should reflect that knowledge directly. Also, agents are naturally inclined to improvise, right? They want to take shortcuts. Sometimes we think it's because they're lazy, but if we give them the benefit of the doubt, maybe they're just trying to find the most efficient way to help you, right? But this can break your workflow if you have specific steps that are required, and that might be for reasons that are unknown to the agent. So your skill should define explicit rules, like required behaviors, forbidden actions, so that agent knows where the flexibility is and where is it, okay? So I design my skills as a contract, not a suggestion. In some parts of your workflow, people miss this part. Some parts of your workflow may need to be deterministic. So I often tease folks that automation is not new. You know, we were doing this before we had AI. We've been writing scripts for a very long time, and we can still do that when we're using agents. So when designing your skill, take a moment and think about, is anything you're asking the agent to do something that could just live in a script? Like, I don't need reasoning for this, right? I don't need judgment for that. So one, it'll save you some tokens. And then two, you know that you're going to get the same result out of that every time. So if it's anything that you're like, no, I need this to be this way. A lot of times I use it in something like scoring or something like that. Like, I don't want to run a scoring thing against something and then I get one result this time, and if I run it against that same thing, I get a different result depending on the agent's mood, you know? That's not what you want. So that sort of thing you can put in a script. And then also your skill should be designed with security in mind. So I have a skill that triages one of my open source projects, which means that the agent is consuming input from untrusted actors. So this increases the risk of things like prompt injection and data leaks, right? So when your skill guides your agent to interact with systems or content that you don't fully control, you need to ensure that the agent is actually validating risky operations, that it requires human approval for destructive actions and stuff like that. All right, so Agent 10X Dev started with a mission to ship a feature to production. It had access to the code, it had access to the tools, but that was not enough. It still needed the team's processes and preferences and rules, okay? Agent skills gave our agent that knowledge. So when your agent knows what to do, but it still seems to suck, you can give it skills to succeed. Thank you so much.
That was so good. Thank you so much, Angie. Okay, everybody, stick around. Call your friends. Our next talk starts at 1:45. See you soon. Hello, everybody. Hello, everybody. I want to give you an intro to this next talk, which is about vibe testing and how you should stop doing that. Please welcome Jim Bennett, who is a Principal Developer Experience Engineer at Arise. Give him a warm welcome.
All right. Hey, everyone. So, quick show of hands. Who here trusts AI? Not seeing any hands. Yes, I like that. I like that. Because, and let's be honest, AI sucks. We agree? We agree. Yes, okay, clap. I like that. Yes, I don't work for a hyperscaler. I'm not trying to hype up AI. AI sucks. We know this. Now, one thing I love about giving these kind of talks is I always want to come up with a real-world example of AI doing something dumb. And it is so easy to do. I actually found one on Friday I was going to use, but then I found one at 11 o'clock this morning that I decided to use instead. So someone here using an online order chatbot, trying to get information about a particular order. The chatbot did not understand the Blackberry lemonade on their order. They literally had to write full brand name Blackberry lemonade seltzer water for the AI to understand it. Now, who's seen these kind of things across social media on a daily basis? Yeah? We all see this. We all see AI doing terrible, dumb things. This is why I keep saying that AI sucks. And I actually think it's important that we all embrace this idea that AI sucks, because if we start from the hype cycle of AI is amazing, then we end up building terrible systems. If we start from the perspective that AI sucks, then we're going to start putting the guardrails and tests in place that we need. Now, to me, there are two big problems when it comes to building AI applications. Two big problems. The first one is you don't know what your AI agent is actually doing. Now, for those of you like me who built code in the before times, like more than a year ago, we built deterministic applications. We could read the source code, and we could understand the logical flow of our applications. We can understand what parameters were being passed to function calls. We can understand the if statements and for loops and all that kind of stuff. But now we've outsourced our application logic to LLMs inside our AI agents. We tell our agent, here's the tools you can do, just go off and do it. And the LLM decides what tools to call, what parameters to pass, whether it's going to call a tool well, whether it's going to call the tool badly. So we don't really know at any one moment in time what the agent is actually doing. We don't know. And the fun part as well is it's non-deterministic. So even if we stick breakpoints and debug through our application, the next time we run it, it's going to do something completely different. Now again, those of you like me who were coded in the before times, the hardest bugs we normally had to fix were race conditions, essentially when our application was running in a non-deterministic fashion. Now, AI agents run in a non-deterministic fashion, so everything we do is that hardest class of bugs. So one, we don't know what our agent is doing. And then two, the other problem is we don't know if our agent actually works. It's actually very, very hard to tell if our agent is working, especially if we kind of just vibe it a little bit, prompt it with a couple of prompts, and see what happens. Now, there's a great quote from Rita Mae Brown, often misattributed to Einstein, that says, insanity is doing the same thing over and over again and expecting different results. Now, the Jim Bennett version of this is AI engineering is doing the same thing over and over again and expecting different results. Because let's be honest, we do. We can't test with the same prompt every time because we will get different results. And so we don't really know if it's working or not on a regular basis. These things are non-deterministic. Plus as well, when I say work, what does work mean for an AI agent? It could sound convincing, but not work. In that first example, it worked when you gave brand name Blackberry lemonade sparkling water, but didn't work for Blackberry lemonade. There's nuance that could be there. There's hallucinations that could happen. There's so many things that could go wrong. So, example for me, I was recently diagnosed as celiac, can't have gluten. And if I ask Claude, is there gluten in oats, yes or no? The answer is no. Sweet, I can go and eat oats. Except there's nuance because there can be cross-contamination. And so the answer could be correct, but wrong. And that's what happens when we start having natural language interactions with applications. We kind of get so much more fuzziness with everything that we do. So I'm going to try and do a quick demo. If the Wi-Fi is on my side, and unfortunately, because of the screen setup, I have to type here and look there. So I've got an example here. This is an application I've built for a toy shop. Okay, and I'm going to ask my agent a couple of questions. Show me coding toys, for example. This is the kind of thing that a lot of people build chatbots for. Interact in natural language, we get a result. Okay, here's some coding toys. Coding robot buddy, yep, okay. Coding board game, yep. Snap circuits, is that coding? Maybe. Gear and chain reaction set, is it coding? Maybe, maybe not. Let's just try another one. Let's go, what construction, it's really hard to type by this. Construction toys do you have for a 9 to 10-year-old? I cannot type when I'm peering at a screen down there. Sorry, give me 1 second. Okay. Let's see what this comes up with. Agent's doing its thing. Okay. Looks good. Architect building set, age 8 to 99, robot builder. Yeah. Oh, here's an interesting one. Architecture brick set, ages 10 to 14. Is that ages 9 to 10? Yeah, we're kind of on that cusp. So this is kind of an example of, is it working? What does working mean? So a couple of examples here. We will come back to these in just a second. So let's start by thinking about how we can solve these two problems. So the first thing is we don't know what our agent is doing. How do we know what our agent is doing? And the answer is tracing. So who's done open telemetry, instrumentation, tracing? Okay, see a few hands. We can basically do that with AI applications. We can literally turn on some form of open telemetry, similar kind of instrumentation across our applications, and start to build up a hierarchical picture of what the application is actually doing. And we can kind of see the decisions, for want of a better word, that the LLM is making. This is kind of our debugging step. We can kind of see on an individual interaction basis what's happening. We can get extra information like how many tokens are being used, latency, all that kind of stuff. In fact, let me just bring up an example of that. So this is one I prepared earlier. Sorry, the Wi-Fi is being not on my side today. Sorry. Give it a second. The curse of live demos. There we go. Cool. Here we go. So this is literally what I've just done. I asked my agent, if I scroll down here, show me coding toys, and it gets the results. And this is the kind of breakdown of actually the flow that happened. So it called Anthropic, the LLM. It called a tool. It called a tool, brought everything together. Now, if I dig into this, for example, this tool call here, it passed a category of coding, got any results? No, doesn't like it, didn't get any results. Nothing came back from there. So it called it again, passed coding as a keyword, got some results. So I can start debugging what my application is doing, kind of see in that trace what it's doing. Now this trace, just a quick note, OpenTelemetry kind of supports the ability to trace AI applications. There's a new standard coming, GenAI Semantic Conventions. It's currently in a committee. It's taking a long time. It's not quite set in stone. I'm using something called Open Inference, which is an open standard donated to OpenTelemetry that has all the details you need and is in production and has instrumenters. And literally, I can drop like one line of code into any framework, and I can build up this level of tracing. So really powerful to get this indication of what my application is doing. Now, the interesting thing here is I'm seeing that's calling the tool once, getting no results, and calling it again. And this actually is a problem in my application that I wouldn't know if I just tested on vibes. Yeah, it was bringing back coding tools. Sweet. But actually it's making 2 tool calls. And it turns out that, based off a study done by Shopify, every 100 milliseconds it takes extra to bring back a product reduces sales by 3.5%. Amazon, Walmart have found similar statistics. So the fact my application is calling the tool twice is going to reduce my ability to sell toys. So it works. Ish. I could be losing money, but it works. So again, if I just tested on vibes, I wouldn't know this kind of information. So it's important that we capture this level of data. Yeah, there's a real cost to it taking a long time. There's a real cost to using extra tokens. OK. Now, that's how we understand what our application is doing. But really, let's dig into that does it work thing. Now, who's heard of testing? Yeah? We know what testing is? We know what QA is? Yeah, well, in the AI space, we're fancy. We call it evals. So if you ever heard the term evals, it's testing. It's exactly the same. I'm sorry that somebody came up with a new word to confuse you. Evals is basically testing for AI applications. And evals is how we determine if our application works. Now, evals come into multiple types of categories. When we think about traditional testing, we would code up unit tests, we would code up integration tests, maybe code up UI tests, and then have like humans doing exploratory testing, manual testing, all that kind of stuff. Similar way with evals, we have multiple ways of doing testing. We do not do it the human way on vibes of just typing things into a chatbot and seeing what comes out. First thing we do is code. Literally, we can write deterministic code to check the output of the LLM. So if you're checking, is my LLM going to spit out structured JSON? Is my LLM going to spit out text that's too long, too short? Does it have client data that shouldn't be there? Anything you can test deterministically, you can just write basic code like a unit test and do an eval. So fun, so fast, boring. It gets more interesting when we start doing what's called LLM as a judge. So this is where we use an AI to test the AI. Now, obviously, sounds a bit odd. You know, we're saying the AI doesn't work, the AI sucks. We're now using another AI to test it. But actually, it turns out, based off studies, that the AI is as good as a human at testing an AI. Conversely, it is as bad as a human at testing AI. But it is as good. So rather than have humans manually checking every single output, you can prompt an AI to do this. Now, where the AI wins is not necessarily that it's better, but it scales. If you're doing 10 traces a day, a human could check that. If you're doing 10 million traces a day, no chance. So you scale that through an AI. You get the LLM to do the testing for you. Now, the next way, this is kind of where we're getting into the realms that's kind of quite new way of looking at it. It's code plus LLM. We have a trace. Traces can have a huge amount of data. You may not want to pass that data to your LLM judge, so you can run code over that first and then pass the output to the LLM judge. You can redact client information, just pull out tool calls, whatever it is you want to do. So that kind of allows you to do some manipulation. The new hotness, to quote the classic movie Men in Black, is harness as a judge. So this is a thing you'll hear more about really kind of over the next year or so, is we're moving from just doing an LLM, where you have a single prompt, to a harness. And by a harness, has anyone used like Claude Code? Yeah? Imagine if Claude Code was your judge. It's basically that. Claude Code, Hermes, Pi, OpenClaw, whatever, you have a harness doing the judge. And the harness can then dig deeper, it can make calls to APIs, it can write code, and kind of give you a really deep analysis. Now, as we kind of go through this set, the speed goes down and the cost goes up. Code, fast and cheap. LLM as a judge starts getting expensive and slower, and when you get finally down to harness as a judge, that's very expensive and very slow. But obviously, the quality you get out of a harness is better than an LLM, and so on. Now, we're just going to focus on LLM as a judge for now, just kind of give you a quick illustration of that. So let's have a look at an LLM as a judge idea. So I've got an evaluator that I've set up. Come on, internet, be my friend. So here's my evaluator here, and it literally is a prompt. This is a prompt. And the prompt says, you are an AI evaluator that detects a specific failure pattern in an agent's tool call history. So I've noticed that I had that tool call issue where it would call the tool with no parameters, sorry, with one parameter, not get the results, call it with different parameters. And I want to optimize for that. And this LLM prompt actually does that. So it says that the failure pattern it's defining is a tool is called with specific parameter in its input, returns no results, and is then called again in a way that indicates the agent fell back to a less specific or differently structured call. This includes parameter removal, parameter type substitution. So this is actually saying this is a known issue we have inside our application. I want you to detect this issue. And this prompt gets past the LLM. We inject the entire trace, and then it uses that, it follows the set of instructions, and then it outputs pass or fail and an explanation. So this is kind of where the trace becomes really, really powerful. Because to do an eval, we're not just evaluating the final output of the agent. It's not just a case of, we ask this question, we get this result, we're just evaluating the result. We need to potentially evaluate every single step in the process. The eval needs access to all the available information, and that is in the trace. So the trace up front is not just about capturing information that you're going to manually look through. The trace is providing you with the raw data that your eval works upon. That is kind of really, really important. You cannot, as a human, review 5 million traces a day, but you can use the evals to do that because the evals review your traces. Really, really important. And so if I run this, I'm going to just go back to my code here. And because internet being slow, where's one that I did earlier? Any other British people in the room in Blue Peter fashion? Here's one I prepared earlier. No? No other Brits? Fair enough. But this is one I ran, and this failed. So this is that same, we call the search products twice. And here we go. It failed. It ran this live. It failed. And it says, what is it? First call tool, search products with args, category coding, result empty. Second tool call, search products with args, query, coding, programming, STEM, keywords, whatever. Result 5 products found. So this has identified that tool issue. And this is a very generic one that's just looking at any tool call, not just our search products call. So I can apply this across any application to look for, is my agent running in the most optimal fashion? You hear people talk about like agent trajectory and kind of other terms for this. But essentially my goal here is, am I being efficient? Am I getting my user the answer as quick as possible with the least amount of tokens as possible? So that's kind of the result of my evaluation. And I can see very quickly pass or fail. Where are we? Back over here. Now that's kind of a cool debugging tool. It's great. We love doing this. But how do we actually do it? I'm saying, oh yes, write a prompt. But obviously, if we know that AI sucks, write a prompt, is that also going to suck? So there is kind of a defined process that you should take to kind of get to the point where you have a good evaluator. So the first thing is you need to know what your application should actually do. A step a lot of people seem to miss out. But before you can write any form of tests, you have to understand what your application can do. So back in the days when we did, more than a year ago, when we built non-AI agent applications, we would write requirement specs, and we would build acceptance tests for those requirement specs. I'm seeing some nods there. It's like, yes, that's what we do. Same thing here. I cannot build an eval unless I know what my application should do, and this is kind of a bit extra, what it shouldn't do. The thing with natural language interactions, if you're using like a chatbot or similar, is it's very easy for people to push outside the bounds of what your application should do. For example, there is a GitHub repo with a tool to connect your coding agent to Chipotle's service bot. Yep, this bot designed to help you when you order your fast food from Chipotle. You can now use that because nobody bothered to put a check in there to say, don't answer questions about programming in Python. Yes, it's a thing. Honestly, there's a whole project where people are hacking different support bots to get free token usage. So in your requirements, what it should do, what it shouldn't do. So you can kind of put those hard gates in. Then you capture the traces. Now, if your application is in development, what you need to do is think about what your users will try and do with your system. You know, I'm looking for coding toys, I'm looking for STEM toys, reverse this linked list in Python, you know, all that kind of stuff. Think about what they do and build a synthetic data set that contains the kind of queries that a human's going to do. If your application is already in production, great. Turn on traces, you can capture data. So either capture traces from synthetic data or real data. That gives you an overview of what your system is doing. And then you involve humans. Who's a human? Anyone here a human? Anyone here not an AI agent? It's me. Yes, we have people. You need to involve humans and start reviewing the system. Yes, you can use harnesses and agents to help with this, but a human would start reviewing this. Now, this session is not long enough for me to dig deep into the data science aspect, but essentially you do what's called open coding, followed by axial coding. You look for ways in which the application is not compliant with the requirements that you have. You know, humans can review this, ideally domain experts. You know, my wife, for example, is a teacher. She's seen jobs advertised where they want teachers to review the output of ed tech systems, not tech people. They want domain experts. So get the domain experts to review it and just note that, oh yes, this is returning STEM toys as well as coding toys. I said 9 to 10 years old. It's got 10 and above. Stuff like that. Kind of build up that list of errors, and then you can refine those down into a number of themes. You ideally just want 2, 3, 4, 5 themes, and those themes become the source of your evaluator. And then you build your prompts against those themes. The theme is, it's generally calling tools in an incorrect way. I don't care about just search products. I care about all tools. It's generally not doing the best trajectory in tool use, so I'm going to build an evaluator for that. And then the standard kind of data science rules apply here. I've got an evaluator. I have a data set. You'd capture 200, 300, 500, 1,000 traces that show your evaluator where it should fail, where it should pass. Use those to test it, use some as few-shot examples, training set, testing set, split, all that kind of stuff. I could spend hours digging into the stuff behind this, I'm not going to. But essentially, you build and you test your prompt for your LLM as a judge. And you get to the point where it's working. And you get to the point where you can actually see how effective it is against your golden data set. And then these become assets. Your golden data set, your prompt becomes kind of assets in your system. Now, as I said, human review, humans are important, but harnesses are really, really good at doing this. So the tool I was showing earlier, it's one built by the company I work for. We've actually got an agent built in where you can literally say, help me create evals, and it will help you find those kind of groupings, help you find those errors based off the requirements that the system knows that you want. You still need a human to review it, still need a human to check it over, but when you're manipulating large amounts of data, coding harnesses can really, really help with this. Now, once you've got your LLM as a judge prompt, once you've got your evaluator, it's time to start using it. Okay. So the first thing you do, you run your evaluator against your application, then you fix it. Yay! We're done, yeah? My app's fixed, we're done, you can go home. Yeah, not quite. So you use it, you fix your app. I would run this against my application, I'd see my extra tool calls, I'd maybe manipulate the descriptions, parameter lists, so it's better at tool calling, kind of whatever it is. I'd fix up my app. Cool. But once my app is fixed, I need to make sure it's still working in production afterwards. Because my golden data set is a snapshot in time. If it was synthetic data, then when humans start using my system, they will do things that I don't expect. If it's real production data, then the humans will change how they use my system over time. Think about how you first interacted with ChatGPT when it came out compared to how you interact with ChatGPT now. Think about those people who didn't use ChatGPT when it came out and now are using it. So over time, we change how we interact with AI systems. So you want to continuously run these evaluations over live data. Small amount of data, you do all of them. Large amounts of data, maybe a sample set, whatever works most effectively for you. But essentially, you run it online so you can see what your system is doing. And then as you find the bugs, as you find that people are using your system in a way that breaks it, you fix your application. Again, cool. But you now have a different data set. Those 100 that worked and 100 ones that failed that you used to build your evaluator, they're no longer valid anymore because people are using the system in different ways. So now you need to go back to that human review cycle, build up a new data set of ways that the system works, the system doesn't work, and then use that to improve your evaluator. And you kind of get into this kind of cyclical nature of I get my golden data set, build an evaluator, I fix my app, I run my app, I get a new golden data set, I use that to fix my evaluator, I run that against my app, I find the bugs in my app, I fix my app, I get a new golden data set, I fix my evaluator, I fix my app, and it kind of just keeps going on in this kind of infinite cycle forever. It'll always happen, so you keep on needing to fix everything that you do. Now, one thing I will say, I know I've said that AI is about as good as a human or about as bad as a human. You do not want a 100% pass rate for your evaluator. If you're getting a 100% pass rate for your evaluator, you are overfitting, which means you have customized your prompt for exactly one scenario, and it won't work very well for others. So you kind of expect to get a 90–95% pass rate. That's kind of the goal that you're going for. Never strive for 100%. You'll only be disappointed in the results. So keep that in mind. Humans make mistakes, AIs make mistakes. 90–95% pass rate is kind of a good place to be. And then as we know, your app is never done. Your app is constantly changing. There's new requirements coming in. There's new models coming out. Your app keeps changing, and your evals keep changing. They are a living, breathing part of your ecosystem. The eval has to evolve as your application evolves. This is really, really important. But what evals do give you, though, is they give you the confidence that as your app evolves, you know it's going to work. So one classic way that apps evolve is, I don't know if you noticed this, but new LLM models come out on a fairly regular basis. I love it when people say to me, what's your favorite model? I don't care, there'll be a new one tomorrow. Oh look, Claude 4.8 is the best. GPT 5.6 is the best. Claude 5 is the best. Kimi is the best. I mean, whatever, yes. There's so many models coming out. And what if you wanted to try a new model in your agent? OpenAI are deprecating models at a ridiculous rate. What was the latest model last year is like, sorry, we're deprecating that. You can't use that anymore. So you've got to upgrade to a new model. Models are getting cheaper. Especially a lot of these open source models, a lot of work being done outside the US to create these cheaper models. You don't want to give OpenAI any more money. You'd rather give it to Mistral or DeepSeek. So, okay, how do I try these cheaper models? Well, if you have evals, you have the confidence to make that change. You can literally spin up a version of your application, connect it to a different model, run your golden data set, look at the numbers that come out of your evals, and go yes or no. Build it into your CI/CD pipelines. It makes it really easy. Literally, I've got GitHub Actions set up that run evals over my applications. So when a new model comes out, it's like, okay, just change it. Just try this new model. Yes, no. Do I want it? Do I not? You've got that confidence to change. The same as when you're building a deterministic application, you've got the confidence when you have good unit testing, you have good integration testing, you have good UI testing. I've made a code change, all my tests are green, ship it. Same idea applies to evals. Evals give you the confidence to change. Now, if you want to get started with getting tracing going, getting evals going, I have to kind of promote my company a little bit. They're paying for me to be here. Just been acquired by Dynatrace. Very cool, news announced today. But if you just run npx evals in your terminal, that will take your existing application and set up tracing for you using Open Inference, the open standard, connect that up to a backend where you can see these traces in action. You're starting to gather that data and understanding, and then from there, you can then start writing your evals. If you're kind of the person who doesn't like typing things in terminals because you're not a codey person, QR code takes you to all the details. Set a few cameras there, wait for people to scan that if they want. Cool. And then finally, I love geeking out on this stuff. So if anybody wants to geek out with me on evals, AI, how much AI sucks, if you want to share your tales of AI doing dumb things, please do. That will take you to my link tree. Connect with me on your social media platform of choice. And please share your stories with me of the bad things AI has done, because I love that kind of stuff. But any questions about anything I talked about today or how you can make AI better, hit me up. I love geeking out with folks. And with that, thank you very much.
Wasn't that so fun? Okay, so quick reminder, don't forget to continue scanning things with your RenderATL app so you can get points and merch. And our next talk is going to be at 2:30 p.m. See you soon.
Sending Cassidy out, handheld 8.
Hello, everybody. Hello, everybody. Okay, I got some waves. I'll take it. I hope you all are doing well. Happy afternoon. I'm very excited about this next talk. This next speaker, Ada Gawrysiak, she came all the way from Poland. So please give her a very warm welcome to her jet-lagged self. She's going to be talking about how open source can become a sales strategy. Please welcome Ada.
Thank you. Thank you. Hi, everyone. So when people hear open source, they usually think about engineering. And I'm here today to look at it from a little bit different perspective. To look at it as a way to build trust, create awareness, and support sales. So I will share with you what we've learned at CallStack from building in the React Native ecosystem, and the playbook we use to connect open source with our go-to-market strategy. So I'm Ada. I'm head of growth at CallStack, a company that was built 10 years ago, evaluated in 2025 at $500 million PLN value, a software engineering consultancy delivering projects for enterprise customers. A company built around React Native, and a company built around open source. So let's start with a quick glimpse into CallStack case study and our go-to-market strategy. When I joined CallStack, I did not fully understand what open source meant really in practice. I thought about it as an output of engineering work. And what really surprised me was how big and connected the whole ecosystem really is. It creates trust, builds connections, and eventually creates community. So you travel to all of those conferences and you meet familiar faces. People very often approach even my colleagues because they're a maintainer of a given library. And I heard so many times, oh, hey, I know you from a GitHub issue. Oh, hey, you are a maintainer of React Native testing library. I saw your PR. I know you from X. And I bet you've already had or heard that here at Render Atlanta. So that was the moment when I started to understand open source a little bit differently. That it's not just code. It's how developers collaborate, how they solve shared problems, and how they build technology together. So a maintainer is not really someone just pushing the code. Very often, they are someone who developers learn from and someone who they recognize across the whole community. So to understand why open source mattered so much for CallStack, you need to understand just bits of React Native. So it's a cross-platform open source framework that was built 10 years ago by Meta. And from early days, it was also built by individual contributors shipping code to the core of the technology. And contributing back was always a part of CallStack values, contributing back to React Native community. So since then, React Native has been actually adopted by many enterprise companies. And its usage is growing year over year. And that matters because enterprise companies sometimes worry that open source means relying on someone outside of their company, outside of their organization. But the reality is that modern technology is already built that way. So companies and individual maintainers, they shape together the ecosystem that is already used at scale. And did we know 10 years ago that technology will grow as it did? We did not. React Native was our strategic bet. And how we connected all of those dots together at CallStack. So the whole company was always built around a mantra. We don't follow best practices. We set them. And we have our R&D team dedicated to support React Native core framework and to support the open source libraries that we're building. And we've been doing that from day one. And ColdStack did not build its React Native presence only by saying, hey, we are the experts, trust us. The company built the tools for developers shipping React Native. And that really mattered because developers are actually very good at detecting empty claims. And open source gives them something real to evaluate, real code, documentation, issue, responses. So ColdStack became known for React Native because developers repeatedly encounter ColdStack when solving their own React Native problems. And it gave our clients a reason to trust us before they even engage in any commercial discussion. And when people think about brand awareness, they often think about marketing, about campaigns, about paid ads. But in a market where software engineer is your audience, then the brand awareness starts when someone is debugging, when they're testing, when they're upgrading, when they're trying to make their production up faster. And they will find your library, they will find your documentation, your GitHub issue, or your engineer answer to their problem. And I remember a potential client asking, how did you find us? I asked them, how did you hear about us? And what they said is, I asked my engineering team, who do we call when we encounter a problem with React Native? Our stack is basically made out of your open source libraries. And that was the moment when I understood that we did not only contribute to React Native open source, that we contributed to the whole React Native community. And that's how open source influenced sales conversations. So when developers repeatedly see your work, they use your docs, they rely on your tools, they start associating your company with category. And for ColdStack, that category became React Native. And the moment it clicked for me was when we had a face-to-face meeting scheduled from a company from totally cold sales outreach. And we reached out to them because we knew they were building with React Native, proposed to just grab an informal lunch because we were anyway close to the office. And we expected a normal introduction conversation, but what we found very quickly is that they already knew us. And they didn't ask, can you prove that you know React Native? They asked us, are we using this library in the best way? What other companies are doing? What are the best practices for measuring performance? And just like that, that is a completely different sales starting point. Because you're not starting from a cold pitch. You're starting from domain trust. And this is how developer trust really travels within an enterprise. So the engineering team uses your work. They trust your judgment. They recommend you internally. And then when there's a bigger performance issue, migration, architecture, delivery problem, then your company becomes the first natural choice. So open source does not close the deal by itself, but it can really make the first sales conversation much, much warmer. So that was a ColdStack story. And now let's discuss how we're approaching marketing around open source. And if you're building in technical market, that's the part you can basically reuse and apply to your playbook. So the biggest mistake is thinking that publishing is a strategy, because publishing is only the starting point. So a repo sitting quietly on GitHub does not create awareness, pipeline, or trust by itself. You need to build the whole system around it. So write content about the problem the tool solves. Go to conferences, tell others what you're shipping. Run your events, webinars, post about new releases on social media, create ebooks, free guides, tutorials, benchmarks, and educate others on how to use your open source tool. Share some of the success stories of people who implemented it and solved a problem on production. Also, look at who actually starts your GitHub repo, who engages with your content, who attends your event. So give them a path to stay connected, because those are not always leads, but it's a clear signal that some company has interest and they have a need. And you should not treat every GitHub star as a sales opportunity, but you should understand what kind of companies and people are paying attention. And as mentioned, publishing code is really only the beginning. If nobody discovers it, nobody understands it, or connect it with your company, then it will not create any business impact. So open source needs distribution. But the goal is not to immediately sell to every person who touches the project. The goal is to keep helping them until a business conversation becomes natural. So open source starts in engineering, but then marketing gives it distribution, and sales gives it a commercial path. So you need a really close alignment and common goals between those three teams: engineering, sales, and marketing. So when open source actually turns into a sales strategy, it's free by definition, right? But building is not free. So it takes a senior engineering time. It takes time that could otherwise be spent on commercial projects. So the business question is quite fair. Why to even do this? So open source does not create revenue directly. It creates trust. And trust is one of the hardest things to build in technical sales. It's a social proof that gives sales a much better opening. So don't measure open source only by direct leads. One of my practical tips would be measure whether you create awareness. Check whether a star on GitHub was on your lead path before they contact submission. So for CoStack, that's what we do, and that's what we measured. And actually, our open source is on more than 80% of encounter throughout our leads journey. And can it be turned into revenue more directly? My answer is yes. But one thing that I learned is that not every open source project has to generate leads directly. Some projects are mainly brand awareness, and they're your brand awareness investment. And that's it, and that's okay. So you start with a free value, a library, a tool, guide that solves a real problem. If it's useful, developers really start trusting it. So also don't build your open source for visibility only. Build something that's useful enough that developers would care even if they don't buy from you. And stay close to your commercial expertise. So the project should make people trust you in a type of work that eventually you want to win. If they trust you, they start remembering the company behind it. And that creates awareness. And awareness creates paid conversations. So when an enterprise encounters a serious problem or they want to change a vendor, you will be on the top of the mind. And your company is already credible before the sales conversation even starts. So they will reach out to you when they need support. And I know it's very, very hard, but you just need to wait. There can be, however, a project that sits closer to lead generation. And I treat and call them lead magnets. And those are projects where the free tool naturally points to a bigger problem the company may actually pay to solve. So you need to have a clear offering around them. If you don't create that offering, you cannot really expect the repo to magically turn into your pipeline. And you need a commercial offer. It can be a paid version of the library that you open source. It can be a service or consulting around it. Create clear call to action and think where you want to redirect the people that see the open source. And it doesn't have to be book a sales call. Sometimes it can be a download a guide, request an audit, check enterprise support option. And a good call stack example is React Native Brownfield. So we created a free library that helps add React Native into existing native app. The paid offer is helping the company actually migrate, set up architecture, rollout strategy, delivery, and team handover. So that's our free to fee path. It looks simple, but it's not automatic. So a GitHub star is not a lead, and a download is not a deal. You need a bridge between free value and a commercial value. So let's look into a sales funnel. I think about open source mostly as awareness and interest building. It is very close to R&D and technical content, and that really helps us define our why we are doing it, why we are shipping technical content, why we're speaking to engineers. But then marketing and sales, they are the ones that turn that awareness into business conversation. And this is important because open source should not be a disconnected activity. It should be a part of your go-to-market strategy, and it should have a clear role in your sales funnel. And open source fails as a sales strategy when companies expect immediate return. If they measure only GitHub stars, or they assume people will come asking for services the moment you ship something, or they don't release and they don't ship fast enough and frequent enough. It also fails if we solve a problem that doesn't really exist in the first place, or there is no offering around the project, no content distribution. So trust takes time to build, but it can be lost quickly if the project is poorly maintained, disconnected from the rest of your business. Okay, so now let's move into AI. Because we are all seeing a new market movement with AI, and everyone sees the potential. The teams are still figuring out how to use AI safely and effectively in the engineering work. So developers right now are not only looking for content about AI, they are looking for tools that can actually help them work in a different way. And this is where open source becomes strategic again. Developers are consuming content through LLMs, using agents, downloading tools directly into their workflows. And they expect much faster results. So as brands, we need to think about building visibility for humans, but not also for agents. And my take on that, write skills for agents. Create content and documentation that's easy for humans, but also for AI to consume, understand, and act on. And once again, some case study. So agent device is a good example of how CallStack is applying same logic to the AI era. So agent device is CallStack open source CLI for helping AI agents inspect and control apps. And here's the free to fee logic. The free tool gives developers a starting point. And then the paid offer helps the company turn that starting point into an operating system for QA. So agent device is an open source library. That means you don't need to pay CallStack to use it. You can just download it. You can just play on your own. But you get the real commercial value out of it if you build the whole system around it. So QA agent workflows, CI integration, device automation. So the expected outcome we've identified for our clients is 30% fewer manual QA hours, PR testing moving from 16 hours to 1 hour. And can you achieve those results only by installing open source tool? No. You need to have know-how on building a whole QA strategy around it. So what we did here, we gave developers a real starting point for free, and the paid work is helping companies turn that starting point into a full workflow with measurable results. So the same strategy in new market. Find a painful emerging problem, solve part of it in public, and create trust around that category. The market needs examples, tools, standards, and practical guidelines. And open source became the way to lead the market before the market really knows what it needs. And this is what happened with React Native. And that is what is happening again with AI native engineering. So I shared with you call-stack case studies, a playbook on how to connect open source with marketing and sales, and the relevance of this strategy in agentic development. So to sum it up, the companies that win in open source are not the ones that are shipping the most code. They are the ones that understand where technology is going, and they help developers earlier than anyone else. So build a full system around it. Solve a problem, open source it. Build a marketing strategy and sales enablement around it, and create a natural paid next step to convert. If there's none, don't push it. Treat it as your investment in brand awareness. So the main idea I want to leave you with is this. Don't treat open source as an isolated engineering activity. Build your sales and go-to-market strategy around it. Thank you. That was all from me for today, and happy to chat later and catch up if you're interested more about open source and how to use it in your own go-to-market strategy. Thank you.
Thank you so much. That was so good. All right, everybody, stick around. Tell your friends. Our next talk starts here at 3:15. Go to get a snack, take a bathroom break. We'll see you soon. Hello, everybody. Hello, hello. I got a single wave. I'll count it. Good afternoon. I hope y'all are doing well. I'm very excited about this talk, the reality of real-time UIs, which is always a very interesting subject, especially in today's day and age. Please welcome Brian Fletcher, who's the co-founder of FM.
Hey everyone, how's it going? Are you awake? Let me get my computer awake. Give me 1 second. Oh, it just kind of went to sleep. Give me 1 second. There we go. Okay, like Cassidy said, my name is Brian Fletcher. I'm the principal and co-founder of a company called FM, and FM helps employees and the companies they work for adapt to AI. But we also build digital products, and like everyone in this room, we're using AI to help us build digital products. But we're also infusing AI into the products that we build. And it's in that capacity I'm going to talk to you today about the future of experience. So yeah, let's get going. So this is a follow-up to a talk I gave 2 years ago in Austin, Texas. I was seeing this emerging capability with AI to what I was seeing is deliver a user experience in real time. We all know about building with AI behind the scenes, but what would happen if you launch an experience that then could react to a user or context in real time? And that's what I was exploring. So today's talk is going to be really about following up on where the technology has gone in that time and also looking ahead to what I think it's capable of today. So these are a couple of very crude diagrams of experience and some of the trends I want to talk about. The one on the left is about the chat experience, which I think we all know since ChatGPT came out, we are using chat more and more these days. And you know, I don't think everything needs to become a conversation. I think that there's something more to experience. Or on the right, we have the feed, the algorithm, the content that is very finely tuned to your interest and what you like, and it is sometimes a prison it pulls you into. And I think that's a terrible kind of way to spend your life. And I don't think this is the future that we want. Because I think that experience matters. User interfaces matter. Interfaces help users, right? If you just compare the two sides of this slide, which one is easier to digest as a human? It's the same kind of information. It's just presented differently. And UIs and the way you do layout and the marriage of content with layout, I think is really, really important. And so that is what I think we should talk about today. But with real-time UIs, what is the goal here? And I think the analogy I keep coming back to is really worn boots that you've had for a number of years. You've walked hundreds or thousands of miles in those. That boot conforms to your foot. It conforms to you as a person. And I think that software has the capability to do the same thing. And I think that this real-time user interface could be one way that we mold an interface or an experience to one user. Because let's face it, models are able to fly right now. You see it in the chat experiences you have now. It's throwing out UI elements or sometimes whole apps. And so that is very capable right now. And so that arrangement can adapt in real time to you, built from components that you designed, actually. And we'll get to that in a moment. But this is the capability that's emerging in front of us. But the ultimate question is, would you let it do it live, unattended, in front of real users? It's one thing when you're sitting there building and testing and trying to figure out how this experience should be. But out in the world, is that something you're willing to give to a large language model? So I've been talking about this topic for a couple of years. And I'm going to raise my hand and say I got a big part of it wrong, okay? So 2 years ago on that stage, I think I got the shape of it right. I think that, you know, it would be composed at runtime for one person, kind of the general shape of this experience. But I thought that it would take a new kind of model. And at the time, I was talking about something I was coining as coin a phrase of a large experience model. So you can imagine, instead of being trained on text, it's trained on experience. I thought that was a cool idea, but I don't think it's necessary anymore. But since that time, time marches on, and people have come up with some other techniques of how they would enable a real-time UI. These are these protocols that are coming online. There's MCP UI, MCP apps, agent to UI, all done by a couple of different technology people in the world. And they're all similar in ways and different in others. But I think it all comes down to when the UI is being written and when it comes across the line. So in the case of MCP UI or MCP apps, the server will render the UI and push it to the user. Whereas with the A2 UI protocol, it just gives you a name and then you're in charge of rendering it. But it's the same idea under the hood. So this is some of the tooling that's coming out there, and there's some really good demos that you can go see online. I encourage you to do that and see what others are doing in this space. Here's an example of one right now. This is an MCP app. So if you use Claude, you can just say, write me a color picker, and one will just appear. That's an MCP app being given to you over the line. It's pretty cool, fully functioning, works. And we're seeing this come into our experiences more and more with chat. There are a couple of people that are exploring this space from the product and design side, and I want to call attention to both of them. The first is Josh Clark. He is over at Big Medium. He's coined the term sentient design to describe what I'm saying today. Just some really good stuff, really good thinking. He's focusing very much on the design system that is required to enable a real-time UI. Or Peter Smart, who's over at Fantasy, which is a 20-plus-year-old digital product design company. Peter's been also exploring this space. In fact, gave a talk literally 2 weeks ago to MIT, what he was calling agent-to-agent experiences, where you can use one agent to pass context to the other, and he was showing this really cool demo with commerce involved. I encourage you to check that out. So a couple of guys exploring this space as well. There's an emerging standard that I'm seeing, which is no one is letting the models draw from scratch. In fact, when I stood on the stage in Texas, I had my team try to build that, and I was like, let's just go down to the most basic HTML and CSS and see what we get. And it was passable, but not great. So everyone is starting to say, okay, listen, we can't let it write from scratch. They must pull from pre-built components. So that is something that I want to explore today. And the way Josh Clark puts it, it's kind of a push-pull. The model supplies the adaptivity, but the design system supplies that consistency, and neither one works without the other. So it is a marriage of these two kind of pulling forces, I would say. So the work is not in the model. It's what we hand it. So I'm trying to think about how we could do that. What could we give the model, the instruction set, so to speak, of experience? So enter the chat, Brad Frost. Everyone knows who this is, right? Brad Frost, everyone raise your hand. Come on, come on, give it up for Brad Frost. No one knows, okay. I'd say half of you know him. All right. He is the godfather of design systems, okay? He's a great guy. He's been doing, I think a lot of people in this room have been following his guidance for years. And what that is he's put together something he calls atomic design, where he's broken down the elements of design into atoms, molecules, organisms, templates, pages. And it's a good framework for thinking about design and what something looks like. And a lot of people build and maintain these. And depending on the size of your organization, this might be your full-time job, is keeping track of the design system so that your mobile app developer or your web developer can stay on brand with the experience that you're coming up with. But you don't just need that. You also need the rule set that's underneath that, which the way I would describe it is the things that are in Jira tickets that describe the rules behind this layout. Of course, the design system itself has some direction there, but we need some more harder rules so that we're able to tell the large language model what it can and cannot do. So you define what's allowed, and the model decides what happens. I've arranged this in 4 different areas I'm seeing, which is this is the rules I'm thinking that need to exist. First is permission, when a component may appear, or when it may not appear. Obligation, what must appear and where, right? There are some certain requirements. If you have a warning label, you have to do it. You cannot, there's not a question there. Also assembly, what stays together and what moves together, right? And in what order. So those are some elements that say they have to be next to each other, like a user profile screen should go together. And then finally, slots, what each component declares itself to be, so that you can then marry the content with the component easier. So it announces itself, and if you have that, the model might be able to react to that in some way. And ultimately what we're doing is we're creating a design system for machine instruction. You're converting probably something that has a look and feel to code, to a JSON structure, or something that you can pass to a model as another element of context. And that's basically the job to be done. So what you're doing ultimately is you're setting the conditions, but you're not building outcomes. And I would say that that makes people uncomfortable. Because this is the part where you're handing it over to the model to decide what the experience should be, right? And that just is a very uncomfortable feeling. It gets to the heart of, would you trust a model to do this? And I think there's a mindset shift that you have to take when you do something like this, or play around with this technology. And I equate it from moving from being a builder to being a gardener, right? So what do I mean by that? Well, what does a gardener do? They put in paths. They put up a trellis for the vines to grow up on. They're not growing the plants. They're putting in the condition for the plants to grow. There's artistry there. There's beauty. But they're not fully controlling it. And I think that's a really great analogy if you're thinking about how to enable a real-time experience. And it's going to take a shift. It's not going to come naturally. But I think it's going to be really fun as we really embark on this together and understand what that could be. All right, so that's the theory, which sounds great. But I wanted to know, let's put it up against something real. And I'll be honest, I don't know if this is the right use case for it. I'm playing with this technology, but basically what you're going to see is the premise about if we do all of this, if we codify a design system and hand it to a language model, is it able to give us an experience that looks like anything remarkably close to being okay? So I built a recipe website. It's called Mise, for mise en place, which is the culinary term of like everything in its right place before you begin cooking, which I think is an apt metaphor for what we're talking about today. But Mise is a cooking website that is a little bit different, is that it's really trying to turn people into great chefs or cooks and really elevate their cooking game. So it does a lot of things around technique, not just recipes, but really helping people understand technique. It asks them for how well the dish was and how well they did in cooking it. And it's trying to be your partner over time to help improve your cooking skills. And that's an important theme that we'll get back to in the rest of this talk. So obviously, I'm following my own rules. So for this demo, this proof of concept, the model never draws anything. It picks from components that only I built. I think I gave it 15 components. And then what it picks from is one file that I wrote, which I call the manifest. That is the design system in code. All of the rules, all the names of the components, and so that's how it makes sense of what I'm giving it. There is no experience without users, so I've got 3 users that I'm looking at to support in this experience. The first I'm calling the learner, and I'll say across all 3 of these, I'm giving the model 90 days of history of what these people have done on the website. So the first is the learner. They cook most weeknights, but they're definitely a novice. They've spent the last few months focusing on the concept of searing something well. And they don't really use the search box. They're really, I think, it's very obvious that they're trying to learn how to cook better and up their cooking game. And then the other 2 are what I'm calling the twins, twin A and twin B. They're not literal twins. They're 2 different households who, from everything they've told us, are exactly alike. They each have 6 people. They cook 45 minutes on a weeknight. They are very confident in their cooking. They're a dairy-free household. And they have the same things in the pantry across both of them, as far as what they've told us. So that's kind of what we've got here. So this is where I'm going to do a live demo. Please pray for me. That already messed up. There we go. Okay, got it. Just one little hiccup. Okay, so this is the homepage of Mies. I'll say from the get-go here, I purposely chose a very loud brand because I wanted to see when it got it wrong. I wanted it to announce itself very quickly and easily so I could scan things to see if it's on brand or not. So it's a purposely very loud brand. But it's a typical cooking site. You've got a home page with a featured recipe, maybe a short list of items that you might want to cook this evening. It has the overall index, which is all of the recipes that you can go through, but pretty simple home page, okay? So what we're going to do is I'm going to show you the 3 different home pages of the personas that we're supporting here, right? Is the home page the best experience? I don't know, but like I said, go with me on this one. All right. So the first is the learner. So this is their home page. The thing that jumped out at me here is that this is a recipe site without a recipe on the home page. Because what we know about what this user did said that this was the experience they need right now. And that experience is trying to learn this technique. So what we did is we gave them this technique thread where we said, here are the 5 attempts at this one technique that you seem to be circling on here. Here's a tip, right? That you might not have tried, starting the pan cold. Here's a technique note. And here are some troubleshooting techniques, right? So this is a user that we're learning about, and the model made this decision for me. I did not direct it. I said, here's the context, here's the user, here is your design system, tell me what they need. Okay, so across the bottom here on this big green bar is where we're starting to get the diagnostics of the proof of concept. And so below this are some of the building blocks of this. So we're starting with the components themselves. So on the left column, you are seeing that these 7 components were not even eligible. We didn't even give them to the model. We didn't even ask it to consider them. This is the deterministic rules that I put in the system. The middle column is about things or components that were given to the model, but it passed over for a variety of reasons. And then on the third column, obviously, is what it chose, the only 3 components that showed up on this page. We also have a concept of max density, so we have a little bit of things to help us get some look and feel, and how many components is too much, right? So this is the homepage that the model came up with for this user. And like I told you, it's based on their behavior. And down here at the bottom part of this diagnostic, these are the clues we're working from to determine what we should show them. So in this case, they open the technique notes. That's a pretty good clue, right? Or they don't really repeat dishes. So these are some of the signals that we're using, but what if I change them in real time? What are we going to get? So if I turn this off, bam, the feature recipe comes right back in place here. So that's a good positive sign that the model is listening, and it did not have enough clues to kind of go down that path that it had already gone down. But there are still some other clues here. It still has some previous dishes, and there's a technique that keeps getting highlighted here. So we know a little bit. And in fact, it says columns were chosen for you. So we knew a little bit to give this more, I guess, on the user's needs and showing them what they need. But we didn't have enough to fully say that they're only a technique kind of cooking enthusiast. So that's the learner. Now let's go to the twins. So once again, 2 households. Everything they told us is right here in the middle. It says, this is everything they told us about themselves. Whoops, sorry. But then what they did was different. And these are their pages side by side. And I can click into each one of them to kind of see it in full view here. So this household tends to like the recipes that split down the middle. It's a feature of Mies where it's a recipe that has options. And so they've seemed to have liked those kinds of recipes. So we're showing that front and center, or that's a layout that we're showing for them, right? If we go back to, and go ahead to twin B, this household is much more of a planning household. So they have a planning of the week ahead. So Sunday, Tuesday, Wednesday, some ideas about what they can do. and how they can get ready for the week. It has a shopping list, and then a recipe all the way down at the bottom. So that's the twins, that's the learner, shows some variety. It shows how the model is able to, I would say, put together a pretty good experience for these users. The final thing I want to show you is this kind of master, kind of behind, in the kitchen, kind of scene of the entire experience of what we're building. So we've got the twin A and twin B in the middle and the right. On the left, what you're seeing, this whole big wall of text, that's basically the manifest itself. And this is allowing me to just play with things in real time. And this is my ability to say, do I trust this enough? If I try to break it, does it break? If I do, what will break it and what won't? So one idea I have is like, remember, they like that split recipe. That's called the forked recipe card in my design system. I can remove it. And then if I save the manifest, it re-renders, and that's gone, right? So all of a sudden, it's not available to the model. I do notice that it puts 3 things in a row. That doesn't look great to me, so it's a little bit of QA here that I'm going to look at. But the model and the system and everything that's been built here holds up. There are fallbacks, there are approaches. There's deterministic along with the non-deterministic rules that we're following as a large language model as we give it this information. So let me go back to my presentation. So that was the demo. So what did I learn in building this? A couple things surprised me. Number one was kind of how quickly it just snapped together. Once I had built the manifest, the component library, kind of out of the box, it was creating something that looked like it was composed by a human. And I really did not expect that. I expect a little bit more kind of pain to get there. Number two, the model is the smallest part of the system. And I think anyone here who is coding with AI in the center of it or an agentic experience knows that to be true. You limit it as small as you possibly can. You don't give it broad instructions, you give it very focused instructions. And that's what we're doing here. And I just kept constraining the model smaller and smaller. And number three, cost. So I am pulling a large language model into the rendering of a page. That's going to get expensive if you have hundreds of thousands of users. I will tell you that for me, it costs maybe a penny or two per rendering it. And I built a caching system to help with that too. So cost is a concern. It isn't as big a concern as I thought it was going to be. And in fact, and by the way, this is a repo that I'm going to give you guys today if you want to play around with it as well. But you can use your own hosted model for free if you want. You can use Olama and see what kind of response you get out of the app there. So cost isn't as big as I thought it would be. All right, so let me dive a little bit more into the details of the app and what it does. We talked about what you decide in advance. This is the design system. All of the rules of that put into that big JSON file. This is what the model does. It's just which of these for this person right now. That's all I ask it to do. That's me constraining the model. And then finally, this is the non-deterministic or the deterministic part where I have checks before and after I give anything to the model. So before I give something to the model, I filter things out that it does not need to know about. And then after it renders, I go back and I ask it, I see if it's right, I try to repair it, and if it fails twice, I just replace it with a backup. Like I said, I've got a backup system built into this as well, okay? And then the final point about all of this, you will need a new kind of analytics, and I want to acknowledge that today on stage. Generally, analytics knows what a crowd did, but what we really need here, what did one person do? And so to do that is easier said than done. We have to track them. We might have to give them, ask them questions, surveys, follow-ups to really confirm if they made that dish and how, kind of like grade it, et cetera. And then you have to have the actual infrastructure to store that and give that back to the model. I'm hand-waving that away with my data model now, but it is something that you will have to build here. So if you can build the product that can tell all these users apart, and then the first-party data strategy to retain that knowledge, that is the big missing piece here. So what does the future potentially look like with real-time UI, and what could experiences be? So obviously the first one is on the nose with what I showed you today. The recipe site opens on tonight's actual dinner. Or maybe you have a workout application that somehow knows that you hurt your knee in March and it routes you around the actual activities that might hurt your knee. Or you have a learning app that just quietly drops what you already know. Nobody set a preference here. Nobody asked or anything. The system just kind of knew. And no template was designed by a team. It just kind of appeared before the user. And you can see that the software at that point took the shape of the person using it. So that's kind of what we were trying to set out to do. So I think that this really proved to me that this is really possible. So everyone here are makers and builders. And I want to remind you that the web and digital that we have today is because of the people in this room. We saw technology, we saw its promise, and we made something amazing with it. And that experimentation is what we need right now. So this was me experimenting. I want to ask all of you to experiment with this technology. I think it's pretty neat. Go break my Git repo if you want. But ultimately, I want you to play with this. It's really fun. And I think it could really be the future of experience. That's it. Thanks so much. That's the Git repo if you want to access it, or you can contact me. And I'll be around if you have any questions. Thanks so much.
Hello, everybody. Okay, stick around. Our last talk here is going to be at 4 p.m. before we start closing everything out. See you soon. Hello, everybody. Hello, everybody. Hi. I am very, very excited about this talk because whenever you learn about some kind of security thing, learning about spying, it always feels like you're in a cool movie. So anyway, I can't wait to introduce AI engineer David Von Thenen to talk about teaching your agents to spy.
Thanks. All righty. Cool, cool. Everyone can hear me all right? Okay, excellent. So appreciate, I know this is like the last session before the final keynote, so I appreciate everyone for being here. Today we're going to talk about keystroke loggers, and more specifically, acoustic keystroke loggers. And for those that aren't familiar with what a keystroke logger is, usually it's a piece of software, it gets installed on your computer, and then you can literally eavesdrop on like what people are typing. But we're going to do this using acoustics, so sound. So my name is David Von Thenen. I'm an AI ML engineer. I have an interesting background, everything from Kubernetes to backup recovery solutions, virtualization, Kubernetes. If you're interested in chatting about any of those things afterward, definitely hit me up. But I've been doing the AI thing for quite some time, and I like to do weird, wacky projects just like this. So let's just talk about the agenda today. So we're going to have to acknowledge that this talk is kind of sensitive because I'm literally going to teach everyone here how to build an acoustic keystroke logger. And the code's all in my GitHub repo, so you can take a look at it afterwards and play around with it. But we need to acknowledge the kind of this weird duality with AI and ML. And we just need to acknowledge it, and then we're gonna then go into how do you actually build an acoustic keystroke logger. So we're going to talk about the data set, the processing pipeline, the architecture, and we're going to actually drive this by live demos. And after we kind of build out this ML classifier for sound, we're going to talk about real-world attack vectors, so what you could actually potentially use this thing for. Don't do this at home, though. And then finally, we'll kind of talk about like ways to protect yourself, securing your information, privacy, and that kind of a thing. So let's talk about the moral duality of AI and ML. So I hope that we all use AI and ML to do awesome things like this. So this is an NIH article basically saying, hey, we used AI and machine learning to do protein folding, categorize and classify new diseases, find cures. This is what I hope we all use AI for. However, there's like definitely a dark side to like AI, and I definitely have all the citations and links so you can actually watch this video at home. But there is actually people using AI, companies, and if you've seen in like grocery stores and convenience stores, they're starting to employ digital price tags on things on the shelf. And what they're actually using that is they're collecting all this data about when things are being purchased, and they're trying to then change the price based on the time of day, let's just say Friday after work when you're really tired, and jack the price way up there so that you might not want to go and price matched at other grocery stores and you just go ahead and buy it. So they're using it to maximally extract what you're willing to pay for groceries. And in my opinion, this is downright evil. I mean, this is really horrific and should be outlawed. There should be laws against that. And then you have the unintended consequences, right? You have now, I don't even know if it's boasting or not, but you have these companies saying, hey, my AI hacked some other company, infiltrated its firewall, and did all sorts of bad things. And I don't know if it's a marketing stunt or not, but it's definitely cause for concern, right? These unintended consequences that exist out there with AI. So I just want to acknowledge that. And this session is actually something I didn't build. I built it, but I built it based off this research paper. And this research paper is literally titled, A Practical Deep Learning-Based Acoustic Side Channel Attack on Keyboards. And I implemented what was there, and I made some vast improvements on top of what was there, what was implemented. And so this session's really kind of about many things: awareness, understanding what's possible, and actually at the end, I'll actually talk about a thing that could be used for good, believe it or not, from this type of idea, this acoustic side channel attack. So let's go ahead and talk about how do we actually build one. So what we're actually trying to do is we're taking sound and we're building a classifier. And we're, hit the letter E on your keyboard. Based on the sound that that key press makes, we want to be able to classify that sound as the letter E. And believe it or not, this has actually been happening in the world for quite some time now. And the way you do that is, if you think about what sound is, it's just basically frequency over time. And here is what this sound looks like in spectrographic form. So we actually take a look at that image, and that's sound converted to an image, where on the bottom axis you have time, and on the y-axis there you have frequency. And then you have the coloring that's in this image. You can think of that as like a heat map. How intense is that frequency at that given point in time? And so from this, you can actually build out you can do a conversion from the sound to an image, and then use a collection of these images in order to build out a classifier to classify individual sounds. So this is called a spectrographic image. Now, the bottom picture here, you can actually see each one of these cells is a sound. And you can see, like the two that are right next to each other in the top left corner, you can actually see that those two sounds, just by visually looking at it and inspecting it, that you can actually see that those two sounds look very similar, like just visually. And then you can take a look at the one next to it, you can see that one's definitely not like the other two. So even just visually looking at these different sounds in these cells, you can kind of come to the conclusion that these two sounds are similar, and this sound must be some different source. And so I have a bunch of links here to example projects. So you can do cats versus dogs, so a cat meowing and a dog barking, and you can build out classifiers to classify cat versus dog. Now, a real world representation of what this actually might look like in the real world. So in urban settings, they actually have these classifiers that are built out to detect gunshot recognition. So when you're in an urban setting, you hear gunfire, it can actually classify the sound and then say, hey, that must be a gunshot, right? But it has to be smart enough in order to know that it's distinctly different from other sounds. So as an example, so I live in Long Beach, California, and it needs to be able to recognize that that is a gunshot and this is not. So as an example, like a firecracker might go off, you wouldn't want to alert authorities saying, hey, we heard a gunshot, and when in fact it was just a firecracker. And then where I live, I don't know why, but it happens, someone's lighting fireworks off literally every day. So yeah, it's a real world implementation of what this could potentially do. So every ML problem always starts with the data set. And we're going to actually use two different types of data sets here. So the first one we're going to use is a keystroke noiseless final. So this is actually a data set, and both these data sets I found online. But the first one is actually a data set that was used from a Singapore hackathon in 2024. And we're actually going to use this data set, which is a single keyboard, so it's a single known keyboard, and it's a data set where they collected samplings for the letter A, hit it 20 times, the letter B 20 times, and so on. And the second one, which is kind of very interesting, is it's a multi-keyboard acoustic data set. So now we're going to, instead of just having a single keyboard, we're going to introduce multiple keyboards and try to classify what letter is being pushed independent of what keyboard is being used. So you can actually click the links here, take you to the data set to download at home. So now that we have all of these WAV files are typically in linear 16, 44.1 kilohertz sampling rate, and we need to take all of these sounds for all these letters, and we need to convert them into these spectrographic images. And because we're building out a classifier, the easiest way to do this is create a script, take an input as the WAV file, convert it to a PNG file, which is our spectrographic image, and group them by folder. So the letter A, put all the images into the folder A, B, C, and then use that folder name as a means of saying, hey, when I pass this image into our model, tell me the letter that it's supposed to be, and we'll use the folder as the label for that particular image. And because we're doing frequencies over time, and we want to know the intensity for a particular frequency at a given time, we have 3 different channels that we're using to track and use machine learning in order to try to classify these different sounds. And the 3 channels are RGB, right? Red, green, blue. And that coloring is that kind of, what we're doing is we're using that color to teach our heat map and our model to recognize what frequencies at what time are inherent to that particular key press, and that's how we actually build out this model. I'm going to skip this, but if you want to go deep into the weeds, it's not important for the story here, about the actual model training, you can hit me up afterwards and I'd be happy to like really, really go into it. But this is for, to take a look at later. So, and there's no need to, the slides are already on my GitHub too, so you can, take a look at them after the fact. So let's look at the first problem. Single keyboard, multiple key presses, and we have a data set like 10, 20 sounds per key. And in any ML problem, and this is kind of like one of the reasons why I love doing this session, is like to teach how ML problem solving actually works. We take this data set and we need to chop it up into 3 distinct components, right? We have the bulk of the data, or the bulk of our wave files, is used for training data. So this is where we're imparting and building a classifier, and this is where the knowledge is coming from. Now, we have this other section for validation. So validation is usually about 10% of the data, and we use that data in order to hone our model to say, hey, how close are you to this representative data? And PyTorch over time, churn, 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 and you start to converge the model based on the validation data. Then the test data, which is 10%, which is 10% of the data, we earmark this and set it aside so that the model has not seen this data before, and then we take that test data to run it through our model to see how well we did, right? Kind of like the final exam. What score is it gonna get? So instead of talking about it, let's go ahead and just demo everything. Can everyone see that okay? Cool. So we can actually see a folder here, data, and if we go data, we can see test, training, validation, right? The 3 different groups. And if I take a look at the training data, I pared down the data set so that it's very, very small, because this would take far too long. So I have the letter A, and if we go look in the folder A, we can actually see the number of wave files there. And we need to take these wave files and convert them to spectrographic images. So, as you can see, there isn't an images folder there, but we're going to convert those wave files and drop them into an images folder and create those images. And I can never remember the command, so I have a cheat here, which I'm just going to copy and paste because it's pretty long. Hoping this cooperates with me. Cool. Now we have an images folder. And if we go to images, I'm just going to pick training again, the letter A. You can see we've converted them to images. And if we want to actually take a look at what that looks like, I'm going to pick one of the images. So this is the letter A in as a spectrographic image. So, cool. Now that we have the letter A, and we have many, many images. Okay, here we go. So if we actually go ahead and we do, now we have a pipeline for extracting the WAV files and images, and then if we actually want to take a look at what all of these images look like, we'll look in our data folder. We have our test, training, and validation, and we need to use this data in order to train our model. You can see all of the different letters, and if I just pick one at random, like the letter B, you can see our PNG files, which are our spectrographic images. So we're going to use the training, test, and validation data in order to train our machine learning model. So to do that, you go Python 1_train, and on an H100, 14 hours later, you have a trained model. So we obviously can't do that. We don't have the time for that, but we are going to run inference. And what we're going to do is we're going to take that file right here. So this is one of the earmarked, the model has not seen this image before. This is the letter S. This is the instance 9, right? And we're going to take this image and we're going to pass it through our pre-trained model. And we're going to ask it, what letter do you think this is, and tell me the confidence for this particular letter. So let's run that. And you can see our most confident score is it's 100%, and it knows it's the letter S. So what's this tell us? That you can absolutely build an acoustic keystroke logger. This is a single keyboard, but it's totally doable. Now, let's move on to something a little more difficult. Let's do a multi-keyboard. And so here, our data set's composed of Lenovo, HP, MSI, Apple, and the two on the end are actually very interesting. Obviously, Zoom is not a keyboard, but those sounds were collected with the microphone unmuted, someone sitting on the other side, and recording the sound for that particular keyboard. So I'm just saying that it is totally possible to collect sound over a microphone that's unmuted and be able to do something with that information. Just like before, we need to divide our data set for training data, validation data, test data, 80%, 10%, 10%, and we train our machine learning model to detect multi-keyboard acoustic classification. So let's go ahead and do that. So we're going to take, so if you want to train this model on your own as well, you can go Python 1_train. 14 hours later on an H100, you'll have this model. And I don't want you to burn your own money, so I actually have these models saved in safe tensor format. You can actually download them at home and then like run inference using some of these test images on your own. But what we're going to do is we're going to take the Lenovo keyboard H, instance 5, and we're going to pass it through our model for inference to find out what its best guess is for what key that is. And as you can see here, the most confident score is 48%, the letter H, which is correct. And now I've printed here, I've done a top K equals 5. Basically, give me your top 5 most confident guesses. And then you have the letter G, which is 24%, and so on. So the thing to note here is that the confidence score drops dramatically when you're dealing with multiple keyboards, but it's still doable. Now, you know, the hacker in me who kind of like loves doing this stuff said, well, if we can guess like multiple known keyboards and we can get pretty confident on the scoring for what key sound made that particular, you know, that letter press, how about we take and simulate me typing something out on a, you know, as like a message or a Word document, an email, password, whatever it is, right? And let's string those letters together and run inference one after the other to see what kind of result we get. So what we're going to do, hide the error message there. So the message we're going to spell out is hello space people. And so we're going to run each one of these images, right, the spectrographic images, into the model one after the other, simulating me typing, capturing the sound, passing into the model, running inference, and then telling me what the confidence score is on the best guesses for its, what letter it is. Oops. That's the next part. Hello, people. Take the letters or the images, pass them in one at a time. So you can see the actual message, HELLO space, PEOPLE. And then, just like before, the first column is the most confident guess. So HELLO space OEOOLE. So it's not quite right. It definitely got a couple letters that it had guessed incorrectly. But what the research paper had failed to realize was that if you set don't give me the most confident answer, give me the top 2 or top 3. And so if you look at the next column over, we actually have PEOPLE, and we can actually spell out this message and figure out what it's intended, what they're typing out. So how do we go about doing this? So kind of what I realized was, hey, what we can do is we can take these letters, run every possible combination, run them through a spell checker, and then just say, hey, is this word spelled correctly? If it is, log it. And so that's what we're going to do. But what's really interesting is we can't just take every possible combination and run them through a spell check, because here we have, if we're just using a top k equals 2, so your top 2 most confident guesses, there are 12 key presses here, I believe. 2 to the 12th power is way too many combinations. We would be sitting here for all of eternity. And so I was sitting there, how can I attack this problem and make this even easier? So there's one key on the keyboard that's vastly different from all of the other keys. Anyone want to take a guess at what key that is? Yes. So we can use that uniqueness of that key to our advantage. Delimit the phrase, cut it based on the space bar, now delimit the 2. Now the first word is 2 to the 5th power, and now the problem is far more doable. The second word's 2 to the 6th power, 64 different combinations, and we can actually solve this problem. We went from a million combinations to now 32 plus 64. And so that's what we're gonna do. And I'm gonna do this live, and I'm gonna actually run it through a spell check. So we're gonna hit the internet and see if this thing actually works or not. And we're going to run every possible combination, delimit by the space, run every possible combination. For every word that is spelled correctly, we're going to just dump it to a file. So let's go ahead and do that. And so you can see our message here, right? HELLO space, whoops. HELLO space, and then the misspelled word, but with all the different combinations. You can see by delimiting the word segment 2, or delimit using the space, we have 2 segments of the phrase, and we're just going to log it with the word complete. Every time we hit, the word is spelled exactly correct. The first word, is 5 characters in length, 32 different combinations. I hope that did not kill the program running in the background. And what we're going to do is, for every combination, we're gonna run it through a spell check. We're gonna log the probability of each word. And then we're going to basically, because who knows, maybe hello wasn't the actual word, and we want to just log every other possible combination. I'm not sure how long to give this because it went off to a screensaver, but we'll see, give it a couple more seconds here. And once it kind of goes through and logs everything, it's going to move on to the second segment, right, which is the word people. Please, please, please. And yeah, we're going to give it a few more seconds. Please, internet, cooperate. This is where you really start praying to the demo gods, saying, please work. I'll let that go, and we'll just check back in a couple seconds here. So results from the experiment here. I actually have one other thing. As that's going in the background, I realized, so there are actually instances where we might not actually get the word correct. And so as we're doing the multiple combinations, maybe that word is still not correct. It doesn't come out exactly right. And so what I realized is I could probably use AI to like basically punch out that word, leave it a space, and use AI to guess the most probable word. So who remembers Mad Libs? Right, that old game where you used to fill in the blanks, but instead of picking something funny, we're going to pick the most probable word. And so I actually built a model to do that. And I'm going to run 2 test sentences just to show you if we were to try to build this thing out in an automated way end to end. So the example here is Atlanta is the capital of blank. Run it through the model to guess the most probable word, Georgia, which is right. Small language models are distilled using large blank models. Language is the most probable word, and that's correct. And this is actually still going. I think I botched it when I went to the screensaver. But I can't hear you. I'll catch you afterwards. Yeah. So results from both experiments, because I am definitely running out of time. Single keyboard, 100% accuracy. Multiple keyboards, take all the test data, run it through, 46% accurate. Now, if you think about it, like a typical machine learning problem, 46% is not great. But if you think about it in the context of the problem, if you were to randomly guess what the letter is or that sound is, you would basically be at roughly 3%. So 1 out of 38, 3%. So 46% isn't that bad, considering you're guessing 1 out of 38 possible combinations or 38 possibilities. So when you start to factor in, give me your top 2, 3 most confident guesses, do all the permutations, spell checking, fill in the blanks, now you actually have a problem that you can actually solve. I did not test a data-independent data set, which is introduce a keyboard that the model has not seen and guess the number, or the letter or number combination. I did a talk on doing multimodal training for sarcasm detection, so like sarcastic comments. And based on that, I actually know that this would not work, so I didn't even bother trying it. However, I think this would work. So let's say that you have 2 keyboards made in the same manufacturing lot. And it turns out, obviously language dependent, but in the English language, we press keys at certain frequencies, and the letter E is used the most, then the letter T, and you can actually see the frequency, 12%, 9%. And kind of the idea here that I'm floating, and I did not get to try this because I didn't have a data set, but the idea here is that the wear and tear on the keyboard might actually be producing the unique signature on the key. And if you were to get 2 keyboards made in the same facility, in the same lot, used for a year, it actually might not need to have, you might not need to have that exact keyboard, just one very, very similar to it. So let's talk about real-world attack vectors. So this isn't a new thing, right? Payphones used to be dial tone based, and there used to, in Captain Crunch, remember that cereal? Back in the 70s, they gave a prize away, a little toy, and it was a whistle. And that actually happened if you blew into the whistle next to a payphone, it resonated at that frequency, and that payphone would give you free phone calls. If you knew about this little trick, for 20, 30 years, you would have had free phone calls based on the payphone system, right, on dial tone. So I was thinking about if I were to try to build out a real-world attack, and I'm definitely running out of time, if I were to build out a real attack on a single keyboard, what would I attack? That is what I would do. Single keyboard, capture the sounds so that when you press the letter, you can actually figure out what number is being pressed. How would you then get the card and the pin so that it's, you have one complete set? Who knows what a credit card skimmer is? Right? Embed the microphone, the magnetic strip goes through the skimmer, turn the microphone on, start recording the sound, now you have the pin. So what do you do about all this now that I've scared the crap out of everyone, right? So do all of the things, right? All of the security things. Two-factor authentication. I actually have 3 of these different fobs, all for different things. Use passwords you don't know. That sounds crazy, but it's true. If you use passwords based on your kids, when they were born, their names, your favorite sport team, I can socially engineer that password and start removing possibilities based on what your preferences are. Use a different password for every platform, right? I know a lot of people are smiling because it's, right? But use a password for every platform, right? One compromised password doesn't compromise all of your banking, right? I know this is annoying. Basically, you have changing your password every 90 days. Your corporate people say to do this. There's a reason for it. Be intentionally difficult. If you're at a sensitive thing, you're typing something over, you're speaking something, to someone on the phone, add noise to the background. That's the reason in spy movies you see them turn on the shower or turn on the radio. I wanted to leave you with something positive and not something really scary. I gave this talk at We Are Developers in Berlin in July. Someone after the session came up to me and said, hey, we're trying to find out what minerals are in the ground. And we're trying to figure out how can we do the discovery without actually doing the digging. And it instantly reminded me about this scene in Jurassic Park where they make a vibration in the ground, use the radar to basically see what dinosaur bones are there without having to actually dig. And I told him, you should be able to use this code and probably do the same exact thing. If you want to talk about some details about how to do that, you can meet me afterwards. Some resources, like I said, everything's on GitHub, slides, code, everything. I did a podcast with Render here, super awesome with William Hill, basically going through my career changes and stuff like that. Definitely listen to it, it's an awesome thing. I did a podcast talking about the human aspects of this, like the security and all that stuff. Definitely take a look at it. Last thing I'll leave you with is We Are Developers World Congress. I did a talk there in 2025. Definitely watch this video. It's basically how to trick AI to do things that it's not supposed to do. By the way, guardrails are absolutely horrible. You can trick an AI to do anything. You just need to get really creative. But if you're talking to an AI chatbot, maybe some e-commerce thing, maybe get a free discount or even something for free. And with that, thank you. I'll be available for questions afterwards. Thanks, everyone. Really appreciate it.
Thank you so much, David. That was awesome and super practical. Okay, everybody, that was our last talk. So go forth and network. This is the final time to do so. We have our keynote here at 5:15. Be here at 5:15. Until then, go explore. Hello, everybody. Oh my goodness, we're already at the end. I am both sad and happy because it's been such an awesome event. Have you had fun? Yay. Oh, I'm so glad to hear it. Okay, so for our final keynote of the evening, I'm going to introduce the man who will introduce it, Jeremiah Sias.
Hey, am I coming through clearly? I feel like I've introduced myself so many times, like in the last few days. Hi, everybody. I am Jeremiah Sias. I am a VP of Market Strategy and DevRel at New Relic. And first, I want to say thank you, right, for joining us this week. Thank you for being here in this final session with so many happy hours and events kicking off. You decide to kind of like stay to the last session. That's like pretty amazing. So give yourself a round of applause. Like that shows that you care, right? And so before I came out, I actually decided that I wasn't going to follow kind of like the prompt, anything that we have in the speaker notes on the slides. And so I'm not going to do it, right? I just actually want to talk with you all. So I've been asked quite a few times, I think starting last week, of like, why are you all here? Like, why did you do runtime? Why did you show up so big? And I was the person that kind of made us do this, and so I felt like I was responsible for answering that question. And so I want to tell you a story of the way that I thought about it, right? So in 2019, I moved from Miami, Florida to Portland, Oregon. Life-changing move, right? Miami's incredibly diverse, Portland not so diverse. I took a role at New Relic, and I didn't really know how it would impact me going from seeing an array of people on a regular basis to not really seeing people that look like me. And so I went to an event, I'm looking for a community, and I was listening to a session. I think they were asking a VP from Daimler Chrysler, how do they survive kind of like in this economy? And she used this analogy of, normally you see eagles, and they're kind of like soaring in the wild, they're on their own, they spend a lot of time alone. But every once in a while, you'll see two of these same birds where they get to spend time, they'll fill their cup, and then they go off and continue to do their own thing. And I think for a lot of us that's in this room, we kind of operate in that capacity, right? A lot of times we're the single person that's in the room. You're not really in spaces with a ton of people that look like you. And I think that it's important for you to take that opportunity in these moments, right, to fill your cup, to meet with people that have the same kind of like ideas and thoughts and interests as you, that look like you, to be in a diverse crowd, to have conversations. I've had some of the best conversations all year this week, right? And so I think that that's incredibly important. And I'm amazed at what Render has been able to do to create that type of environment. But that's not why I chose to do this. Like, I think it's important, but that's not the reason why I said we have to go really big. Like, we really have to show up. The reason why I'm here is because of you, right? Like, when I looked at the reg list and I think about the folks that I knew that would be in the room, we had engineers on this list from logos that I'm amazed at, right? From companies that run the world, that's on the cutting edge of technology, right? Googles and Microsofts and Home Depots and Cox and HD Supplies. And look at all the vendors that we have on the show floor, FanDuel and AWS and all these companies. So it's like, if we have representations from all these brands that are running the world, and these are the people that we care about, these are the people that I want to interact and learn with, then the question for me wasn't, why should we be here? Why should we go so big? It was, why wouldn't we be here? Right? It didn't make sense to me. Like, this is a space that we should be in because you were here. Right? Like, you're the people that I want to interact with. We're the people that we want you to buy our services, but we need to engage with you and understand and work with you and have empathy for the work that you're doing and learn from each other. So that's why I did it. Right? That was the one decision. That's why I always speak with Justin about how can we grow Render. I sponsored their second year when it was 300 people at the gathering spot. And to be here where we have 8,000 people registered has just been amazing. Right? So I want to say that's why we're here. That's why we're here. That's why I show up behind the scenes. That's why I push my teams to be here. That's why I've been on this stage so many times. It's because I feel that we belong here because you're here, and so I want to thank you all for being here. And with that said, I'm going to bring out someone that I truly admire, right? Our head of, I'm going to get the title right because it changed, so let me actually use the words on the slides now. I'm gonna bring out Tracy Williams, our Chief People and Culture Officer from New Relic, where she feels the same way, right? She truly cares about the people that's in the room. And Tracy, thank you so much for joining us.
Hey, hey, Atlanta. This has been this has been an incredible week, and I am so, so happy to be here. And you may wonder, though, like, you know, the HR lady on stage talking about what at the end of the developer conference. But first, let me just start with, I am so grateful for the team here to let me close this out, because I do think with all the technology and all the things that we've talked about this week, it's really important that we also focused on the humans in the room. So I'm going to try to make this, I won't say brief, yes brief, I will make it brief, I promise. But I am also going to try to make it worthwhile, and I hope that you all learned something to take back with you. Again, I'm Tracy Williams, and Jemiah, with all that searching, got the title right. It was the first time in a long time. But Chief People and Culture Officer at New Relic. Now, I said that, right? Like, when I first got asked to be on stage for today, you imagine Jemiah, he was like, hey, I heard you're gonna be at Render. Can you do the closing keynote? And I was like, me? What, like, what am I gonna talk about, right? And I thought he was joking, and he's like, no. And I'm like, but dude, you guys speak a whole different language than we do, right? You guys speak in metrics and logs and traces, and apparently something called for loop. Oh, thank God somebody laughed, because I don't even know what that is, right? So that's how different this language can be. I mean, I spend my time, and thank you for my team who's here, but I spend my time, we recruit, we hire a bunch of people, right? But we're really focused on how do we make our work environment the best place it can be. So we're talking about inclusion, belonging, culture, performance reviews, and all those things. But HR and tech? I don't know. And then I thought about it, right? And I was thinking actually back to the opening, and I really appreciate the panel and also Killer Mike. So let's give a huge shout out to Killer Mike and that panel. Because they talked about the thing that was actually really important, because there's a commonality here, right? And I will start with the commonality is all of you. It is keeping the humans in the room at all times. But also, this place, RenderATL, I think I came to the one Jemiah was talking about when he said that there were 300 people in the room. It was small, it was very intimate. I had a blast, but I looked around the room and I was like, wow, this is very cool, right? Tech conference full of brown people, it's awesome. And then I came this year, and at one point I stood in the room on the show floor, on the expo floor, and I just looked around and I got the biggest smile. And I actually texted Jemiah's boss, the chief marketing officer, and I said, my heart is so full right now, because there is a room full of incredibly talented engineers from all over, right? Atlanta is an amazing place. This is a unique environment, it's a unique event, and I'm so pleased that we could support it, because this is a place where you get code and culture in the same room, right? Where you have Killer Mike dropping a whole lot of knowledge and profanity all at the same time. You also have, you know, a panel that was so full of just information from different perspectives, right? Talking about what it means to code, talking about how this industry is changing, and talking about how we need to remain the producers of all the things. But this thing is all wrapped up in what I call Southern hospitality, right? This is so important. And if you think about Southern hospitality, what is Southern hospitality? In the words that I use, it really is belonging, right? Throwing the doors open, saying just come on in, come party with us, come hang with us, come learn with us. Doesn't matter who you are, you don't have to leave anything at the door, you just come as you are. And that's what Render has really been about. And so it's an incredible, incredible event. The rest of the industry, in fact, is trying to keep up with the things that some of y'all are doing because it is incredible. And this event is one of those. So thank you. Now I'm going to get into what I'm here to talk about. AI has changed the way you all work, right? And my team is here, the recruiting team. Yay. They know because even in our jobs, we talk about AI how often? Every day. That's right. That's right. We talk about it every day. It has changed your jobs. It has changed the way we work forever. It is here, right? It's not coming. Last year, we were like, oh, this thing is coming. It was already here then, but now it is really here. And the pace of work has moved incredibly. Like, I thought tech was fast before. In fact, it's one of the things that I love about it so much is that it changes all the time. There's so much innovation. I was like, what is that? Y'all got thunderstorms here. I'm trying to pay attention. But the pace is like astronomical. And I'll give you an example, right? I went to lunch with a friend of mine who's a serial entrepreneur. And he's got a crew of like 6 or 7 guys, and they build these companies, right? They come up with an idea, they build a company. A few years later, they sell it. Now, I went on LinkedIn to see, on average, how long it has taken them to go from concept to company sale. It's about 4.5, 5 years for each of the companies they have built and sold. A lot of people would be okay with that, right? Yes. So when I had lunch with him, they have a new idea, a new concept that they started. It's now been about 4 months. They used AI. They're all engineers, but they built their product. They have done all the testing. They've got customers. And when I had lunch with him, they had just signed their first 100K customer, six-figure customer, not even 100K, six-figure deal. That is 4 months for your first deal. That is pace, right? And thinking about with all that human experience behind that, it won't take them 4 or 5 years if they choose to sell the company again or move forward, because I already know the concept, and I think some big company is going to come buy them this time too. But it is just so fast. Now, it's exciting, right? That's super exciting. I know I'm excited about AI, and people look at me like I'm crazy when I talk about it. I am passionate about it and what it can do, what it's done for me personally. But it's also been very disorienting, right? So I hear all the good stuff, the pace, but I also hear a lot of people talk about sort of the other side of it, right? Which is a lot of uncertainty. Engineers who've been in this game for 15, 20 years who are like, man, I can't keep up. This thing, they're trying, I don't remember who said it yesterday, but it's like 10x developers. I can't tell you how many times I have heard other companies, ours included, say 10x developer. And I've always been like, what does that mean? Right? We've improved our ability to get products out the door, good products hopefully with good governance. But and again, whoever said it was like, but what does it mean the next time? Does it mean once we get that, we go another 10? At some point, the humans, it's almost impossible to keep up. And so when I think about this technical shift, I also think about the very human shift, right? And so how do people get enough support to stay in the room? Because that's what I worry about. How do people feel supported so that they can thrive in the jobs that they do? Because the humans need to stay in this. We cannot be run by these machines, right? And I think a lot of people are still thinking about, like, how much can we give over to AI? Like, let's just hand it all over, and we'll just take whatever answer it gives us. But if you think about it, like, that is not the way to control where we're going. That's AI directing us, and we have to always maintain control. It should see and reflect our vision. And I think it was Killer Mike when he was talking about music. Yeah, they use AI, and he may lay down some tracks using AI, and he gets some ideas. And then he takes it over to the musicians, because the musicians are the ones that are going to bring it to life, right? And so thinking about how to use AI always as a tool for you. It is a tool, and that's how we talk about it as a team all the time. I'm like, this thing is not, I don't want you replaced. I don't want you doing the work you don't want to do, right? I know there's a lot of stuff that I didn't want to do, and I was like, hey, how Can it just take my calendar and streamline it for me? Can it summarize these meeting notes for me? Can it do all these things? Can I build agents? And so that is what we've got to ensure we do. And that's what I really want to make sure that we continue to talk about. But saying all that, if you take one thing from me, I want you to take this thing, and that is to stay in the room. This is very uncertain times, right? Like, we are all uncomfortable. We've been uncomfortable before, right? Each big technological jump, we get really uncomfortable. We got a lot to learn. The hard part about AI is as soon as you feel like you've learned it, it's on to something else, right? A new release or 17 in the same day. It is changing so fast. But you may feel overwhelmed, right? You may feel like, I will not use profanity, but you may feel behind in those moments. And that's okay, right? Like I remember last year when we started talking about it as a team, people were like, I'm not technical. I don't know what to do. As soon as I try to learn something, now they're talking about we're going to be using Gemini Enterprise. What is that? What are you talking about? What is an agent? How is that different from a gem? What do you mean notebook LM? I don't even know where to find that link, right? And so you get all these things where people are you just gotta keep going, right? You will catch up, you will keep up in a way that really matters. And the way that matters is you staying in the room. You feeling uncomfortable is actually okay. That means you're in it. You're paying attention to what's going on around you, right? But you're driving the vision, and I think staying in the driver's seat, I don't know why I remember Killer Mike's comments so much in those. I keep looking at Jemiah because we've been laughing about this, but like, you know, he wouldn't ride in a Waymo. I'm like, dude, that's new technology. Come to San Francisco, where Waymos are like everywhere. But anyway, when it gets hard, it's so important not to step out. And it gets hard. It gets hard as you climb in an organization. It gets hard for different reasons. It gets hard because you don't know if you can keep up. It gets hard because the pace of change is so fast. But you just have to just stay committed to yourself, to staying in that room. And remember that the people who are shaping the rooms, they aren't always the ones who are the smartest. But you got to be in there to actually make an impact, right? So fight for your voices to be heard. It's so important. Find communities to help you thrive, like this one, also important. Those who stay in the rooms are the ones who have the most influence, right? I'm going to tell you another story because I've been pointing out my team here. But when we first started really talking about AI as a company at some point last year, you know, I totally could have been like, whoo, I don't understand anything that you people are talking about, right? Different language. And we're just going to chill over here. The engineers will figure it all out and tell us what to do. I thought about that. And then somebody hit me to like, you know, ChatGPT and showed me like ChatGPT was making a rap song. And I was like, oh, wait, that's kind of fun. There's a lot of fun things you could do with this too. And I actually just started experimenting myself. And then I started talking to my team, and I'm sure my team is tired of me talking about AI. I talk about it all the time. But the reason why I talk about it all the time is because I want people to feel comfortable, right? I also wanted people to know and hear my story about it. I have made mistakes. I have searched stupid stuff. I have tried to build an agent that was the worst agent in the world when it came, did not do anything I wanted it to do. But I didn't break anything, right? And I think that freedom to know that you can just go experiment with AI as long as you're not putting your code into production, because I do know that much, right? And that is definitely, there's no risk here of that. I don't even have access to our production code. But it's so important to just make sure that you continue to experiment and grow in these areas. The other thing about that is this has probably been some of the most rewarding time in my career, and I have been super uncomfortable, right? Because again, I am not the technical person, but even our CEO, and I get embarrassed every time he does it, but he has called our team out twice, and he has been like, he thinks it's funny. I think it's pretty cool. But he'll say like, oh, guess which team is out in front on AI, right? And there'd be a room full of it. The first time it was a room full of engineers, and they were looking around thinking about the teams in engineering that could relate to, and they were throwing out the teams, infrastructure and APM team and this, that. And I was in the room, and he goes, no, it's HR. And the whole room looked at me like, how? And I'm like, that's right, that's right, that's right. Now, then in all hands, he did the same thing, and I was like, all right, come on, dude. Like, I don't know if I should take that as an insult or, right? But the folks in my team have really leaned in, and I'm so proud of them, because we could have stayed in our lane and we could have stepped out. The important thing that I'm trying to get across is the fact that we stayed in it, and we got an opportunity to actually not just participate in transformation, we get to help lead it. And our voices mean that we'll have a word to say about what happens to the humans in the room, right? And so that's why you need to be, that's one reason why you need to be in the room. As you think about the importance of staying in the room and belonging, these things matter so much, right? But it's not just like the soft, fuzzy words of inclusion. And because sometimes I think that, you know, these things have sort of lost their way, right? Companies put up a poster, they deliver some training, you know, once or twice a year, they talk about it, but are you really living it? The belonging piece is so important, because if you don't, then you end up with a bunch of disconnected individuals who get burned out, who leave the companies, who don't give their all. You end up with the machines leading the way on something that the humans should be making the decisions about. Are you following the vision that you set forth? Are you the actual producers and owners of the work that's going out? So when I think about belonging, it is not really about, oh, it's this nice soft fuzzy thing. When people are in environments that they can thrive, performance increases, and every company wants that. We all know, like every company wants to drive revenue, every company wants to build great products for their customers, like we all do. We all want to be successful, and that requires high performance. And I will argue every single day that belonging, inclusion and belonging help drive that. But here's a trap, right? Every time we have some new technology come out, there's this thing where they're like, everybody gets access to the new tool, right? You got a new tool, equal access, level playing field, everything is good. But we also know that if you're not intentional, like that tool doesn't mean a thing, because the power still will pool, right? And so you just got to make sure, again, I'm going to keep saying it, is staying in those rooms, pushing for access for everybody, pushing for support systems that work. And when you think about real access, it's actually not the tool, right? It is relationships, the relationships that you build that give you information that's not written anywhere. It is the actual information that's not in the onboarding documents or the source documents for things, right? Like that information is so incredibly important, but so is the context, the why, not just how to do a thing, but doesn't everybody want to know why? Somebody asks you to do something, and you're like, all right, I'm just going to go do the thing. But you're like, no, I learn better if I know the why behind it, right? Give me the context. With that also comes confidence. And so having the confidence to stay in those moments, and that comes from a lot of support that you get. And the final one is support. And, you know, I was reading a thing, and it was talking about support and everybody needing support sort of in a, if you're falling down. I'm like, well, you don't always have to be falling down and need support. I think support is, you need it all the time, right? Because the important thing about support is it should also help lift you up. And if I think back personally, that is such an important currency, right? Like how many people have helped me in my career? People look at I've been at my company for 10 years, which is incredible, but it took a lot. I went really fast to get to this, 5 years to get to this role. But it took a lot of support, it took a lot of context, information, it took a lot of confidence. And I will say in this room, what I say to everybody is everybody should have a hype man. And I say man, but it could be a woman, it could be you to yourself. everybody needs a hype man. And when I say hype man, I mean somebody in those moments that when you're feeling a little bit of self-doubt, or even when you're not, you got somebody saying, that person's not smarter than you. And yes, that's important, right? You're gonna go in rooms where imposter syndrome might set in or whatever, but it doesn't matter. You deserve to be in all of these rooms. So when I want to talk about community then, and the importance of all these things, community has become a business imperative. And again, the rooms that will thrive are built on trust. We talked about that. Shared responsibility, all of you all looking out for each other. It's also important. But staying in the room is not a solo act. Not a solo act. It takes a lot of people, not just to help you get to a place, but to help you stay in a place. And I know that so many people that I am networked with talk about that fact all the time. Like, we don't stay in these roles just because of us. It is really important. But it's also important to remember that technology is going to continue to get more and more powerful. It will. It should, right? It should advance. It should continue. So should we. We still have a voice. We are the producers. This is a tool that we use. And so the hopeful thing about that is that as it gets more powerful, the actual human part of it also begins to grow. It's critical, right? We're not just going to sit at home. I mean, have you guys had a good time this week? Right. Me too. Right. Yes. From the show floor to the sessions to, yes, the party. We had a reception last night. Then there was a party. There was entertainment. There have been dinners. Like, that connection, forget the AI stuff that I've been learning. Being with the team, spending time with them, hearing their stories, meeting other people, learning what they're about, really trying to help understand and help people grow. Thinking about how I can network somebody to another person where they might be of support to each other. Like, that's what this is all about, and that's going to become even more important. So when somebody gives you all of those things, you have to promise. You have to promise yourselves, and you also have to promise those around you and those coming up behind you, and that is the thing that AI absolutely can't do. It cannot turn around and reach back and pull the next person. It can't share information. It can't build those relationships. It can't bring the humanness into the work that we do. That is this room, right? That is every room that we walk into, and it's so important. But that's also how belonging becomes real. That's how the work stays human. I don't have my shirt on. We use this thing, we talk about being superhuman. And when we talk about superhuman, it's because of the recognition for us, a lot of things, right? Making y'all superhuman, but for us as a team, it's really about how do we use this tool to make ourselves better, right? And having that be so important. So stay in the room. All right, I know I've been on my soapbox for a while, and I'm sure y'all are tired. I have some thank yous, and I'm gonna look down here because I don't want to forget, but I really want to say thank you to the RenderATL organizers. This has been an incredible event that only y'all have been able to put together. So thank you, Justin and team. I mean, don't you feel like that this isn't just like the normal tech conference you go to? This is really tech and community, right? Where you can come be yourself. You can, I can't talk like I want to talk right now on stage because I might get in trouble. But it is so important to continue to do that. I also want to thank the volunteers and the staff. There's been a ton of people running around making sure that these events all go off smoothly. From the moment I walked in, down with the security guys pointing me the right direction, and then up getting my badge. Lots of smiles, lots of happy faces. I never felt like I was bothering anyone when I had a question asked, so thank you to our volunteers. We know how hard that is, and frankly, that is the epitome of hospitality, right? The hospitality we were talking about. The other folks I want to thank, sponsors and partners, including New Relic, the company I work for. I am so proud that we chose to invest in this community. But like Jemiah said, like this, when Jemiah did the pitch, because we get to pitch the things that we want to do, it wasn't just about the community, right? That was a piece of it. We wanted to be here no matter what, but I walked out and I was like, is this Render or a New Relic event, right? You guys saw all our branding all over the place. That feels good. It does, but that's a lot of resources and that's a lot of commitment. But the reason why, just like Jemiah said, the reason why is because there's so much talent in these rooms, right? Logos, candidates for us to talk to, because there's brilliant engineers in here. I mean, we have met some great people, so thank you. And finally, thank you to the city of Atlanta. I am looking forward to dinner tonight, because the one thing about Atlanta is the diversity here is amazing. The music, Atlanta has soul that a lot of places don't have, but they also have food. We're flying a very long distance to eat, and I'm about to eat some more tonight. All right, but the other thing is, last thing, Jemiah, I promise, then you can come on back. Again, remember the important piece here is you are not the last one through these doors. You got to reach back and make sure, answer those questions, talk about what you do, because part of the reason why these rooms stay small is because we don't share enough about what we do. And you got to get to the point where talking about engineering and code and AI just becomes part of your natural language with other people. They may not understand today. I didn't understand. My team probably, some of them, I got some tech folks in my team too, but like some of them didn't understand either. They understand now. They understand because we talk about it all the time. And so for those of you who have kids or young people around, like just make sure you're bringing them along in these conversations. They'll learn super fast. Again, each one of us got here because of other people. We need to stay in these rooms to keep them human. We are going to change the world by what we bring into the rooms. And I will say, I'm going to call out Jemiah, because I remember when Jemiah first started at New Relic 7 years ago, and day 2, Jemiah was on the stage, and I was like, who is this guy? And he has been tearing things up at the company ever since, right? He has been in the room. Like he said, he made the pitch. He decided we were going to not just be here, but be here big. That is the place that more of us need to be. So hold the doors open for the next person. Don't step out. Stay in the room and lean in and get curious. Take the seat that nobody expected you to take. Change what's possible. And I'm going to just keep saying it and reach back. Just reach back. And reach back in mentorship, both internal and external to your companies. Reach back and talk to people and be kind when you do it, right? Because people don't know some of this stuff. You start talking to people and you give them the eye that like, oh my God, this person, they don't know, they don't, right? And then they won't ask any questions. You've just shut some person completely down. All right, stay in the room. And that's it for me. Jemiah. No falling up the stairs.
Nah, good. Thank you. All right, that was amazing. Everyone, Tracy Williams. Man. All right, I'm not gonna take too much time. I only have like 50 really quick slides around New Relic, why we're better than our competitors. I promise, no, I'm kidding. I'm just gonna wrap up quickly. And I wanna say, once again, thank you all for joining us. I feel honored to share space with you all, right? I hope that you've connected cell phone numbers, LinkedIn, hope that your cups are filled. Hope you had an amazing week at RenderATL, and I hope to see you all again next year. All right, so with that, I'm gonna go ahead and end this session. Thank you all so much for joining us. Thank you, Tracy. And
thank you. Thank you.
Actually, I'm not gonna end it.
Yeah, he's
we got one more person. I'm gonna bring out Brianna, right, our head of marketing from RenderATL.
Yay. Hi, everybody. Did you guys have a good RenderATL experience? Wasn't New Relic amazing? That is exactly right. Well, hello, I'm Brianna. I'm the head of marketing here at RenderATL. Who saw my push notification on your app? I see one hand, I see two hands, I see a couple hands. I mean, I've been doing a lot of them, but I hope you're thinking about the one that I said we were gonna try to give away some tickets to RenderATL. Oh, now y'all saw it, huh? Well, first, before I do that, I just want to personally thank you on behalf of the entire RenderATL team and for just being here, for showing up, for learning, for contributing to the future of technology as a whole. So give a round of applause to yourself. And also, just on behalf of the RenderATL team, we don't take what we get to do lightly. We don't take lightly what we get to do with New Relic and have brought runtime to RenderATL and so many amazing summits this year. But that being said, I think it's time to give out some tickets to RenderATL 2027. So, let's see. How should I do this? Okay, who wants to be considered to win? Oh, okay. So, look to the person to your left and to your right. If there's one person, you're gonna play rock, paper, scissors with that person. No, we're gonna do it. Okay, best version is rock, paper, scissors, shoot. You only got one time. Okay, on your mark, get set, go. Okay, raise your hand if you won. Okay, all the people who won that round, come to the front of the stage right here. Right in front, please. Okay, you're gonna, now stand in a straight line in front of you, side by side. Okay, or make two lines perhaps. Nope, make two lines so you should be in the front or behind somebody. We do engagement around here. Okay. Now, everyone should have someone in front of them, but except if you're in the front. Okay. Turn around. Person in the front. Play again. Okay. You can't play. Come, get over here. You can't play. Get it. Okay. Winners, keep standing. Winners, keep standing. Get closer. If you lost, please sit down. Okay. Now, to the person who is to your... Oh, are y'all still playing over there? Okay. Now you're going to play the next person next to you. Just pick one person. Just pick one person. If you don't have a person, go to the end of the line. If you lost, go sit down. If you lost, go sit down. Just one time. Just one time. Not yet. Okay. If you lost, go sit down. Okay, if you're still standing, make sure there's two lines. So someone should be in the back, someone should be in the front. They're still going at it. You're still playing. We need one other person over here. Oh, can you stand in front of him? Everybody has someone to play against? You're solo? You come stand right here. Okay, keep playing. One time. Okay. Okay. Who do we think is gonna win? Okay. Are y'all ready? You got two? You got two? One of you go stand to the side. Just don't ask questions. Go stand. Go stand. Okay. Now this is the final time. You're going to play best 2 out of 3. Okay. Go ahead. Don't ask questions, just stand. Okay. You're a winner? Did you? Go ahead. Don't cheat. Okay. You won? Don't move yet. Okay, one more time. Okay. Did you win? Did you win? Okay. He said you could come back one more time. Did y'all finish playing? Okay, go ahead. Okay. Rock, paper, scissors, shoot. Okay? Yeah. Oh my gosh. Okay, go ahead. No. Just rock, paper, scissors, shoot. So you go shoot, and that's like the one that you're choosing. Just don't pay attention to the joke. Pay attention about winning. Okay, ready? Rock, paper, scissors. Rock, paper, scissors, shoot. There we go. See, you were worried about winning. There you go. Okay, so you won. You guys all won? Come stand over here. Don't look at me, look at them. No, wave. And say, I'll see you at Render 2027. Okay, so you guys don't leave until I get your information. But like we said, well, we have a special guest. You guys might know him. He's pretty cool. His name's Justin. He's the founder and CEO of RenderATL.
What's up, everybody? Just want to say a thank you to everybody for helping make this happen this year. I'm going to answer the question because everybody said, hey, when's the conference? Are you going back to June? No, we'll be in August again next year. So yes, I know. We'll be in August for the foreseeable future. It'll be a week of August 18th for next year. So next year, August 18th. And then this coming Saturday, if you're going to be in Martha's Vineyard, we are crazy enough, and we'll be up there too this coming weekend. So catch us up there live. So thank you again. Shout out to my boy Jeremiah right there for helping us make this happen too.
Woo!
And then also, if you earned points this year, continue earning points because they carry over. So you do get points the entire year by coming to anything that we do. Workshops, activations, parties.
That does mean virtual events too.
Virtual points are soon on the way too. So there's gonna be a lot more opportunity to earn points and get cool things like how Jemiah offered some Meta glasses. You'll be able to earn those too and whatnot. So thank you again, everybody, for coming out, and we'll see you next August. And tell them about where they could find us at tonight.
Oh, yes. Tonight, after this, go put your stuff up in your room, keep your badge, meet us over in South Downtown at Founders Green for the official after party for RenderATL, featuring D4L and Dim Franchise Boys. Are y'all ready to lean with it and rock with it? All the things? Yeah, okay, no.
Complimentary.
Take your labby taffy. Exactly.
Complimentary.
And it's complimentary. It's free for you as a ticket holder. So we would love to see you there. And you might even be able to get some photos outside of the RenderATL office. So we will see you later on this evening, but we will definitely see you at RenderATL 2027. And until then, make sure your eyes are on RenderATL.com and on RenderATL on all platforms. And thank you guys again.
And get them points. Get them points.
And get those points.
Get those points.